Jordan, I'm knowing on social media as our godfather. I'm a full-time bug hunter, security researcher, and pen tester. On the BugCrowd platform for bug bounty, I'm on the top 50, and for the B1 Warrior, it's like the report for critical and high bugs. I'm in the top 5. More than 500 critical and high report I have been submitted. More than 1,500 report I submitted on other platforms such as Meta, Google, Microsoft, all of this stuff. I'm the winner of the Hacker Cup for 2022-2023, the Ethical Hacker of the Year for 2024 in B-Sides Ahmedabad. I'm a speaker in B-Sides in Ahmedabad, in Jordan. I have more than 10 zero-day CVEs I discovered in the last 4 years. My experience in cybersecurity and bug bounty, it's just about 5 years. And my original work, it's a cooker. I'm a chef. The agenda that we will have today, it's going to be very helpful for bypassing the 403, finding origin IPs, WAF evasion, zero-day recon technique, access for unique endpoints and the credentials, and vhost testing, and going to be a SourceGraph dorking, and some tips and tricks. After this talk today, what we can find from this talk, directly for report as a bug hunter or pen tester, we can find directly a PII information disclosure endpoint, such as GPG, PDF files, maybe be sensitive like in banks and something like that. As well, information disclosure endpoints such as voucher codes, gift shopping cards, emails, passwords, maybe clear text, maybe base64 encoded, authentication bypass via tokens, API keys, reset passwords link, and backup files such as ISO, XE, zip files, star, GS, DLL, and unauthorized access endpoints. That's directly. And in the same time, assistly for us in testing, for getting unique open ports, unique file extension such as PHP, ASPX, ASMX, all of this stuff, and login panel endpoints, registration panels, unique directories, and after that we can start fuzzing for that. Section that we will have today, VirusTotal and Shodan, and zero-day recon, and SourceGraph for dorking and tips. So now let's start with VirusTotal and Shodan. So Shodan, it's the search engine for internet, a linked device. Why it's amazing for me, it's find origin IPs, discover misconfiguration servers, maps internal panel, real-time IPs, find vhosts. It's, for me, it's the Google of IP. About VirusTotal, it's like I call it the bug bounty oil. I will explain later why. It's very helpful for me to find expose origin IPs, vhosts, and cover 403 bypasses for URLs, real-time IPs, endpoints. So let's start with Shodan. I gather like the top dorks that help for testing on Shodan. So let's start explaining each of dork. First one, it's using like when you're targeting a company name and you want to extract everything for that company, not a specific domain. You can find domains, you can find the IPs for that company, and as an example here we have like Facebook, INC. Now, ssl.cert.subject.cm, when we target a specific domain, like I want everything under domain.com, like orwa.domain.com, all of this stuff, it's fine, subdomains and IPs. And here we have an example. HTTP title, page title, it finds like all the IPs that include the same title in the browser. And here we have example, fiv icon hash. When we look for fiv icon hash, it's help us to get like all IPs for a specific software.
Good.
And the status when we dorking on Shodan, 200, 301, 302, for when we looking for a specific HTTP state response. And in the same time, we can look for a specific header. All of that I'm going to explain now in a picture for real scenarios. When you're looking for CIDR, a product name, we can use it as well. As example, we have IIS.
Thank you.
And dash, so I can use it to remove a specific results from search. Like if I write like Facebook INC and found like a lot of duplicate result, I want to remove it, I can use dash and like HTTP title, I remove this title. Let's show some examples. Here the example for looking for a specific domain. The dork, it was core.amazon.com, and here we have results. Here we have the IPs, ports, and the response we have here. Here when we look for the HTTP title, like I want to look for title page, here's the example for web transfer clients. We can see all the IPs and the company who use it. It's very helpful for zero-day testing or recon. Fiv icon hash, we can discover the fiv icon from pressing here and then using the door with adding the fiv icon hash.
Anna? Allah. No. I'm not sure. Which one is it?
Here, when we're looking for a specific header, it's also very helpful for zero-day testing.
This? No? Yeah. So, that's her.
Here, when we look for CIDR, it's a CIDR for PayPal, it's already public. So here an example for the result. Here when we look for the product, like a product IIS, it shows us all IPs running with IIS product. Here the door for targeting a full company name, and we can find like here there is some interesting domains. Not just facebook.com, there is more than that domain. And here an example, when we use dash dork to remove the duplicate, we can see here we have a lot of these results. Now we want to remove it from the dork. We remove it as you can see in the title, and now we have 36 IP. We can do more than that. We can keep filtering. As well, when we look for a specific IP, we can, like, visiting IP from, as an example, if we visit IP like this, inside, it shows us all the connected vhosts. So in a lot of cases, some of this vhosts is not accessible directly. But when you connect this host or subdomain with the IP, you can get the access for the app. And it's very good and helpful for testing. Here's some other example vhosts for IP. It's for AT&T, but you can see there is more than domains, not just one domain, and some other domains, subdomains, and more information. We have the ASN, we have more stuff for getting a good recon. And here are other example as well in Facebook for the IP, the domains and subdomains. And sometimes Shodan can help us with a specific vulnerabilities can be vulnerable on this IP based on the technologies and the versions running there. Now let's come for the VirusTotal. And as I said, I call it bug bounty oil for me. Now, most of people know about VirusTotal, like it's a popular online service that analyzes files or URLs for potential viruses or malware or other threats. So VirusTotal inspect the items with over than 70 antivirus scanners and URL domain blocking service. But That's a lot of people don't know. That's most or all of apps that you scan it on VirusTotal, it's directly get archived. So website endpoints, internal endpoints, IPs, files, credentials, sometimes tokens, everything get archived on VirusTotal. And that's how it's happening. It's via user submission or automated crawling or analyzing reports, direct scan. There is a lot of other stuff. So here, the usual method how people using like VirusTotal, they directly like search for IP or a domain or can upload a file such as exe file or DLL file or can directly search for hash. But as a hacker, look for the API report. And in this talk, I will share how to look for a specific domain or a specific subdomain or a specific IP and what we can get from that. So here, as a start, we have the domain. When we look for the domain, we have to use this. Now we have to create an account and generate an API key for us and replace it with this. And then we can use this endpoint with the specific domain or a specific subdomain. And here the example, API key, this subdomains.att.com. Now this is going to help us to find subdomains and IPs, including origin IPs, endpoints, including internal ones, and hashes file. The other link here we have, it's for looking for specific IP. So we found IP on Shodan or in any place. We want to look for that IP, what it have, subdomains or domains or vhosts, endpoints, all of this stuff. We can use it like this with the same API key. So it's helped to find subdomains, domains, and vhost and endpoint. And the last thing, it's looking for hash file. We can get some hash file from looking here, so we can search for that hash file. In that time, hash file, it shows us like the file name or endpoints. We can directly then test it on the app. So here are examples like looking for these subdomains. What we have in this, just the same URL. We have as a start these subdomains. And mostly it's going to be unique subdomains. You can get it by automation tools for subdomain. Next thing, we have like the hashes files. We can use it as I said. We have like, as you can see, some endpoints. Mostly we can get endpoints. It's not available on other web archive services, such as you can see, admin-login. So it's very helpful to bypass 403. If it's nothing shown in the app, you can use it to get more info, more endpoints about the app. Here's some other example for looking for IP. As you can see, we have like IP, we have a domain, this subdomain, this different subdomain, and this one, and we have like a very interesting endpoints such as this. Now, anyone working in bug bounty or pen test and doing fuzzing, it's very hard to find like a specific endpoint like this in word list. And here an example for looking for the hash file. It shows us like we can see here. It's a JavaScript file, and it shows us like the endpoint. We can use it and try to access directly to the app. So when we do that on VirusTotal, how can be fast to locate what we are looking for? We can directly, I added here like the top keywords to search in VirusTotal. First of all, searching for backup files. So zip files, 7z, gz, tar, dll, exe, msi, iso. And then we look for authentication bypass, keywords, token, equal, API key, equal, reset password, registration, EYG, it's a short for JWT token. We can search for equal, it means something encoded. We can search for it's helpful to find like directly a credentials leaked, like employee@company.com and the password. env config get, it's very helpful for other testing. And we can look in the same time for the files extension, such as ASP, ASPX, SMX for ASP, PHP, PHP3, HTML, XML, all of this stuff. Here, just an example for a report just I submitted in the last year just from working on VirusTotal. That's not all, just like a quick shortcut about the bugs that I discovered. And here in the same time, I create a tool. So now a lot of people here asking how I'm going to do it, like on subdomains or apps one by one. Here I created a tool. It's help you to gathering all endpoints for a list of subdomains. When you visit GitHub, you can see all the full installation. It's easy to use, and it's very helpful. Now, zero-day recon. So the zero-day, it's like a vulnerability in a software or hardware or a plugin or anything that's typically unknown for the vendor and for which no patch or other fix is available. It's called zero-day. So in this talk today, it's how to get zero-day. First of all, we have to find like a software. Now I'm going to talk about zero-day in softwares, all this stuff, not hardware or plugins. You have to find the software or installed app or a plugin or third party. You have to start recon about that software, installed app or third party. Then you have to find a bug in that software or third party. Then you have to test it in more than one app or two apps. And then you have a zero-day. Here I will show you example how to find third parties or installed apps, softwares via Dorking, and in the same time via FivICon recon. Here we have example for third party or softwares, like we have a Okta third party, ServiceNow, Frog.io, OneLogin, Looker. Most of you know these services or third parties. And here's example how we can find it. It's like the company.thirdparty.com, or in some cases it's going to be like a subdomains, like as you can see here, github.att.com. So as we can start with Dorking on URL scan. URL scan, it's amazing as well to gathering endpoints, but it's more than amazing to gathering softwares or third parties. Here I'm explaining. So the star we have here, it's mean I want everything after dot. And dash, it's very similar to Shodan. It's to remove results I don't want to see. So here as example, like I try to look for bmw.star. It's mean everything after that. And I want to remove like bmw.com, I want to remove this one, I want to remove this domain, I want to remove this domain, and I want to remove this. And now I have this results. When we look here, we have here like an interesting domain, not this one. We have here like a this third party. Here we have other third party. Here we have other third party. Most of people not know about this third party. It's maybe not tested at all. It's the same thing, but now the star after dash, not after dot. Because after dash we can get like bmw dash blah 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 dot thirdparty.com or something like that, as you can see here for the examples. And here a dorking method in the same time. This dorking, it's for Hassan. He's talked before in BH Day. He's talked after me today. It's how to locate more by adding these dorks. It's get you, as you can see here, when I look for ATT, I got like some att.jobs. Or we have here att.gop.po. All of these results, it's like something unique and mostly not tested at all. Now, the most favorite thing for me when I look for 0 days or doing recon, normal recon or everything, I start looking for Fiv icon. Now, what's the Fiv icon? As you can see here, on the most modern browser, whenever you open the web page, a little small icon appears in the top on the left corner right before the title. Here, as you can see the example. Now, that's what I'm looking for. I'm trying like to get the hash for this icon and then looking for all the apps that having the same hash. Here like a quick tip to find the Fiv icon hash for like when we looking for a company. So we visiting, this is a FUFA engine, it's very similar to Shodan. So we visiting like, we try like, we add the domain, just now the first dork, it was just this one, att.com. Then it show us all of these results. Now if we look here, this is ATT logo. This is the ATT logo. This is, and this one. Now when we press on each of them, it show us the Fiv icon hash for each of them. This one, and this one, and this one. Now what we do after that, we copy this hash, then we go to Shodan, and I already added the dork for Fiv icon hash, and we start getting more apps, IIPs, and servers. Now, how to get Fiv icon before, now how to locate the Fiv icon before getting the Fiv icon hash. Most like, as you can see here, like you can, now most of apps, when you visit like the main page and view the source, is directly you can search for .ico. It's mostly be fivicon.ico. Maybe something else, but mostly like that. As we can see here, there is an acolyte template for that. There is like a quick checking via HTTPX. Now, here, like explaining the command BMW, it's a list of subdomains. I'm going to run it on HTTPX to see what is live from these subdomains. And then match that with this endpoint and see the results. Now, when I start visiting this one or this one or this one, it's show like a picture, a small, very small picture. What I'm going to do after that, I'm going to copy that link of the small picture icon and going for this domain, Fiv icon hash. Then I add the endpoint here. It's give me these results. There's a other way in the same time. I can like download the picture and then upload it here. And the result will come after that. It's going to be the Fiv icon hash and the MD5. Now, how can we use the Fiv icon hash and the MD5? We can use it on Shodan search. We can use it on VirusTotal. We can use it on, there's a lot of methods. As an example, here on census, we use the MD5, not the Fiv icon hash. This one. And the dork, this one. And here we add the hash. And here's, as you can see, an example, and here's the results. That matching with the same Fiv icon. Here already I explain it. It's on Shodan for Fiv icon hash. As you can see, we added here a hash, and it's give us all the servers, IPs, domains that using this software. And as you can see here, we have the domains. And in the same time, we can use it on Zoom AI. It's not familiar for a lot of people, but it's get very good results. And the dork, it's icon hash, and we can drop the hash here. And here, example, this is a hash for GitLab service. And as you can see, here's the results. So now, we know what's the software or the third party, what we can do after testing. So if the app is running with a strong WAF and no origin IP, we can start looking for the same software without a WAF or install it locally and test it. Like we're working like on PhD, there is strong WAF, then I take the Fiv icon, I match it with a similar apps, but without a WAF. And then I start testing, or I can download, if it's software, I can download it locally and test it. What else? We can collect all software endpoints on other domains, because if this domain use this fiv icon and this domain use fiv icon, it means same software, it means same endpoints. So if I didn't found endpoints for this software, I can look for other domains using the same software and test it on my target. We can, in the same time, look for software repo on GitHub or GitLab. Here's an example, like for 0 day, I found it me and Abdullah HackerX. He have a talk in 24 here. It's going to be about authentication bypass, and I'm sure it's going to be amazing talk. So what we did, we was testing a bug bounty program. In that time, we found a very it's unknown fiv icon hash. So we take that fiv icon and we extract the fiv icon hash. Then we looking for the software on the VirusTotal, on everything, and we start Googling about the software itself, and we found that we can download the software. We downloaded the full source of software, we installed it locally. It was ASP software. So directly after install it, we directly looked for the web config file. In the web config file, we found a machine key. So directly we took the machine key and we start looking for a view state deserialization using the machine key. And yes, we found the machine key, and then we tested that machine key on all the clients, and the results was amazing 0 day and RC remote code execution. And here an example for 2 clients of reports and the bounties in the same time. It was very easy, just by download the software, install it locally. Then match the machine key with all the clients, other clients. Now, SourceGraph, it's a code and file search. So what is a SourceGraph? It's like, for me, now it's like the top code search after GitHub, because now most of bug hunters or researchers was using GitHub for looking for leaks or exposed endpoints. But we can say about 1 year ago, GitHub made some updates. Now we can say the dorking, it's not easy like usual. So with looking more and for resources, I found these resources, and it was amazing for looking for leaked credentials, sensitive data, everything. And here, like, when I try to compare the SourceGraph with GitHub or other websites, this is the result that I got. I'm going to explain it now. And here we have the keywords and the queries, why it's used, and example for that. So here we have a lang. It's mean when we're looking for a specific language to filter the codes for languages. Like if I want to look for PHP, PYD, domains.com, then I want just the Python codes, language Python. A pretend type for regexp, as you can see here. Example. We can look directly for the repo name. And here an example for repo, GitHub, PayPal. We can look directly for the file. It limits searches for a specific file. Like I want to look for AT&T.com and then including the passwords, and just search in files. It have .env. I can look as well for the content. It's a little bit helpful, but the most helpful for me, and or not. I'm going to explain it why. Now, and it's the search for the same keywords in the code. Here an example. I want to look for att.com and password and admin. So I want to bring for me a result containing a password and containing an admin in the same time. Or, or here to search for more than 1 keywords in the codes. Like I want att.com and If you can find for me password or passwd or pwd, it will bring me a results for this or this or this in the same dork. Not it's like the dash we use it in Shodan. It's to remove the duplicates, the unknown that's annoying results. And here example, I want to look for ATT password, not help.att, not test. So it's mean I want to remove anything containing help.att from results, and I want to remove anything containing test from the results. Now the top keywords to looking for sensitive data. Password, passwd, pwd, pw, access key for AWS credentials, secret key, the same thing. AKIA, ASIA, it's the starting of AWS access key. API equal API key, client secret, or a client underscore secret, authorization, pair EYG, secret token, secret underscore key, send underscore key. And here I added just the example how like I'm mixing the not and or in the dorking. So now here like I'm looking for a ServiceNow third parties. And in the same time, I want to look with the ServiceNow for passwd or password or pwd. I want this or this on this, including the ServiceNow. And I want to remove in the same time from the result example. I want to remove test, I want to remove server.serviceNow, and I want to look just for language Python. I can remove it for all languages, I can look for Bash for other language. Okay. Now some tips and tricks. There's another example when I explain it, Shodan, when you visit the IP, it show you like the host or vhost. Now, in some cases, like you can't see the hosts or vhosts on Shodan. But in Firefox browser, you can, like when you're visiting the IP, it's very, very normal. And all people saw that, but no one think to take it. It show you like a lot of subdomains. Directly copy all of these subdomains and match them with the IP. In a lot of cases, you can get access for apps, not the same app. Maybe this app, it's not this app, it's not this app. And in most cases, this app can't be accessible without the IP. How to do that? When we visit the IP normally, and we can say for the last 6 months, most of bugs we found, it was like that. Now we look for IPs having this response, bad request, as an example. So as you can see, we have the IP and here, and the response is bad request. Then we generate all the subdomains for the company, and we start test that here in the host header, but on the same IP. Here we have an example like we know the response here is bad request, and most of people when saw like this IP, they will ignore it. So we grab the company, all subdomains, and here's the number of subdomains and domains. As you can see, it's 34,000. So what we do, we keep the IP here just like this. Then we like hashtag the host header, and we remove from here, like we don't want to update the host header to match the target. We want to test here on the same IP the different subdomains. And here we remove the encode so we can get a clear results. And here, as you can see, the example. Now, the normal response is 400, but from 34,000 subdomains, we got one have a state code 200, two have a state code 40101, and three have a 403. Now, these apps mostly not accessible without this IP. So when you visit this IP, it show 400. When you visit this subdomains, it show 100, 500, but mixing this with this, we got a live hit. We can use like for a quick automation command, it's using FFUF with like this command, fuzzing 1 and fuzzing 2, and then we can add the word list, the IPs. That's when we go on like a list of IPs with a huge list of subdomains. We want to run all of that together. We can mix that with this command. Word list for IP, word list for domains and subdomains. Then we mix that with this command, fuzz1 and fuzz2, and we match it with all response. We remove 400 response, we match it with 200 response, and we print the output as a HTML. Now, for like how in some cases this kind of vhost testing, now if we found like an IP and domain, but now this not dead domain, it's accessible domain, but it have a WAF. But the IP, it's not have a WAF. IP back with a 500 results, the domain back with a 200 result, but with a WAF. Here an example. Now, the normal domain, when I tested the login and I was testing a SQL injection, after 2 or 3 commands, I got too many requests. Then I went to VirusTotal. I looked for this domain. I found IP. This IP is accessible, but IP, it's not show anything. Then next step, I mix the IP with the same app. And I keep running the payloads here without any WAF. As you can see, this is a normal response. It means there is no WAF here. Now there's another method for Akami WAF evasion. Now how? Via loading a huge content. As you can see here, if we like try to add like a script, JavaScript for access us, directly the Akami WAF is blocked us. So you don't have permission to access, it's a Akami block. What we did here, like in Akami, it's if you load a huge content in the request, it's look for the first huge content and then forget what after that. But it's just working with post request or put request, not get request. You can load a very huge content like that, and then after that, adding the right parameter and the right like payload you want to exploit, and then send it, and as you can see, it's directly bypass Akami. It's the same request here and here. What I add, I added a huge content, and it's ORWA equal XXX, and the same, till I bypass it. This is a good and helpful one. It's like a word list generator. When you work on a specific app or specific company, we can use this BARB extension. It's called BARB word list generator. And in the same time, if we extract the endpoints from VirusTotal, from Web Archive, web apps, now we want to create a word list from that endpoint. We can use for TomTom and FURL. It helps us to create a word list for a specific company to get unique endpoints. All the time with the header, and it's helpful with me. All the time, we try to add to the request X-forward for header and referrer header. And in the same time, we try to inject that with SQL payloads and blind access as payloads. Now, when we do fuzzing using FFUF, now most of people, they're doing this step, running a word list and the target and fuzzing. Now, to get more amazing results, you can directly start mixing the word list and starting with the app name. So like as you can see, we have a subdomain called ORWA, and the domain is app.com. First thing, like we can try to fuzz. We can add ORWA, then fuzz. Maybe we can get ORWA administration, ORWA login. We can like copy now the domain name and fuzz that in the same time. So we can get like app login, app administration, or something like that. If it's have a different name, we can use like a underscore, then fuzzing. It's help us to find a hidden files. We can add dot fuzz, and there is like a lot of some methods. Now, if the target is running with a PHP, directly we should add for this command this following extension, PHP, and this very helpful for bypass some of files, P capital, H small, P capital, PHP. Or PHP 3 or zip file looking for backup file, TXT file, 7Z, all of this stuff. If the target running with Java, there is a lot of extension, but most of them GSP, GSF, CGI, XML, XHTML, and zip for backup file, and 7Z. If the target running with the ASB, we should add this extension ASB, ASBX, ASMX, SHX, and looking for backup files such as DLL, EXE, zip file, and 7Z and XML. And here, like, if someone here starting like fresh in bug bounty or pen testing, it's this mind map. It's amazing. It's keeping updated all the time, so you can use it like a checklist. You come back for that. It's very helpful for us as well. And here I am done. Hope you enjoy it with this talk. Hope you like it. And if someone here have a question, yes. Thank you.
The interview.
Okay, again, thank you.
So, my name is Shodan. I'm a bug bounty hunter and security researcher. I'm also the CEO of WebImmunify, which is a pen testing company. We also provide security services to companies. I have also won some bug bounty events, bug bounty live hacking events. I have also won the recent bug bounty live hacking event. That was the live hacking event that was done by Positive Hacks, which was called Hacks. And we hacked Telegram, we hacked Wildberries, we also hacked tbank.ru, which is a Russian bank. And so I have also won this live hacking event, the three prizes. And I have done some other researches. So far I have more than 1,500 vulnerabilities found overall. And I also have found vulnerabilities on more than 1,000 companies approximately. So between these companies, we speak about lots of different companies such as Facebook, Google, Microsoft, American companies, Russian companies, European companies, and all kinds of companies. So today we are going to see what are some significant bugs that I have found recently on big companies. The main problem that we have nowadays is that some hackers find some really cool bugs, but the problem is that they don't think too much out of the box to find very harmful bugs, because they just stick to what they learned, such as you have SQL injections, you have to stick to SQL injections, or you know, for example, some kind of specific CVE, so they are going to stick to that specific CVE. But the hacker has to think out of the box, and he should try to find some new techniques which he can use to find more vulnerabilities along the way. So I hope you're ready for the talk, and let's go. the first vulnerability we are going to explore is a vulnerability I have found on a login endpoint where I could bypass the login endpoint by using some special So an endpoint being behind login redirected to SSO unless you added authorization bearer null. So suddenly the server assumed that I was authorized and skipped the login flow entirely. This was a logic flow in auth validation where a null token passed checks. So why did this actually happen and what I initially tried? What I initially tried is accessing a protected admin endpoint, and obviously the server would say, no, you can't access that specific endpoint because you don't have any valid login authorization token. And so I always got redirected to the login page. So obviously from there you can try a few different login bypasses, which might be some SQL injection login bypasses or some other kind of bypasses. But what I have tried is testing with authorization bearer null, like you can see here in the header, and the application responded with a 200 OK instead of redirecting. So this was a straightaway bug that granted me access to a very specific endpoint which was protected by authentication, and that application failed to protect its users by not validating what is actually being sent in the JWT. So in this case, there was two specific things that were happening. First of all, if you send a valid JWT token in the header, the application will let you in. But if you send something that is not valid, it will not let you in. However, once I sent the bearer token null, just like that, it actually granted me access to the application and let me in. So you can, of course, use Burp Suite to send a payload that is very straight, and we also gained full access to the application. Then what we can do is using setup match and replace rule inside Burp Suite to actually keep sending the bearer token null to the server as soon as we browse it, so it gives us access to all the pages. So behind the token trick, the application uses bearer token to validate access, but fails to verify whether the token is valid or even non-null. So why the null token worked? Because some middleware treats the presence of an authorization header as a green flag without checking its value. In this case, a null token wasn't parsed or rejected, it just passed through. So all the application did is checking if a bearer token was sent, then it checked if the bearer token was not valid, then it didn't grant authorization. But as we sent a null token, it passed the check for the application and it granted us access to the specific endpoint. So this issue often lives in custom built-in authorization filters because it's way uncommon to find this type of bugs on way known softwares. But sometimes developers make mistakes because we all make mistakes, and it just granted us access. So another vulnerability we are going to see today is unsigned JWTs. Don't mind if I access your application with some unsigned JWTs. What is this vulnerability about? This vulnerability is about a login endpoint. The server accepted JWTs inside the headers again. But it never validated the signatures. So what does it mean? Is that the server is taking in the JWT token, it's decoding it, and it's granting you access or not, but without actually having a SIG and having a valid signature generation, checking and a session cookie. So what can happen in these cases? What can happen in these cases is if you take the actual bearer token and you decode it using JWT.io or other services to decode the actual JWT tokens, then you can see how it is structured. And once you know how it's structured, then you can forge your own tokens. And if you forge your own token with a valid date and valid structure, then the application would likely give you access to these protected pages. So we can see here that when I did, I posted to some specific endpoint with a token that is not very real. There is no signature inside this token. We can see here at the end. Then it just gives us access with a token value here that could be accessed and used later on other endpoints. Yeah, so what I initially tried, I noticed the application used a token parameter in the login request. I tested with expired and tampered JWTs, which were still accepted. Eventually, I sent a JWT with no signature, and it let me log in. So this is also a common vulnerability that we can see on some applications when the authentication flow is not well written and not well secured. So how the payload was built, we created the JWT using the header and the payload, and this can just be done with JWT.io or any other tools like CyberChef or any other JWT parser that you know of. And then send the token into the login endpoint, and the application returned a session cookie giving full access to its protected area. So why did it happen, and how does this work? The JWT are meant to be self-contained and tamper-proof thanks to the cryptographic signature. But when the server keeps verifying that signature, it accepts any payload, no matter how fake it is or how fake it looks. So the most important thing when testing JWT-related authentication flow is first trying to log in without a valid signature. And the second thing is also trying to send a null bearer token, which might sometimes give you access to the application, as we have seen in the previous bug. So it's a quite but deadly misstep. Just base 64, a fake user, skip the signature, and you're logging in like it's totally legit. Another authentication bypass, so I think you have seen the pattern here. We are looking into some different authentication bypasses vulnerability cases. Another authentication bypass that I have found recently is by sending a null password inside the login form. Yes, you've heard it right. And why this happened and how it happened is that we had this specific post request, which was a post request for a login endpoint. And if you send, for example, admin, it will not give you access because it's not valid credentials. However, when we send an empty password, then suddenly the application gives us access to the authenticated area, even though we don't have a valid account. So that's again another deadly mistake made by the developers, that they gave us access to the protected area by just sending in an empty password with a valid username. So we verified this in Burp Suite by stripping the password field entirely. The server responded with a full authenticated page, proving the password check simply didn't trigger at all. And so we have tried dummy password, SQL injection, trying to bypass the authentication flow and other things. Nothing worked, but once we send the login request again in Burp and remove the password value, we got a large 200 OK, which actually proved that we got access to the application without actually having any specific account that was needed to log in. And the payload was just used again in Burp Suite, and we can, of course, use again match and replace rule to automate that later on. Skipping password logic, login flow often check if credentials exist, but they always check if the fields are non-empty. This happens when devs assume the front-end will enforce front validation. But even here, front-end validation is not always, is never complete, because the actual patch has to be done on the back-end and the front-end to avoid any substantial issues. So it's a quite but deadly misstep. Just, sorry. If the token structure looks okay, the backend trusts the payload. Another vulnerability we are going to cover is local files spilling the secret. We abuse the local file disclosure to access sensitive files like etc password, bash history, and file descriptor under proc self-fd. This led to extracting domain and MS Graph API credential, Microsoft API credential. So we decoded a leaked graph token and found it had broad permission. So what happened is that we had a specific endpoint with a specific content, and once we sent a specific payload inside this parameter, this gives us access to the password file on the host, and then later on by doing further checks and checking proxy self-fd payload, then we got access to further secrets which granted us access to the Microsoft API graph token. So we used an SQL-based login access to internet endpoint. We began fuzzing the pass to test for file disclosure, and reading proc self-fd and SH history revealed the graph token. So how the payload was built, we could use again Burp Suite or use curl or anything that can be used to send HTTP requests to the specific endpoint. Why and how this works? When applications read files based on user input, they are vulnerable if pass validation isn't alright. Local file inclusion lets you reference system files like etc password or generic passes like proc self-fd. So for the developers, we should always make sure to not let user enter some weird payload into the application, parsing it, and actually allowing file read access to something that is very sensitive on the application and inside the system. We go to the next vulnerability, which is a remote command execution, which we have found while doing some testing on an endpoint that looked like it was using curl to actually do some requests based on the user input. So what happens here is that we had this specific endpoint, which you can see here, and once we found what the pattern looked like, then we could build a payload. So the initial request just stops here at the 20, and all of this is what we have added to generate a payload from this to this. So in a service that used curl internally, we passed extra flags via input, adding options like -x and k led the backend to fetch remote files, write output to disk, and drop a GSP shell into a web exposed directory. So what we have done here is that when we saw the initial feature, we started trying to send it some specific flags to see how it responds, and it dropped an error. And once it dropped an error, we could identify that it was using actually curl to make the request internally. So what happens here is that we were able to break out of the curl context that was happening in the backend and specifying our own payload that will eventually lead to remote command execution. So what we can see here inside this specific payload is that we are breaking here with a code, and then we are giving it -x, which is a curl flag to give post request, to give proxy, sorry, and we are setting it to my host, which contains the shell, and then we are giving the output to poc.txt, which would save actually the payload we gave it here. And so what happened is that it eventually gave us remote command execution access.
instances. So this worked because the input was never sanitized and curl happily obeyed every extra instruction we snuck in. So we always have to try random things. Sometimes when you're testing an application, you think that some things might not work because it is not designed to work. But sometimes you try some random weird things and you end up realizing that some things actually gives you some debug output that can further lead you to understanding how the feature was developed and how you can break it and do whatever you wish to do. Again, another remote command execution. We added a dash here, and what we can see here is the same application which is vulnerable to another remote command execution. This happened because we just discovered that at passing special curl flags like std error, redirected the error logs to any file on disk. Using this, we wrote a malicious DSP file into the Tomcat web root, and we dropped a shell on that application. So we can see here the malicious payload which we used to send to the application, and this was sent inside the std error flag, which was eventually passed to the curl on the backend, and which actually executed the code on the backend for us and saved our shell code to the server which actually was vulnerable. And so we've then eventually visited the GSP endpoint with the CMG ID payload parameter, as this is what we have included inside our payload when we actually exploited the vulnerability. And then any setup that builds a system commands from user input without strict sanitation is a gold mine for exploitation. So once again, you have to always try some weird thing and see how the application actually interprets what we are sending it, so that we can see how it works. Another vulnerability here is proxy escaping, which was a server-side request forgery vulnerability that we found on some other big company. So what happened is that a reverse proxy path leaked access to internal apps by modifying the path like app main admin, who escaped the intended route and hit production admin, not internal, directly. This allowed us to browse and interact with internal-only admin panels. The server-side request forgery vector worked because the proxy followed internal redirects blindly. A small misconfig, big result. So what happened here is that host/API/main/anything is pointing to internal application. And then when we send it another thing instead of anything, we send it admin, it's hitting internal-admin internally. So once we hit the /admin, which is on an internal host, it gives us access directly because it is blindly following the redirect payload inside internal parsing. And so the payload was built again by sending in the vulnerable payload using burp suite, and then DNS lookups revealed internal aliases being resolved server side and being following the redirect blindly. So in this case, we used a predictable escape path to reach internal domains through the public interface. It worked because the proxy trusted the rewritten internal host header. It became a web-based internal recon tool that is simple SSRF into full on-asset discovery. Another bypass we are going to see is again a payload bypass that uses extension-based. I have spoken about this multiple times, but I think that we should again bring it on because not very much of the people know how it works. So what happens here is that a website is protected, has protected its endpoint behind Microsoft login, but by appending this specific payload, so !.gpg to links, we bypass authentication completely. The application treated it like a static file and served it. This happens lots of the time when some applications has a reverse proxy that lets you access some specific endpoints based on the content that you are asking it to give it to you. But sometimes if you are able to trick the server to think that you are requesting a static file, then it will eventually give you access to what you are asking it to give you access to. So in this specific case, the past configuration was exploited using Burbs rules to add GPG or GPG to every request. So suddenly, we had free reign over the application without plugging in. So you can see here that we are inside a specific directory, and we are giving it the GPG payload to bypass the authentication. And the server responded with 200 OK, while it usually responded with 403, which means that we don't have access to this specific payload without any authentication check. And so we always try some different payload, but in this specific case, accessing the main endpoint, we got a redirect 302 to on an SSO. And then once we send it the specific payload, we got a 200 OK, which actually gave us access to all the endpoints. Then once we find this kind of vulnerabilities, we can use Burp Suite match and replace rule to actually automatically replace the suffix of the endpoints and actually always add the specific bypass payload. So as we browse, it gives us access automatically without restricting any authentication. And so this trick turned every GET request into an unauthenticated read, effectively crawling the application as an internal user. The next bug we are seeing is again a SSRF with open redirect. So what happened here is that we chained an open redirect with server-side request forgery to fetch internal resources via public API. By pointing a redirect parameter to internal admin domains, we got full responses back through the proxy. This revealed everything from internal HTML pages to cloud metadata, and since it followed redirects and served responses transparently, we didn't even need to exfiltrate, it came straight to us. So we can see here that we got a specific API request, and then we got here a parameter called link, and then the response of whatever we send it here inside the link. And so we can see that what happened here is that API public auth, and then we got the redirect here. And by pointing that to an internal domain, it actually followed the redirect and actually gave us access to that specific internal domain's content. And then we combined the SSRF with the public proxy into internal host. So this initially was not giving us any access to internal domains, but once we found the redirect payload, we actually was able to build a payload that actually gave us access to the internal domains. And so this setup became a data leak machine, letting us explore the internal attack surface completely from the outside. The last vulnerability we are seeing is the full config control over a major dev forum. I think everyone knows the Apple developer forums here. We have found a vulnerability that could let us access actually pretty much everything on that specific domain. One single unauthenticated put request to a config endpoint allowed us to override any application-wide variable, CDN links, keyword filter, internal passes, all modifiable. So while doing bug bounty on Apple domains, I have found developers.apple.com, which is a developer forums, and by looking into some API requests, I found some API requests which looked like API/config, let's call it like this. And this specific config file returned some vars, variables, and I noticed that by giving it a put request instead of a get request, I could modify this configuration. So what happens here is that it let me modify the configuration of the Apple Apple developer forums, and I could point most of the links to my own domain. And so this actually gave us access to everything, because we then can see here communities.apple.com, and you can see here the link that I could change on the main index page. So if you can see here, youtube.com/embed callback, and with the XSS payload that I put in there, so everyone who was visiting developers.apple.com, the developer forums, or Apple Communities Forum, was actually going to be infected by my payload. And so I think that every day there are more than 50,000 people who visit Apple developer forums, but Apple swiftly responded to the vulnerability report and fixed the vulnerability very quickly. And I made sure every time, as I was trying and as I found the vulnerability on the system, I made sure to revert back to not cause any damage to Apple or to any users and harms to users. So what is funny here too is that I was getting callbacks from all Apple users who were visiting the Apple developer forums, because I had changed the links on the page to point to my own domain, and from there everyone who was visiting Apple developer forums was actually getting served content from my domain here, which actually made everyone send me some data, cookies, what he's sending requests to, and also IP addresses and lots of other secrets, because also Apple admins were also infected by this, because they were also using this specific software on some other hidden admin panels. And I got all the callbacks here on my own server. As you can see here, public/assets/favicon. This was sent by an iPhone of a user who was actually visiting my the Apple developer forums. What was also great is that it was caching the request. So once you visit one time, you have to wait a long time before it actually changes back to the original Apple content. So Apple swiftly fixed the vulnerability and secured what we have found on the system. So we browsed through the mobile application authentication flow. We found that signing with Apple, and then after that we have found that specific config endpoint, which let us have access to that specific config endpoint, which we modified and infected more than 20,000 people following the website. And this misconfiguration let attackers rewrite key parameters like CDN links and admin controls, effectively hijacking the application behavior and enabling widespread exploitation. So basically it's like you own the domain, but you lose control of the domain because someone could modify some configuration on your domain, and then what you want to serve as a content is not what you are serving anymore, because someone is controlling what is happening in the middle. And the takeaway is always to spot the logic gaps. Don't just scan, think like the developers. Chain the pain, small bugs combined can lead to great bugs. And also you have to stay creative, stay ethical, bring assumptions, not the law, and always poke at the config application, misconfig, and others. So this is the end of the talk, and I'm happy to answer any questions anyone might have. Thank you so much. Yeah. Do we have a mic for questions?
Hi there.
Hey there.
Can you hear me?
Yes.
Hi, thank you for coming. I'm casual, but kind of top 55 on the Russian platform.
Yes.
Standoff. So I'm very happy about your
Sorry, I will move
presentation.
closer to see you also. Yeah.
I'm happy about your presentation, and I have a few questions.
Yeah.
About null authentication token bearer. Was it in only specific domain implementation or more wide?
About which vulnerability exactly? About which vulnerability are we speaking?
First, about bearer token authentication.
Oh yeah, the null? Yeah. Yeah, what's the question?
Was it about a specific implementation platform or more like...
So yeah, the program was on Buckroad, on Buckroad platform. So it's a public program.
If it were more wider problem, would you mind to actually take a time and make a boop extension to automatically send another request with your legitimate request with a null token to actually find if it's vulnerable?
Yes, of course we can always try a few things, but what happened here is that application was not parsing effectively what was being supplied to it, so it let us pass with a null bearer token. But if there is anything specific which we'll have to go in details, I will be happy to chat with you later on and take these specific things and tackle down what doubts you have.
Okay, and I have one small more. You were talking about all your great vulnerabilities, yes. And how much in percentage of those fun and just out of nowhere bypasses happens in wildlife?
Yeah, so very few people actually find these creative bugs because they stick to what they have learned, such as SQL injections, that's it, XSS, that's it. But very few people actually go for the creative part and thinking out the box. So I would always suggest to take this path and trying to find some things that are not common, because this is actually the beauty in hacking, because hacking is an art at the end of the day.
I meant, thank you for answer, but I meant how in percentage of those bypasses actually you had in overall?
So how much does it happen? So this is a very low percentage. I'm not going to say anything. Maybe we can say 5% of the times. But I have some specific checks I always do for this specific authentication bypasses. So I have maybe 15 different authentication bypass checks that I do on all kind of login endpoints. And if I have some luck, I might get in sometimes with one of that.
Thank you.
Thank you. Is there any other questions before we move in? I think that's it. Thank you so much, Russia, and I'm happy to be here. And question? Oh, that's it. Thank you so much. Goodbye.
Уважаемые гости, покидая этот шатер, верните приемники синхронного перевода на стойку выдачи.
Я выведу просто.
Тест.
Всем добрый день, очень рады видеть вас на нашем докладе. Атакуем криптокошельки, свежий взгляд на
Hi everyone, I am glad
безопасность
to see
браузерных
you
экстеншенов.
at our presentation, which is devoted to attacking
Суть в том, что
crypto purses. Why are presentations important?
сейчас через браузерные криптоэкстеншены проходят
basically,
буквально уже
currently,
не миллионы, а можно сказать миллиарды долларов, потому что это
billions,
основной
rather millions
способ
of
коммуникации
dollars
с блокчейном,
pass
способ
through those,
подписи транзакций, пересылания денег и всего
crypto
остального.
purses and wallets
Но в индустрии
being
нет
one
как
of the
такового
key
фундаментального
methods
подхода
of fund
паттернов
transfer,
безопасности к
although in
экстеншенам,
the
и,
industry
соответственно,
there
мы
is
решили
now
это немного
generalized
исправить.
approach to extensions, and we have decided to correct this
Всем привет.
situation.
Меня зовут
Everyone.
Артем Михеев.
My name is
Вместе
Artem
мы
Mikheyev.
этот доклад и ресерч делали с командой
We're going
Niplox.
to present
Как Сева уже сказал
together
слово правильное, мы
with
занимаемся
Uniflox.
фундаментальными исследованиями и
As was mentioned
аудитами
before, we're engaged in fundamental
экосистем,
research
скажем
and
так,
audits,
Web3-продуктов.
auditing the security
Хотя
of
мы в этой
Web3
сфере
products.
достаточно недавно, всего примерно полгода, мы уже
Although
поработали с
we've been doing that for slightly more than 2 years,
такими как
we have already
MetaMask,
established
вот про
relations
них
with
немного будет в этом
major
докладе,
vendors such as
Coinbase,
MetaMask,
ну и многими
and
другими.
my partner is going
Наша
to
команда в
cover
целом
that
сформирована
in more detail.
по большей части
Basically,
из
our team
наших сокомандников из
mostly
CTF команды
comprises
KBZ. Если кто-то играет в CTF, наверняка о нас слышали, потому что мы
KBZ
последние несколько
members.
лет занимаем
You may have heard about us because in the recent years we've been part of top 2, top 3, and top 4 worldwide. And this year, for third time in a row, we'll be participating. We won the CTF in Japan 2 years ago, so we decided to engage in Web3 since this topic appears to be quite interesting to us. A few words about ourselves. I've already introduced myself. In addition to Niblox, I work as a cloud infrastructure engineer. Previously, I worked for Ozone, and currently I'm working on algorithmic trade. I've already introduced myself, although the community may know me mostly under my nickname. In addition to Niblox, my key business is doing research for Solid Lab, and my topic is cybersecurity. Well, I suggest that we should proceed to the main content. To begin, I'll make a brief introduction, what you should expect from our presentation. It will be very technical, although I'm still hopeful that it will be understandable to you, even though you're not a technical individual. We'll be giving examples of specific attacks that we implemented. And let's begin from considering the overall extension architecture. I'm speaking about browser extensions for you to understand the technical details and to make sure that this presentation is useful. And then we'll proceed to simple interface attacks in the context of crypto wallets, and then we'll drill into more detail, speaking how extensions can be utilized in order to carry out attacks on websites. And then we will discuss how extensions can be attacked from websites proper. And we'll also consider how crypto wallets can be attacked through finding browser vulnerabilities. We'll go over the attacks that we use to exploit Crypto.com vulnerabilities. So, let's begin from the architecture overview. Understanding that many of you are not familiar with the extension architectures, I should say a few words what it's about. It's pretty plain and simple. For example, we may have a page and an extension connected to it. And we have four key components, which are in-page script, which is script that is embedded like any other website scripts, which means that they are on the same page and in the same context of the website is the content script. It's also embedded in the context of the website, although it is part of an isolated context. We'll get back to it. There are also background works, which can be construed as microservices, which are launched continuously and in the background to be in control of all the pages. And it is through them that we implement the most serious logic. And there is also data storage, which can be addressed by the extensions themselves.
Начнем с бэкграунд скрипта.
All right, let's begin from the script background. Discussing browser extensions. The main file is manifest.json, which describes the extension, specifying all the key permissions. This file should be uploaded, some of them to work in the background, others in the main script, including the uploading rules and so forth. As I mentioned before, when you open up an extension and look into its code, you will see the background and the service workers, which will be acting as a microservice for the whole extension. Speaking about the storage used by the extensions, we mean two branches. The first one being the home storage IP, which is a specialized privileged IP, which is accessible by the extension. It stores the session, .local, and .sync. As part of our presentation, the context of extension safety, it's not that important to distinguish between the session, the local, and the sync. It's just important to remember that session, local, and sync are accessible by default to both background. As to the sync, is a storage that's synchronized between all the instances, which may include your Google account. To make sure that it's accessible by the script, it should be engaged manually. As I mentioned before, the content script is embedded into the website itself. Besides, we have a page on the extension proper, which is usually at chrome.extension with the following ID. And it will be typical local GB, local storage, and so on and so forth. Speaking about content script, it's important to mention why it is necessary. As I mentioned before, the key differentiator, differentiating it from pscript, general script that may be loaded on the page, it does isolate the context, which means that all variables will not be shared, as well as redefined features. It will not be shared with the main content, with the main context, to make sure that the website will not be able to disrupt the document. At the same time, we'll be having full access to the code. All the documents will be able to send post messages and have access to the storage, to IndexedDB, and the other storage resources of the website. Speaking about content script, It's also important that the send message IP or an API allowing us to communicate with our API script. We'll get back to it a bit later.
Так это примерно выглядит в главном файле manifest.json.
This is the way it looks like in our main JSON manifest. We just specify which file is to be loaded, and we also indicate the vault. In other words, is it going to be isolated while loading or not? Without that, it will be isolated by default. Through Chrome scripting API, we can also upload it in the runtime using our background script.
Самое важное, что уже упоминалось несколько раз,
Most importantly, and it has been mentioned several times already,
потому что
it's important that we have our isolated vaults,
создается отдельный контекст.
because for every extension, we create a separate context on the website. All of those contexts having access to a shared DOM.
Соответственно, как разработчик экстеншена, ты не знаешь, какие
As
экстеншены.
an extension developer, you never know which extensions are going to be loaded, which may cause additional problems.
Спасибо, Сева, за введение. Я, кстати, забыл сказать.
Thank you, Seva, for this introduction. By the way, we have prepared 3 bags with merchandise for you to hand it out afterwards. Now let's proceed to attacks. The attacks on extension interfaces, whatever strange it may sound. What is an extension interface?
Кажется, понимание это
In a classic sense, it's a kind of pop-up.
нажимая на иконочку экстеншена, где у тебя
You can open it by clicking on the extension icon to have the interface displayed.
возможность использовать
Besides,
в виде
you can use
И здесь интересный
the interface as a panel.
все эти ресурсы располагаются
Interestingly,
на
all these resources
самого экстеншена,
are based on the origin of the extension proper,
поставляются вместе с экстеншеном в
and they are supplied
который устанавливается.
along with the extension as part of the archive installed together with the extension.
Элементы интерфейса были доступны.
For these interface elements to be available,
Помимо того, что эти
rephrase.
интерфейса
In addition to the fact that these interface elements are used by the extension interface itself, they can also be used
экстеншен конкретно
for the websites and by the websites
Wallet, например, вставляет
worked by the extension. For instance, a Rainbow Wallet
специальные стили для поп-апа, который он отображает при уведомлении.
inserts its own styles for the pop-up to be displayed for notification. Interestingly, these resources are available
Да, как бы в качестве стилей.
by anyways. Here, they're embedded as styles.
Фетча
However, they can also be requested from the network or accessed in any other way, and we're going to go over it right now.
которого
A
возникает,
classical problem usually encountered is as follows.
любой ресурс,
If it's possible to frame any resource,
мы можем сделать что-то на типе классического кликджакинга, то есть
and we can do something like classical clickjacking,
кликер сломался. Да. В чем
the clicker is down.
использовалось довольно часто при реальных атаках
So,
и также идентифицировалось.
it's been used quite often in real-life attacks, and we analyzed it in working with a number of cryptopurses. When an extension allows framing any HTML file,
Просто взять и вывести
we can
с
just display the iframe on the page, such as approved.html, should there be a button
как это делается в стандартном
sign transaction or submit transaction, the way it's done in classical clickjacking.
claim-free NFT,
We can get button displayed And the user will believe that they are clicking a button that has nothing to do with their crypto wallet, while in reality it will be signing transaction which is about transferring all their money to us. Another problem, many developers already know that they shouldn't add critical pages like these, making them available for access from the web. However, there is a valid behavior which is not familiar to many developers. If we have iframed just one page, it will carry out redirect to a page with no accessible resources, and the redirect will work out. Having found such a redirect for a page that's allowed, we'll be able to iframe and implement clickjacking for a more important page for the same .html to steal money from the person. A couple of years ago, this mechanism was used for clickjacking at MetaMask, and the report was evaluated as $120,000. And this mechanism is still widely used, although it can be identified and detected. Another interesting problem, which may not be considered by many of you, is UI redressing. It's about rebuilding our UI extension or application using our data in an unpredictable way, in a way which is not expected. This is an example from Tranvalet. They were missing some Unicode symbols, and this allowed using a decentralized application to give a name, helping to redress the UI. And we could insert our own text. These attacks can be particularly dangerous when they are concatenated with another attack in order to trigger an XSS. With such an attack, one can just fool around the user to get an XSS, which may be necessary for access to the crypto wallet, to steal the money. Why is it important? It is important for crypto wallets because those wallets, they usually grant very little data, and quite often users sign transactions knowing nothing about their content, which aggravates the problem even more. Now let's proceed to more technicalities of these attacks, namely what extensions allow doing with websites and what kind of risks they actually pose and how extension problems can be used in order to attack websites. As was mentioned before, extensions have content scripts and session scripts, both being scripts that are launched in a certain HTML-related context attached to the page model. Well, actually, the extensions can modify any elements of the DOM model. Here you can see an example with just one password. The extension just adds a UI element to make it possible to insert fake passwords. The danger is in that you cannot secure yourself from the side of the website because it ignores the policies of the website.
Content security policy, который вы
You
задали.
can see it here. CSP for content security policy will just be ignored, and the extension
который как бы не запрещает.
will work in accordance with its own security policy,
И что больше, можно как бы переписывать не просто стиль,
allowing you to do whatever you want with the website. You can rewrite HTML styles. You can insert or embed your own scripts.
скрипты у нас исполняются в отдельном контексте обычно.
If the content scripts are usually
С контекстом
run in a separate context and you're in no position to interact with the text of the domain,
так называемые, опять же, inline или in-page скрипты
the extensions
исполняются
are free to insert the inbuilt scripts, which will be
полный доступ ко всем,
executed in the context of the website, granting you access to all the variables and memory resources.
включая как бы это введение, такое экстеншн имеет полный доступ ко
To
всем
conclude my introduction, I should note that the extensions, they grant you access to all the elements of your domain,
content security policy и другие политики.
while ignoring the content security policy and the other policies of the domain, allowing you to do whatever you want.
Пример скрипта кошельков уже раньше я говорил про Rainbow Wallet.
I already mentioned Rainbow Wallet and some other wallets that allow for this. They just show a kind of notification
Вы в валете поменяли
of some action. For instance, like
блокчейн-сетку,
you may have changed your blockchain net
так скажем, HTML,
is done
каких-то стилей,
with XML injection
уведомлений
using some specific styles
HTML в контексте дома.
to display this notification in the context of the HTML itself, of the website itself. If we look into the tree,
Представляет просто
we will see
HTML. Если
that it can be inserted via HTML.
сразу понимаете, что это
If you're a security specialist, you immediately understand that it's a very bad pattern leading to XSS.
вставляется URL сети, вставляется какая-то иконка
Look,
сети,
the network URL is inserted and some icon.
криптокошельков. Почему
It can mean nothing, but in the context of crypto wallets, it may be a problem. Why?
в множестве разных сеток, и у них должна быть возможность эти сетки
Some applications based on different networks, and they can add them actually, which gives us a problem.
своего веб-приложения, со своего домена имеем возможность
From our web app, our domain,
и задать ей
we can
параметры,
add a new network
хотим,
and set up whatever parameters we want.
в иконку payload специально
If we insert
под
an ad hoc payload icon,
то
which will match the injection point,
где не будет видно, что что-то подозрительное вставляется, потому что
you will not even be able to see anything suspicious.
иконка как бы отобразилась, все нормально.
The injection
Даже не заметит, что какая-то
is against the icon, and the user will not even see that there is an issue.
мы добились XSS. Но вот
While we have managed to
так как
implement our XSS.
вставляет эти уведомления на всех
Since the crypto wallet inserts those notifications on all domains
три приложения, которые будут использовать это,
for all the Web3 applications that may be using this network,
добиваемся XSS
we end up
не на своем как бы домене,
with an XSS which is not on our
на других веб
domain or sandbox, but on real life domains and web applications. And our XSS
с точки зрения даже
is therefore
это universal,
acting as one
когда
of the most dangerous attacks,
проатаковав браузер, по сути, с одного сайта, можешь
where having attacked the browser from one website, you can get your XSS on
То есть
any other domain.
в данном случае мы сам экстеншн никак не проатаковали, мы не
Well, in this particular case, we have not attacked the extension itself.
это все безопасно.
We haven't stolen any money from the crypto wallet, but because the extension is used as a link
Между разными доменами мы
between different domains
эксплуатировали совершенно другой домен с нашего.
on our browser, we
Опять же,
can exploit a vulnerability on some remote domain. And as a result, we see a very interesting attack surface. Although our websites are separated using separate security policies and so forth, there is still a link established as an extension with a shared storage for different domains. We will also consider a reverse situation, where one extension is attacked by another extension using a link represented by a shared domain from which both extensions are launched. Now, let's proceed to attacks on extensions coming from domains proper. And we see something really important here inside the extension. Within an extension, we need to be able to do two things. First, sending data from websites via content script and content script data within our background. Usually, it's just a request to sign a transaction and so forth. And here we can apply two different approaches. The first one is well familiar to all, which is the post message, which is used the same way. It's using classical Web 2.0 apps rather than extensions. For example, if we get the post message registered within our content script, all the post messages coming to this frame will pass through a message handler registered within our content script. The other approach is origin-wide. It doesn't allow us to do frame-to-frame data sending, but sends all the inserts using broadcast channel. It's not a very popular method. There is another method. We can use the message channel, which is very close to post messaging and broadcasting, and it does not lead to any fundamental change. The first problem that is given rise to, and we found it in a number of wallets, like the Gate wallet, which is presented here. The wallet itself would do the injection of the script. After that, it would make sure that the message is not sent to content script, but is received by itself. Then, in order to find the handler, well, it was necessary to find the type of response. However, the problem was that, and we worked with JavaScript, with this popular pattern, people usually don't make sure that the type is within the handler. We can just send the type construct and then add any data we may want. And when the handler is called with the construct data, the construct will return the data. We have learned how to send data from domain with any random data. And we can do it from a domain that we are in no control of. Why is it that is depicted by this example? For instance, we have a MetaMask communicating via post messaging. In post message, there is a library which is based on post message. What we do, we send a message which is usually sent by a MetaMask provider from our domain to the app. And it may contain a transaction, but we do it using our trick with a second extension. As you can see, our MetaMask would display a request not from our website, but as though there is a request for a transaction. What's important here? MetaMask is not to blame. The problem is, when you get down to developing extensions, it's very seldom that you keep in mind that your users may have myriads of other extensions. And this logic, it can be broken completely with post messaging. There is no an efficient way to protect yourself against such attacks. Another illustrative example that we found is so-called zero trust handling. What is it about? Let's look at our first example from post-message stream MetaMask. Basically, it doesn't trust any origin. Everything is validated. However, if we look at the point base, we will see kind of backdoor for their own website, and it's done to get them connected, to make sure that those domains can act on behalf of any other domain to do whatever they need. And here we see a problem. This logic, it can be spoofed.
And what's the point of it? The post-message logic came to us from classical web programming in the context of applications or in the context of extensions, and there is no any other vector of attack. With extensions, we are in the same window where we have the script of the content. That's why we can use dispatch event function in the window and not using the post message link. We have the post message event, and in the origin we add the validbase.com, and we can randomly put the event source, and it will come to us with the origin that we indicated there. So now, everywhere, not only post-message handlers, if you open a point basis, you can see that preventively it will be checked that event is trusted. The second problem that many developers don't think about, that within the event handler with the message name, we can set not the essence of message event, because matching happens there not by the prototype, only by the name of the event that you sent. For example, we can make such a thing that media message share it. It's a classical event. It has the lines like event has, and nobody checks it. And it doesn't really create security vulnerability. And here what we see that MetaMask doesn't check this one either. So concluding this part, based on the analysis we had, we made a conclusion that broadcast channel, the technology that recently emerged, we think it's most suitable for building protocols and for extensions, because it doesn't work based on the events of the browser that was developed for regular sites. Besides, this API guarantees that the request came to you from the same domain. As we showed you with the post messages, we sent post message to the Uniswap window, and this attack wouldn't exist because from our website we wouldn't be able to send a message to a different domain. So the broadcast channel, that's the only good solution to protect yourself from this attack that appears because you, as a developer of extensions, you can't control any other extensions that users use.
Ну и теперь перейдем к самой сочной секции.
So now the most lucrative section.
Почему не стоит доверять даже самому браузеру?
Why we shouldn't trust browsers themselves, and why you shouldn't trust your money to the browser, because such a fundamental component as a browser that realizes everything for the extensions can be vulnerable as well.
Отдаляясь немного от темы, зайдем так.
Going a little bit away from the topic itself, and let's begin from afar. What is site working and what it does? Everybody who deals with cybersecurity, you should know that service marker, this is a special background component, a script that can register itself, and it will work separately from the context of executions of all the parts of the website. But what it can do, it can intercept some requests that the website sends. Oftentimes they use it for caching of different requests, because if you realize caching on one tab, but then you won't be able to reuse the cache between the tabs. But when we do it like this, it has like a connecting link between the tabs.
Вот если мы рассматриваем теперь сервис-маркеры в контексте.
Now, looking at service markers in the context of extensions.
Здесь входит новая механика.
Here we have a different mechanics. It's isolation of the network. As content script is isolated by JavaScript from the main website, so requests from it should be isolated as well. Why? Because otherwise the service worker will be controlling this website. If service worker could be processing requests of the extensions, that it could fake responses, and break how extensions work. For the sake of protection of extensions, and as we showed you in the architecture, one extension, which implies it creates its own cell within the domain that you can't break to from the website.
Да. И тут, соответственно, первая из проблем.
And here, one of the first issues we found, it's quite a popular pattern. When in runtime, in the content script, it's not manifestations, it's script JS. So you can see awaited import of extension resource. It's quite popular pattern. It was in Crypto.com extensions from the standard. It was one password, about 1 million downloads. And here's the problem that we found.
Вот этот импорт функция внутри хома внезапно.
Import function inside the Homa, it wasn't realized. Developers, they skipped this line. They didn't think that it's supposed to be there.
И, соответственно, что мы могли сделать?
And this is what we did. We could register it on our website. The following service worker that could just check if the request goes through .com extension, and if it goes from our crypto.com extension, then we can just substitute it and get access to storage of the extension itself. So it worked in Chrome version 129, where they fixed it, but they didn't have storage, and as you can note, that the data is pretty useless. And what to do in this case? We need to look at how content script is working with the background script. And suddenly it turned out, since the developers of Crypticom, they think that content script is secure, and usually users can't do anything about what's happening in content script, and there are many sensitive parameters within which you can make an injection. For example, the simple one, origin, and it helped them to spoof transactions and to get the data as they get it from any plain app, and you can check any number of valids. With Oxyblock securities, we would be able to read them, and from the name of Uniswap, we could send them. So, it wasn't the end of the problems. Architecturally, the problem is deeper. Think about it. Chrome developers, they had to write the script in all network paths, and it's a bad architecture solution because you can easily miss things, and the developers themselves, they don't take security too seriously, because their main efforts they send to finding RSAs and many other things. So they decided to see where else they can miss the request, and they found another place. This is link header. And here's the point. Link headers within the requests and within the responses to requests, they went through a service worker. This is how it works. Crypticom was fetching its internal resource where they had a link header, and this link header loaded a few styles or something like that. And then, after that, in order to take it to favicon and the style or something else, it would go through our service worker. And in response to this request with a preload, you could send another link header with a directive mode preload, and this is the directive. If the browser sees it in the request, it will follow it, it will visit our service worker again, and it will cache it, or will sparse it. And using this chain of the links in the preload modes, and when they make a request to prom extension to ID, and we get back to our JavaScript, and we get all the same that we received the last time. I sent it to Chrome, we get it CV, and now it's not relevant anymore. And why it's important globally? In fact, it shows us how badly, how poorly this architecture is realized within Chrome, and it's not properly worked on, and to figure out that import is not isolated. But this bug, when I looked at it, it sat in Chrome's branch for 10 years until I saw that it wasn't isolated. Maybe after this presentation, some people will go there and will see more of it. You may find some other vulnerabilities. So therefore, you can't trust the browser. And in general, using browser extensions, yet it's quite popular way for cryptocurrencies, but the idea is bad anyway, because you can't trust the developers of the browser. You can write your code securely, but there's so many undefined headers, and that may allow the attacker to affect your users in some bad way. So that's it. Of course, I would like to thank all the vendors and MetaMask and all other people who spoke to us, and I would like to thank Chrome that fixed our vulnerabilities, and I would like to thank Elizaveta who made this great presentation, and thank you, all of you, that you came to listen to our presentation. So we're ready to answer your questions, and don't forget that for 3 best questions you'll get some merchandise of ours. I have a couple of questions. First one. Since you spoke about Google Chrome and crypto wallets, maybe you can give us some recommendations. So if it's not so good, then what's better to use? What browser would be the best? And maybe it's better to use some software wallets. That's one thing. And another thing is, in MetaMask there was a problem that has to do to de-anonymize the user. When NFT was sent to a particular wallet, then it was bringing the data, taking the data, and since you were dealing with this, maybe you found some similar vulnerabilities in other crypto wallets. Here's the problem. First of all, many vendors, they're not quite interested in this attack vector. So the money didn't go, fine. It didn't de-anonymized, fine. But we didn't talk to vendors in this regard. Here we showed you just a small part of the attacks. And in fact, there are more serious vectors in our view. And we worked pretty much with those ones. Answering the first part of the question about the browsers, well, we were studying Chrome because they have most developed extensions part. But in fact, other browsers are not universal. Safari, with support of the extensions, and Seva found some vulnerabilities there. Safari is also moving as part of extensions. I wouldn't advise to use Safari at all. There are a few vulnerabilities in terms of isolation. And given your recommendations, I think the best way is to use mobile applications. I think it's the best one. Maybe you don't know, but there is such a project. It's if there is a problem with CVE, you can go to that project and they can help you actually with CVE as well. Thank you for your presentation. I would like to find out, would it be logical and will it help creating a standard? Will it help making crypto wallets more secure? Would it help? Yes, right. One of the key problems is that, in fact, there is no any big developers framework for extensions, and the only people who are kind of linked with the crypto wallets, it's MetaMask, so they have packets that they use and really secure tools, post-message screen and lava mode, and with. But in fact, yes, you're right. There is no somebody big who would come to open source that people wouldn't be writing this 10,000 crutches, so to speak. And it's not about some standard patterns. The key problem is they are not interested in making crypto wallets more secure. There are not so many big incidents that people would take it seriously. Thank you for the presentation, and my question is more about extensions, but not particular crypto wallets extensions. My question is, you as experts can say, about browser extensions as a compromising of the system. What are the methods of attacks and what would be a protection of it? When you can call something from the browser and to continue infecting the system, yes or no, and is it valid today, and what are the protection methods? And then the question is, and the manifest W3 can solve the problem, or there are some other ways to go around it? So you're talking about the attack matrix when users download with extension or with bugs, right? Yes, roughly speaking, yes. So it's about the manifesto W3, and does it resolve the issue? The extension itself will not give you much. The key problem is that usually all users, if you look at popular extensions, users just allow to launch the extension HTTPS with asterisk. And the developers, they don't have a comment so that the extension wouldn't have access to all data. When you installed the malicious extension in Chrome, then you gave all the access to the attacker. So how dangerous this is? Is it used? So malware extensions, they're used for that? To get the system, to hijack the system. Well, actually, this is not our field of expertise, and I won't be able to tell you much about it. So I can only say that the tools, they do work. Okay, thank you.
Привет, спасибо за доклад. У меня два вопроса. Первый про
Universal XSS, did they have real cases when it helped them attack other websites? So when we changed for a different blockchain, and then so that in the different websites they should just have a pop-up. When there was an example of Subsale, so we get the network. When you go to Upsale, it sends you to cryptocurrency. So I want to work with this network. So automatically you get the extension when you have access, and it works. And it's just not only applicable to this website, it can be applicable to any website that uses the network, not the network that the user uses. But in this pop-up window, so they will be saying that change the old one for the new one. Well, see, the data that we wrote, it's going to be in the global storage, and it'll take it from there, if I got your questions properly. But I just thought that in pop-up there will be a new link that it will be changed for. Yes, it is, but this network was added to Crypto Wallet from our website, and it turns out that we control the configuration of this network. And the second question, extension cannot trust the web messages from the website because another extension could have changed this page, right? What could save us if all important post messages would have a token that extension itself would mark with? It's difficult to protect post messages as part of the implementation from different SDKs. The simplest way is to use broadcast. Some people use it because in the broadcast you find the random ID and nobody can attack you. Yes, right. It can save you, but from what we looked at, so in terms of realization, it's way too complex. Probably you can build it. It's just more difficult to implement rather than to use simple random ID. Thank you for the presentation. Did you study app tokens in Antonio? So do you know how to fix that? They call this token USDT. It breaks layout. You give them one tone and you get 1000 SDT. You mean in the context of cryptocurrencies? Again, it's problem with the user interface. You can call tokens as you want. So in fact, with tokens, we didn't look at it. We looked at it as part of crypto wallets while realizing our application. You can send a config and a description of what you do, but yes, the token vector sounds pretty interesting. No, we didn't look at it. When into Unkeeper in Unifast, you could put there any URL. Well, it's a problem of any wallets. You can put there any URL, any icon, or whatever you want, and nobody can be protected from this. Another question. Website owners, they're not protected from the extension that extension can identify the dome. And they check their home. If the extension how you can fight with certain extensions. When we're talking about the classical attacks and orientations, so CSP won't work. You can write any tool, any crutch, so to speak, but it's going to be a crutch, and nobody is going to be dealing with this. And you're not supposed to use a generic mechanics as CSP. You need to think about so the user will come there with extension, and if extension will change something, so people don't do this. So thank you very much for your presentation. Thank you, really great. The question is, did you look at how browser protects crypto transformations, crypto layer? So how could you comment on this one? Well, in fact, it's a very complicated question. In popular extensions, first of all the crypto transformations, they happen in background within the WASMA, where they clean up the memory. And since we're here in the context of PA, if that's what you're talking about, so you know, it doesn't make sense to trust it. I don't know what else to comment. So browsers, they don't take any special measures, so nothing is embedded in the browser for crypto wallets. And that's why crypto wallets, and this is what MetaMask does. So they're trying to come up with their own wrappers for them, because the browser does not give them any methods to protect the crypto wallets. Thank you for your presentation. My question. The case was so the objects of the event can be sent and it's not validated, so we can send any object or how that happens. So if you can send any objects, well, in fact, any object is not quite precise phrasing. Any transferable browser is called any object that we can deliver with post message. It's something at the level of object that has some primitives or can even have a buffer. So some custom class cannot be sent using some random methods. Hello? Two short questions. First, is it possible to protect yourself without installing some random extensions? In terms of malicious ones, so if we can't execute a script, and if the website can't execute a script, so what? So the attack through the website, from the point of view of the website, there is no way to block it in any way, because all the security policies, they used for extensions. But the question is in a bit different thing. So if we turn it off to the website, will be able to attack them. The problem is that we can generate numerous numbers of domains and from JS, and it works domain by domain. So if you turn off JS on our website, it's not going to work. So in other words, so if you turn it on for the white list, so to speak, so something from in terms of, so you turn it off and your site won't be broken, right? So in other words, so if you do it through the script, then the problem in some ways will be mitigated, right? Yes, right. And the second question, so we here work with the solutions of security. So what solutions can help to fight with malicious extensions in the websites and antivirus and many others? Let's answer this question separately because the time is up and we don't want to detain other speakers. It's a complex matter, but the answer is that from the model of attacks, so if you visit some strange website and something was triggered in the extension, then using classical methods, it's very hard to do anything. So, for example, in the same MetaMask and some other ones, there is a list of malicious websites. So we are there as well because of what we exploded. So they forgot to remove us from there. So of course you can do it on top of it and you can block some extensions, but in classical situations it can't really save you because you register a new domain and that's it. What can they do with you? So only through the list of domains, right? Yes, well, at least to prevent this mass attacks when you know that they started and you have the list of domains. Well, with this, thank you. That's it and no questions. My general question is, let's imagine a situation if I gave the permission to our cryptic wallet. Will it be easy to click jack me in the morning and browser can protect me more than I can do it myself? Damn, I don't know what to answer to this. I think browser will not protect you at all, and if it will protect your crypto wallet. So it's important to use a proper crypto wallet. Choose MetaMask or some other ones, those ones that stood through time. So browser will not do it. Okay, thank you.
Мне понравился первый вопрос, вопрос про Universal XSS.
Okay, I liked the question on a universal XSA best of all, as well as the question on the rules for crypto transactions in the browser. These two questions are getting the prizes. Thank you.
Раз. Нужен. Раз. Всех приветствую. Зовут меня Пробочкин Андрей. Занимаюсь я реверсом. Это мой профессиональный навык. Если говорить про проекты, ранее я занимался ботами, парсеры, скраперы, вот и прочие моменты. Сейчас перешел активно в исследовании уязвимостей. И тема моего доклада — это реверс-инжиниринг под iOS. Представьте себе вот такую ситуацию, что вот у вас есть какой-то сервис, там, соцсеть, например, или что бы то ни было, и вас активно автоматизируют. Ну, например, там заливают контент, собирают какие-то данные, ну и прочие моменты. Причем этих ботов вы никак не можете определить, потому что они маскируются идеально под настоящих людей. И с другой стороны тоже пройдем, вот кину этот тезис, что как бы многие, наверное, слышали про вот эту сферу, там боты, там скраперы, пролив трафика, вот это все. Но откуда корни растут, как бы мало кто знает. Вот, и я пришел, собственно, сюда вот посвятить эту тему и рассказать, откуда оно все берется. Итак, и у вас еще возникнет один вопрос такой, а почему мы говорим именно про iOS, например, а не про Android? Казалось бы, там, через браузер можно это сделать, там, либо через Android, почему именно iOS? А вот дело в том, что в контексте автоматизации Android, он не актуален уже. По какой причине? Во-первых, API у него слишком обширный, там куча всяких методов, функций, там библиотек, в общем, нужно с этим копаться, если честно, запарно. Операционка отличается от одного производителя к другому производителю, тоже неудобно. Ну и исполнение кода происходит в Java-машине. Разумеется, это удобно для реверса, для чтения кода, но для патчинга, а нам именно нужен патчинг, далее объясню почему, это не очень удобно. В то же время под iOS, он у нас един вообще на всех устройствах семейства компании Apple, там MacBook, iOS, там вот эти часы, нам по факту все одно и то же. Еще один интересный фактор — это что с точки зрения вот, разработчика приложения, он не может внедрить такую защиту, как проверка собственной подписи. Вот просто нет такой возможности. Всего лишь два параметра выдают уникальность пользователя. Ну, то есть уникальность вот установки приложения, что это именно вот один и тот же человек. Ну и исполнение кода на iOS у нас происходит нативно. Что ж, поехали. Первым делом мы погрузимся в тему реверс-инжиниринга, как там все установить, программы, как все настроить, ну и базовые навыки по патчингу. Итак, первым делом нам понадобится 3 девайса, это MacBook и 2 телефона. Первый у нас будет jailbreak, и второй обычный без джейла. У вас тут тоже, наверное, у некоторых мог возникнуть вопрос. Блин, это же так неудобно, да, то есть... Если мы что-то будем патчить, ломать, то, скорее всего, нам нужен будет iPhone на jailbreak, чтобы это все делать. И, конечно, в конце концов, мы тоже это будем делать на jailbreak, возможно, там какой-нибудь фридой. Но на самом деле наша цель — это научиться патчить под устройство без jailbreak. Ну, то есть, грубо говоря, там, на мой самый последний iPhone все то же самое спокойно встанет, там все патчи, все хуки, вот все будет спокойно работать. А jailbreak телефон нам понадобится просто, чтобы первоначально тестировать работу системы, там, делать какие-то первые патчи, ну, то есть больше для себя, чтобы удобно было. Итак, двигаемся дальше. Сперва настроим телефон на jailbreak. Что же такое у нас jailbreak? Jailbreak — это специальный взлом телефона, который дает полный доступ к системе. Вот, например, тут на скрине установлен там специальный этот терминал под iPhone. Вот у меня есть доступ ко всем файлам, я могу куда угодно заходить, читать, писать. Вот, работает он до 15-й оси включительно, на самом деле до 14-й, там вот на 15-й просто вот совсем небольшой спектр устройств, куда это можно поставить. Но в нашем случае мы будем ставить на 14-ю ось. И еще один вид джейла есть, который нам не подойдет, это rootless. Он нам не дает доступ ко всем файлам, там, ко всем территориям, поэтому ну, я упомянул просто, чтобы вы знали, что такой тоже есть. Он работает с 15-й оси
to know that it does exist. It works with iOS 15, 16 and so forth. But we're going to use 14.
Собственно, там все просто ставится. Мы скачиваем специальную программу Checkra, там нажимаем Next, Next, Next.
We download Checkra.
Этот телефон по проводу подключаем, все, там загрузка прошла. У нас появилась сидя на главном экране.
Everything has been loaded. We see the logo on the main
там, где мы
screen.
можем поставить всякие полезные нам
Is a
твики,
third-party
ну и пакеты.
storage
Пройдемся
with
дальше
a
по
range of
твикам и
interesting
приложениям,
tweaks.
которые тоже будут полезны в
Now let's
работе.
go over the tweaks
Filza —
and apps that
это
we'll
файловый
need.
менеджер.
Filza is a file manager.
Explorer там или Root Explorer, вот то же самое.
Set up your S
Тут,
Explorer
вот,
or
на
Root
примере
Explorer,
на картинке я открыл
stuff like this.
файл с кейчейном телефона.
Here you
Тут
can
вот
see
можно все
file
поля
with
отсматривать. Тоже, как видите, доступ
You
есть.
can look
Далее.
into all the fields.
AppSync Unified — это специальный
AppSync
твик,
Unified
который нам позволяет ставить ИПАшки.
is
ИПАшки —
special
это
tweak
аналог АПКшки
allowing
с андроида,
to set
без
up
подписи приложения. То
patches
есть
with no app
устанавливать,
signature.
что мы захотим.
In
Далее,
other words, we
App
can
Store++
set up
полезен
and
в тех
install
случаях,
whatever we
когда нам
want.
нужно
Next, App Store++.
установить
It may be
какое-то
useful when we
приложение,
need to
даунгрейднуться
install
там,
an
до
application.
какой-нибудь старой версии. Но вот в контексте
When
вот
we need to
jailbreak телефона
downgrade
нашего
to one of
на
the previous versions. For instance,
iOS 14,
in
это
our
будет полезно, потому что там
jailbroken
уже не
phone, which is
поддерживаются
based
новые версии
on iOS
приложения.
14, it will be extremely useful because it does not support
OpenSSH — это
new versions of
утилита,
apps.
чтобы мы могли
Next,
по SSH просто к
OpenSSH.
телефону
It is
подключиться
utility,
и работать как
allowing
с
you to
терминала,
get
тоже
connected
удобно.
with your phone to work with an
Так,
external,
теперь настраиваем iPhone 11, который
which
у
is
нас
also a
без
good idea.
джейла.
Now,
Как же у нас тут
let's set
обстоят
up
дела?
our iPhone
Здесь
11
нам
with no
понадобится подпись
jailbreak.
разработчика, чтобы
For this,
устанавливать
we will need a developer
любые приложения,
signature
которые мы захотим.
to be
Тоже
able
как бы
to
есть
set
слух, что
up
iPhone он закрыт, типа мы не
the
можем их
apps
поставить,
we
но на
are
самом деле можем.
interested
Просто
in.
надо эту подпись купить
Our
и
iOS may
поставить.
be locked.
Есть два варианта.
However,
Первый — это
we can unlock it actually.
купить, собственно, сам аккаунт
And there are two
разработчика у
options.
Apple, и второй
We can
где-нибудь в Телеграме
buy
под
an account
UID
from the
телефона
developer,
там, за $20,
and
скажем,
we can
купить.
also pay
Мы пойдем первым
$20.
путем, купим аккаунт разработчика.
Well,
В аккаунте разработчика
we'll
это
opt for
примерно
the
вот
first
так
way.
работает. Мы вводим
This is the way it
UX
works
устройство. Ну, до этого мы
on
там
the
настройки
developer's
получаем.
account.
Вот, вводим его.
We get
Затем
what we need for our settings,
регаем какой-нибудь bundle
enter
ID, там
the data,
рандомные буквы пишем, не суть важно.
get
Capability
some random bundle
можно не
ID.
ставить.
We may
Затем вот
go
выбираем
away
этот App
with our
ID, выпускаем
capabilities,
сертификат.
and then we
По
issue
итогу вот этих
certificate.
всех действий мы получаем два файла. Первый —
As
это
a result,
P12
we
и Mobile
get two
Provision.
files,
Далее через специальную
P12
программу
and
Gbox
Mobile
мы вот эти
Provision.
два файла туда
And
грузим.
then using
И
a special Gbox
там у
program,
нас
we
активируется
will
такая кнопка,
load
что
these two
сертификат поставлен
files,
успешно. И теперь в Gbox мы
and
можем
button
импортить ипашки
will be
и нажимать
activated
install,
saying
install. То есть любое, что мы захотим ставить.
the transaction has been
Теперь
completed
перейдем к программам,
successfully.
которые нам понадобятся.
Now let's proceed
это
to the apps that we will
IDA
need.
Pro, разумеется. Кто-то
They
знаком с IDA
include
Pro? Поднимите руку.
IDA Pro.
Вот, хорошо,
Those of you who are familiar with
Есть
IDA
ревелсеры среди
Pro,
нас.
please show me your hands.
Далее, Фрида.
Oh,
Динамическая
great. Quite a few
инструментация.
people.
Мы прям с терминала
Next,
быстренько можем
Frida,
какие-то патчи
our
быстро
dynamic
накидать, посмотреть.
toolset,
Ну и Xcode там, в принципе, все
allowing
по
us
дефолту.
to
Сейчас покажу.
to do things dynamic and
IDA,
exfold.
как я и сказал, ну, там
This is
интерфейс
IDA Pro.
сложный, на самом деле, если разобраться, там
Its
потихоньку
interface
станет
is pretty
понятно.
complex, although it's not
Фрида,
as
вот в
complex
данном
as it may
конкретном
appear.
примере.
Frida,
Вот я
I'll show you a
подключил, у меня
specific
подключен,
example.
значит, iPhone просто
I have
по
my iPhone
проводу
connected
к компьютеру. Я
with a
запустил
wire
вот с командной
It's connected
строки
to my
вот,
computer
команду Objection Merge App Store
using
Explore.
my command
И
line
затем
interface.
ввел
I
keychain down.
launch this
И
command.
у меня от App Store
And then I
стартовался весь
launch
keychain вот
my
дальше в терминал. Я его
keychain
могу
dump.
просматривать. Вот примерно
And now
такая
I can
логика.
look
Мы
through
с
it.
командной строки
This is more or
удобно
less the
можем в
logic that I
рантайме все, что хотим делать с приложением.
And I can do anything I
Ну
need
и
in the
Xcode,
runtime.
чтобы как бы на младшем,
Anything
на старшем брате
that
вот
I need to
iPhone
do with the
7
app.
тестировать, deployment
And
target я поставил
this is an example
14.4.
with Xcode for higher
Так,
iOS
теперь
versions.
поговорим про
In
важное
this case, it's
понятие, которое мы
14.4.
далее будем обозревать.
Now,
Это
let's
hook. Что это
discuss
такое?
an important
переводе-
notion, which is hook. What is it
В
about?
переводе с английского hook — это крюк. Мы будем ставить крючки
Translated
на
from
функцию кода,
English,
чтобы манипулировать поведением
it is a
программы.
hook. We
Давайте
needed
на
to
примере
manipulate
посмотрим.
our
Вот я
application.
сделал какое-то
I'll use an example for it.
приложение
Let's
тестовое,
assume
да, ну, на Xcode накидал.
I
Это
have a
просто
test
обычная
application.
форма логин и пароль.
Just a simple
Наша
login
задача,
form.
первая задача нам отловить логин и пароль, который мы
Task
введем
number one
через Фриду.
is
И вторая
to
задача — это
catch
подменить данные.
the
Мы то есть
user
вводим
ID
одни
and the
данные,
password.
нам
And
выдаются
task
другие
number
данные.
two
Давайте
is to
попробуем.
replace the data.
это сделать? Первым делом мы берем IPA-шку, то есть приложение, и нам его надо разобрать. Вот если мы с App Store его ставили через даунгрейдер, вот этот App Store плюс-плюс, можем получить IPA-шку и вот стащить ее на комп. Либо через Frida iOS Dumps, тоже специальная утилита вспомогательная от инструментала Frida. Вот на Git есть, там
utility from Frida.
Там все как предлагается, вот просто Python дампай и название приложения. Нажимаем Enter, все, оно тут локально дампит. Вот это приложение, вот, которое мы сейчас будем смотреть. На самом деле, IPA это как application, это тоже zip, который можно разархивировать. Собственно, мы этим и займемся. Мы переименовываем в zip, разархивируем, там будет папка payload, и в payload у нас файл, так и называется, название приложения, insecure
with the name of the app, which is secure login.
Мы вот этот insecure login, это у нас исполняемый файл, Unix executable файл, мы его грузим во Frida. И здесь сейчас я поясню, что происходит. Смотрите, тут все непонятно, страшно. Вот смотрите, слева у нас обозреватель функций, то есть какие функции Frida у нас нашла в файле. Там через свой опыт я просто поискал разными техниками вот функции. Нам нужна функция, которая обрабатывает вот логин и пароль. Вот я ее, предположим, нашел. Как именно, но это тоже отдельных навыков требует. Но не суть. Вот я ее нашел, я по ней кликнул. Вот она открылась. Так вот она и называется, как бы говорящее название, у нее есть процесс логин. Ну, в контексте примера, в принципе, это специально так и сделал. Индикатором того, что я корректно нашел функцию, служит следующее. Когда мы вводим какой-то логин и пароль, у меня выскакивает сразу алерт, что он введен. То же самое мы видим и в декомпиле. Есть некий какой-то Objective-C класс, UI Alert Controller. Вот. Мы видим Alert Controller и вот поведение. Ну, значит, мы нашли ее правильно. Логично.
And the behavior shows that I have identified the feature correctly. Now let's look into the stack.
Вот сигнатура функции записана. Вот у нее, кстати, есть
username
и password. И есть ее offset. Сейчас нам понадобится как раз-таки этот offset. Мы создаем новый файл .js, вот как раз-таки для Frida. Берем вот этот offset. И вот прописываем сюда. Это мы берем базовый адрес нашей исполняемой программы, добавляем offset, чтобы пойти на конкретную функцию. Затем юзернейм у нас, соответственно, это нулевой аргумент, ну, как ранее я показывал из сигнатуры функции password, это первый аргумент. И затем просто консоль лог и логируем вот эти данные и запускаем скрипт вот такой командой. Тут на презентации, к сожалению, не вместился скрин, вот как в терминале мне выводится результат. Там в терминале вот именно и выводится, что там MyLogin, MyPass, все успешно. Вот первый хук мы написали, мы перехватили данные. Теперь попробуйте манипулировать аргументами. Тут все то же самое, тот же самый базовый адрес, но теперь мы делаем следующее действие. Мы берем, аллоцируем две строчки, фейк-логин и фейк-пасс. И затем вот подменяем аргументы. То есть нулевой аргумент это у нас теперь вот наша строка, которую мы аллоцировали. Все так же запускаем утилиту. У нас сразу моментально спавнится приложение. И вот как можете видеть, мы там вводили какие-то вообще любые данные, а у нас по факту выскакивают другие данные. Вот это был пример именно с манипуляцией поведения программы. Что ж, давайте подытожим касаемо Фриды. У нее есть два важных недостатка. Первый — то, что работает только на jailbreak мобилах, и второй — то, что писать патчи вот на JavaScript. Ну вот такие, это в принципе несложно, но когда там какие-то сложные патчи огромные, ну вот парсить вот эти нативные штуки, это реально как бы не прикольно. Вот это неудобно. А плюс заключается в том, что это мгновенный запуск модификации. То есть буквально по проводу подключили, Enter нажали, все, оно запустилось, и сразу там, видим тестировку, захотим. Итак, назревает вопрос, а как же нам работать с новыми iOS-ами? Единственный выход у нас это, на самом деле, патчить пашку готовую. То есть внутри нее там патчить какие-то бинарные данные, грубо говоря, переустанавливать и тестировать, смотреть на поведение, как бы работает, там
Internally,
подменяется,
it
что-то
has
вылетает или
binary
нет.
data. We need to see how those data work,
Что ж, сказано, сделано,
what
давайте
can be
мы
substituted, and so forth.
научимся это делать. Поговорим и
Now
про
let's learn
фишхук.
how to do
Это
it.
специальная
Let's discuss
утилита,
the
которая
hashhook,
нам дает
which
возможность
is a
патчить
specialty
приложение
utility
вполне
allowing
удобно,
to patch
без
applications
jailbreak.
in a
Но прежде чем мы
user-friendly
говорим про сам
manner
фишхук,
and
давайте вспомним
without
вообще, в принципе, как у нас
jailbreak.
работают экспорты и что это
But
такое, и как они
before,
в
let's discuss
macOS
how
работают.
macOS exports work.
iOS, не суть важно. Вот, я
It can be Mac
написал
C
функцию, там
or
простейшую
IOC and so
сумму
forth. Let's
вот,
assume
сделал
I've written
default, то
a
есть вот объявил
simple
экспорт.
feature. I have
По итогу, по
declared
факту, это как
export,
работает? Из фреймворка 1 мы
and it will
хотим
work as follows.
вызвать
From
вот
framework 1,
сумм 2,3.
we need
Вот он указывает на
to
фреймворк
call
2.
the sum
Вот в соответствии с тем, что вот мы объявили вот
to
этот
3
атрибут.
to work
В
with
то
this
же
attribute.
время системные функции, которые именно вот в операционной, специфичные для операционной системы,
Speaking
например,
about
работа с
system
кейчейном,
functions,
работает абсолютно так же.
like those
Есть
for
security
keychain, they
framework,
work in
который,
the
вот,
same
например,
way.
содержит
We have our
security
security
функции.
framework
Там тоже есть вот свой
comprising
экспорт.
all the
Ну, вот, к
various
примеру,
security
всякая
features with
из
its
любой
own
вот
export
программы
and
мы
so
когда его хотим
forth.
вызвать, он также у нас ссылается
When we want to
на
call it from
вот
any application,
в
it will
памяти
refer
работающий вот этот вот, ну там по офсету вот security framework. Далее
to the
покажу.
memory-based offset or security framework.
Итак, пришло
I'm
время
going to show it
осветить
to you
тайну.
later.
Исходник процесс-логин вот этой функции, которую мы хукали, на
So
самом
this
деле вот
is
выглядел
our
примерно
source
вот так.
process login.
Смотрите, вот процесс-логин. Тут в двух
This is the way it
словах,
looked
чтобы не
like.
вдаваться в код, тут вот красным
These
блоком
are
происходит
our
какая-то некая
credentials.
работа с кейчейном.
Highlighted
Ну,
red
на самом деле не суть важно, как она работает.
is some
Суть
work
в том,
with
что
keychain.
результат у нас
We're
логин и
not
пароль просто
interested
кладется в
in
сам
its internals.
кейчейн. То есть он просто его
The
сохраняет.
username and password.
Опять же, это сделано для примера, конечно,
Go
так
to the
на практике
keychain
никто не
proper.
делает. Это вот в контексте вот
This is just an
обзора
example.
полезно.
Nobody does it like this. It's just an overview.
Теперь
make it
мы
plain and
чуть листаемся ниже в IDE Pro
Let's
и
scroll down
смотрим,
in
как
our
оно это
IDE Pro
выглядит. Вот синий блок —
to
это
see
формирование query. То
what
есть
it
вот
looks
сначала у
like.
нас query формировался,
Highlighted
потом идет
blue
вызов всякой
is our
Вот мы сначала сформировали
query
query, и вот
creation.
зелененьким это
So,
вызов
we
непосредственно
have come
самой
up
функции
with
всякой
our
item
query.
Давайте
And
у
highlighted
всех
green
item add посмотрим экспорт,
is
как он
our
выглядит.
item request. Let's see how the export
Вот мы дважды
looks.
кликаем на сек item add, видим вот
We double click on set
штуку.
item add.
Ну, опытный реверсер сразу видит, что это объявление
add.
экспорта.
An experienced reverser
Вот это
will
как раз
see that we
есть
have
объявление
declared
экспорта.
export.
Тут нету конкретных адресов в памяти, потому что они
We don't see any
динамически
specific
вычисляются. Ну, суть в том, что
addresses
вот
in the
PR
memory because they are
это
identified
инструкция ассемблера, которая
dynamically.
нас, безусловно,
And
перекидывает
this
на какой-то
is
адрес в
an
памяти.
instruction
Вот, и он как раз-таки
that
нас
switches
перекидывает
us
вот
to
на
some
определение всякой
memory-based
где он у нас
address.
есть в памяти. Ну, к
And
примеру, это вот такой
here
адрес,
we
я
are
вот с
with
головы
our
взял, вот его
SourceGraph.
написал, и он указывает на security
This
framework.
is just
С другой стороны, если мы это
made
посмотрим,
up
вот у нас есть
address.
наш исполняемый главный файл, и вот по вот этому
This
адресу
is
у нас
our
как раз-таки
executable.
вызывается наш security
And
framework.
this is the
Хорошо,
address
давайте,
used
допустим,
to
наша
call
задача
our
сейчас
security
это впихнуть
framework.
всякое item,
Let's
чтобы
assume
перехватить вот этот самый логин и пароль, вот эти данные, которые там
objective is to
прилетают.
intercept the
Смотрите,
user
какая
ID
есть
and
одна
the
очень
password.
интересная идея. А давайте попробуем
There is an interesting idea
внедрить
that I'd
свою
like
библиотеку
to
вообще во весь
show to you.
процесс. То есть мы
Let's
с нуля
try
напишем там
to
какую-то ну,
insert
простейшую.
in our library.
Вот, она будет называться там
We may have a
myInjected
simple library.
Мы там объявим
It may
тоже
be
такую
called
же функцию по
myInject
сигнатуре, как sec item add, и на экспорте мы подменим адрес таким образом, чтобы у нас вызывалась не security framework sec item add, а наша пользовательская реализация из нашей собственной библиотеки.
Own implementation, our own library
Выглядит
rather than the
это
system
по
library.
итогу примерно так. В рантайме вот тут уже будет
This is
другой
the way
адрес.
it will look.
На нашу
In the
реализацию
runtime,
он
we'll
будет
see a
прыгать
different
по итогу
address.
исполнения программы. То
In
есть на
our
хук.
address, in our implementation, sorry, it will be
И
switching.
вот, если подытожить, вот был адрес такой,
To summarize,
розовым
we
указан,
had
оригинальный стал
this address
другой.
initially. This is the
Что ж, а
original
вот теперь
address
пришло время
highlighted rows.
поговорить конкретно про
pink.
сам фишхук.
And this
Это
is our
библиотека,
substitute address. Now
так как я
to
ранее
the
сказал,
fishhook
которая
itself.
подменяет в рантайме
As
вот
I
эти
said,
экспорты.
It's a library
Сейчас мы
that
попробуем ей
replaces
воспользоваться.
those
В
exports
коде
in the
создаем
runtime.
новый
Let's try
проект,
to use
вот
it.
просто
Let's
выбираем
create a
фреймворк,
new project, we
Затем
select
с гита
framework.
качаем сам фишхук, вот просто я его тут
We
закопировал в эти файлы.
download the fish
Вот,
hook from
и потом
GitHub,
идут две очень важные сущности
copy
вообще,
it,
вот, в контексте всей
and we
работы.
see
Первое, вот
two
MyConstructor,
important
это
entities here. This
конструктор
is
нашей
my
динамической
construct,
библиотеки, который
which is our
вызывается
dynamic
немедленно при
library
загрузке
construct,
вообще всей программы в
which is
память.
called immediately
И
when
здесь мы ставим
the program
специальную
is
структуру,
loaded
называется
in the
repeating array,
memory.
в которой мы
And
указываем,
this is our repeating
что мы
array,
подменяем. В данном случае мы
a
подменяем
special
функцию с
structure
названием всякая
indicating what is going to replace what.
который вот прописан вот здесь.
And
Вот.
this is what we're
В
doing.
хуке
This is
пока
our
что мы
hook.
просто логируем данные,
In the
то есть
hook,
смотрим,
we
точнее,
just
не логируем
log the
данные, а
data.
просто
At this
логируем,
point
что
in
оно
time,
зашло, чтобы убедиться, во-первых, что много не
we
крашилось,
log
и
the
как бы, что
fact
логика
that
работы
it's
программы
been
не
inserted.
изменилась.
The
Мы
logic
билдим вот этот наш
is
тулит,
still the same. The
библиотеку.
program has not been changed. We build
Вот мы его забилдили, мы его берем
our release,
и прокидываем, создаем папку
and now
framework, это
we create
разархивированная
framework
ипашка.
folder,
Вот мы его туда прокидываем,
which
и потом с помощью
is
специальной
our
утилиты мы в таблицу
the archive
загрузки
API,
прописываем, что она у нас обязательно должна
and we
вызываться.
specify
Вот,
in the
соответственно,
utilities
поэтому без
that
краш
it
оно
must be called.
в процесс ее заинъектит, как бы, и оно заработает.
The
Всё
process
обратно
is going
компрессим
to inject it,
ипашку.
and it will work out.
Вот, сначала в zip,
Then we
потом в IPA.
compress
И потом тоже с помощью специальной
using first zip
утилиты
and then
удобной,
IP,
ну, либо можно через
RIP and
Gbox, как
done.
я ранее говорил.
We
Просто
can also
ставим на
use
iPhone
Gbox,
эту
as I
ипашку.
mentioned before. And then we install this API on our iPhone.
Все, запускаем приложение. И
And
что мы
here
видим?
we are, we
Что
launch
вот,
our
когда мы
app, and
вводим
what we see.
какие-то данные, вот нашу форму, у нас в
When
консоли
certain data are entered in the form,
вываливаются логи, что оно работает.
the
Супер.
logs are displayed in the console saying
Теперь
that
мы
it works.
попробуем, возвращаемся обратно к
Great.
хуку, уже
Now, let's get back to the
залогировать
hook.
сами данные, которые там пролетают.
To log the data proper.
Вот зеленый блок — это просто разворачивание квайри в обратную
Highlighted
сторону. То есть
green
тогда мы его запаковывали, сейчас распаковываем. И
about
красный блок —
reversing
это
our
уже
query.
лог самого юзернейма и
And
паспорта.
highlighted red
Билдим, там
is
все
the
собираем,
log
все то
of
же
the
самое,
username and
запускаем
password.
приложение и видим,
We
что
see the
вот
same in the
мы
build,
вводим
we launch the
данные, и
app,
они у нас
and we
успешно
see that the
проскакивают.
data are
консоль.
displayed and they work out. We can
Супер,
see it on the
да.
console.
И сразу кейс
cool.
злоумышленника, например, что он с этим может сделать? Он может взять ипашку, например,
What
банковскую,
can
ее запатчить,
a
оттуда
malefactor do
собрать весь
about it?
кейчейн, там в любые логи, куки, там сессии,
They
файлы,
can
и там на
actually
какую-то
manifest the
опишку это
keychain
все
with all the
отсылать.
files
Ну,
involved
эту саму
and send it
ипашку
to some
ставить
IP address.
там, через, например,
While
сайт-логин
the IP
какой-нибудь.
will
Ну, про
be
это я еще позже
inserted
расскажу.
using some other mechanism that I'm going to
Так,
touch
идем
upon a
дальше.
bit
С
later.
стомами мы разобрались.
Let's
Это
move
был
on.
самый простой способ
We are done with
хукинга.
the basics.
Вот, но
So
одними
far,
CI-шными функциями
has
обычными у
been
нас не ограничивается
a very
работа,
simple
потому что в
hooking
основном
method.
приходится
But we do
хукать
not confine
Objective-C
ourselves to
методы
this. We
и
need
свифтовые
to
методы.
hook
И сейчас мы как раз
Objective-C
с этим будем
methods and
разбираться.
some other
Начнем с
methods. And this is
Objective-C
exactly
хукинга.
what we're going to discuss now.
Как же мы
And
можем
let's
это
begin
сделать?
with
Давайте сразу, опять же,
Objective-C
практический пример.
method.
Допустим,
And I'll
вот в
give you a very
приложении я сделал
specific
простейший антифрод,
example.
чтобы, например, у меня авторегу типа не писали по параметру IDFV. Если что, IDFV — это уникальный параметр разработчика приложения. То есть он будет уникальным
This is
там,
a
для
unique
каждого
parameter
разработчика. По
of
нему
the
можно
vendors. It's going to be
идентифицировать
unique
уникальность
for any
юзера.
vendor, and you can identify the uniqueness of the user.
Вот мы, соответственно, его прописали, там же на сервер его, допустим,
we wrote
отправляем.
it on the
Вот,
server,
и,
we send it to
допустим,
the
наша
server.
задача подменить этот IDFV.
And, for
Так,
example,
слово,
our
как
task is
IDFV сам у
to
нас
substitute this
вообще в
IDF.
коде пишется. По сути, неважно, мы
So
на
how it
Swift,
is written
например,
in the
написали
code.
его получение,
So
или
no
на
matter where you write it,
Objective-C,
in
в данном
Swift
случае,
or
на
in Objective-C,
написано. По итогу,
in
весь
this,
код, который мы
here it's
пишем,
written
почти
Swift,
весь код, 90% кода,
any
он
code,
транслируется в
90% of the
Objective-C
code
структуры.
is translated into the
В
C
дизассемблере
structures.
это можно особенно
In
заметить
disassembler,
по
you can actually
следующему
see it
параметру, что есть вот
quite well.
последний блок,
And
у нас
here's the parameter.
вызывается
There is
Objective-C
a
MSG Send
last block that is
и вот
Objective-C
Fly UI Device Current Device, и потом вот Identifier for Vendor,
device,
это
now
как раз таки
device,
есть
and identifier of
IDFV.
the vendor.
Обратите
This is
внимание на
IDF.
функцию Objective-C
V.
MSG Send. Что
Look at
это
the function
такое?
Objective-C
Это у нас динамический
function.
отправщик
This is
сообщений
a
Objective-C.
dynamic
То есть весь
sender
код, который мы на
of
Objective-C
messages
пишем,
Objective-C.
по
Everything
итогу
that we write
вот
on
таким образом
Objective-C
транслируется, что у нас единственная
So
функция Objective-C
is
вызывает
the only function of
определенные
Objective-C
методы, который к ней
It's
приходит.
called using special methods.
Вот сигнатура у этой функции, вот
Signature
примерно
of
такая.
this
Первый
feature
параметр
is
это
like
у
this.
нас
First parameter
self, это указатель на объект,
is
к которому
self.
отправляется сообщение.
This is indicating the
Затем
object that the
селектор,
message
то
is sent
есть
to.
метод, да,
Then
и дополнительные
selector
аргументы,
is
вот
the
если у
method,
нас метод требует получения
additional
аргументов.
arguments if
Ну
the
и
method
казалось бы,
needs additional
а
arguments.
давайте хукнем вот вообще вот этот весь
And it
Objective-C,
seems like
мы сказали
let's hook
единственную
the
функцию,
whole
чтобы
this
вообще перехватывать
Objective-C
все функции
to intercept
Objective-C.
any features of
Увы,
Objective-C.
но штатным фишхуком так
Alas,
сделать не выйдет. По той
But
причине,
the common thing can be done
что
like
сейчас
that.
я объясню, то есть вот мы поставили
Let me
ребиндинг,
explain it
казалось
to
бы, да,
you.
прописали
So we
такую же
put here
сигнатуру
repeating,
функции, но
and
оно
we had
закрашится
the
и не
same
будет
signature of
работать.
the function,
Объясняю почему.
but
В
it's not going to
предыдущем
work. I'll
хуке,
tell
вот
you
где был
why.
stack item map,
In
мы
the previous
хукали
hook,
самую, то есть stack item
we
map это самая
hooked
обычная сишная функция по сигнатуре.
stack item
Там
add,
стандартное
it's a
соглашение
simple
о
function in
вызовах.
signature.
И фишхук
It's a
с этим умеет
standard
работать. Давайте поясню, что такое вообще соглашение о
Fishhook knows how
вызовах.
to work with
Это
this.
у нас то, как в регистры передаются все параметры. Вот,
This is how in registries we transfer all
ARM64,
parameters.
NX86, она, в принципе, похожа.
NX86
у нас
and the
приходят
default in the registry.
аргументы, и
We have
результат
arguments.
исполнения функции это x0.
And the result of it is x0.
Вот самый простой пример, я написал функцию,
And a simple example is,
строки,
here is the function of
hello world.
concat
Вызываю
of the
функцию, вот в
string.
диsassembler примерно так оно выглядит, что
I
в x0 мы
call the
кладем
function in disassembler.
указательную
In
строку hello,
x0
в x1
we
world.
had a hello and
Вызываем
x1
конкатенацию
world.
строка, вот x0
Then we
из
call
x0
the strings
забираем
and
результат.
x0 we get the result.
Вот, но у Objective-C есть такая,
Objective-C,
есть такая особенность, что функция
there is
передается
this
переменное количество аргументов, вот
specificity.
эти самые три точки в
The
конце.
function can
Это
transfer only
структура называется
certain number of
valist.
arguments, and the
И
structure is called
фишхук
VA
с этим из
list.
коробки, к сожалению, не работает.
And
Вот, а я
sadly,
напомню,
fishhook
вот эти
doesn't
три
work
точки и ту самую
from the
сигнатуру,
box.
которую мы писали. Вот, оно крашится,
The
но не
same
будет
signature that
работать.
we wrote,
Но это
3
не
points,
проблема.
3
Мы
dots,
все равно
and it's not
можем
going to work.
ее
So,
захукать,
but it's not a
но
problem.
тут
We
будет
can
чуть
hook it
сложнее,
anyway,
сейчас увидите.
but it's going to be a
Во-первых,
bit more
ребиндинг
complicated.
ставим
First
точно
of
так
all,
же, Objective-C
rebinding.
send, строчкой
We put
прописываем
here
и объявляем хук.
Objective-C,
И
and
сейчас,
we
прошу не пугаться, хук выглядит
hook
у
here
нас вот
hook,
так вот.
and the hook looks like this, so don't be
Тут
scared
вы
by
можете
this.
видеть ассемблерные ставки какие-то
So you
страшные.
can see some
Вот я
assembler
не буду сейчас в подробностях
points
объяснять, как
here,
это
some
работает,
scary
да это в
ones. I'm not
принципе не
going to
надо.
explain it to you how it's going to
Суть
work.
писать все эти хуки, патчи, разобравшись, давайте
topic,
попробуем снять SSL-пининг.
managed to write all these hooks and patches. Now
Снимание
let's
SSL-пининга
look
обычно
at
нужно
SSL
для того, чтобы API-шку с приложения достать.
Usually you needed to get the IP from
Во-первых,
the
напомню, что это такое
application.
SSL-пининг.
First of
Это
all,
хардкодинг
SSL
сертификата
pinning, this is
сервера
hard coding
в
of the
приложение.
certificate of the
Таким
server
образом,
in the app.
это защищает нас от митом-атак.
Thus,
Человек
you can
посередине.
protect yourself from
Даже если мы на телефоне
MITM
доверим вот этот
attacks.
самый сертификат
And even
и
if on the
прокинем
phone
трафик
you
как-нибудь там,
trust
или
the
хакер его
certificate
там
and you will be able
прокинет
to
через
put
сервер,
the traffic through, or hacker will
приложение
be
элементарно откажется
able to
работать,
put it
потому что он
through the
видит,
server
что
and the app won't work
сертификат не тот.
because it'll see that the certificate is not the right one.
Пример приложения без SSL-пининга. Вот мы
So
его
now,
просто открываем,
an
прокидываем
example of the
трафик,
app
и у нас
without
весь
SSL
трафик
pinning.
улетает в
So we here
Group
there, we
И тут
put
нет
there, and
никакой
all
защиты.
traffic will go to group
Это
suite,
проблема,
and it's not,
но
we don't have
в
any
качестве
protection
примера,
there.
в
So that's
принципе, вот
problem.
понятно, что
Like
там
giving you
есть
as an
куча
example,
всяких
so you
запросов, мы там можем по
clear there are
приложению
many
передвигаться
queries
и
there in order to
видеть
go through the
данные.
app and to see all the
Но
data. It'll
рассмотрим
take
уже
time.
ситуацию, когда
So
SSL-пининг висит. Просто так, если мы откроем Group Suite
let's see
и
if
приложение
SSL
туда
pinning
пустим
is already
трафик, у нас
there, and
трафик
if
не
you
пройдет.
open
По той причине, ну что, у нас
the app with the unit,
сертификат захардкожен, мы
and
там
the
вообще ничего
traffic
не увидим.
will
Обычно
not
на
go.
iOS
You
снять
won't be able to
пининг
see anything.
обычно
Usually
помогает
on iOS
функции
to
Sec
get
Trustful.
rid of
Это
SSL
системная
pinning, so
C-функция, хукается самым
Sec Trust
обычным
Evaluate can be
способом, вот
hooked, and
самым
it
первым,
can be
которым мы
easily
рассматривали.
hooked with the
И тут
simple
просто
way that we just
константное
looked
значение
in the
мы
beginning.
переписываем на то,
And we
что
have a
там все успешно,
constant value
грубо
here.
говоря.
We just get the message that everything was written successfully.
SSL Kill Switch 3 — это в открытом доступе есть специальная динамическая библиотека, в которой
Switch 3,
помимо вот
they have a
прошлого
dynamic
хука,
library that
там
besides
еще
the
куча
previous
других
hook,
хуков на все
it
случаи
has many other
жизни.
ones
Так,
for any
вот тот самый хук,
type
который до
of
этого был, и там еще куча
need.
других хуков. Если вы просто заинъектите вот этот
There are piles of these hooks there, so if you
open-source библиотеку, пининг, скорее всего,
inject this open source library, so and the
еще
pinning
как вариант
will get to
это
you.
тоже
Another
есть в
way
открытом
to do
доступе.
that, you can also find it in the open source.
Fire — это специальная
Hook
библиотека
for
запроса.
Fire.
Тоже хукается, там
This is special
специальный
library
метод.
for
Либо как
queries
вариант
what you can hook.
можно формирование
Or
всех диктов, то есть
another
перед запросами
variant
же
is
формируется дикт, чтобы его отправить. Можно тоже
when
их
you
перехватывать, в
generate all
консоль
the
логировать и
dicts,
смотреть, что там
you can
прилетает.
intercept them in the console of
И мой
logging, and you
авторский
can see
способ
what
по
got to
снятию
you.
пининга.
My
Обычно в
own
приложениях
way
есть
of
отладочные
removing the
символы.
pinning,
Это
usually in
включен ли
apps,
дебаг
you
режим,
have
например,
special
включен ли
symbols
продакшн
on a
мод,
debug
включен ли
mode and
пининг.
production
Вот,
mode
и мы
or
просто
special
находим
pinning
эту
mode.
переменную где-то
So you
в
can just
реверсах,
find
там
this
ищем,
variable in
и
reversals
пулевый
and
return, там с false, например,
and
точнее с
pull a
true
return
подменяем
with
на false, то есть
false.
пининг
You
включен
can
ли. Было true, то есть единичка, мы
it was
подменили на
true
0,
or
все, он
false,
выключен,
so
мы сразу
you
видим трафик,
switch
и
from
ничего
0
нам
to
больше
1, and you
делать
can
не
immediately
надо.
see traffic. You don't need to do anything else there.
Таким образом, вообще в абсолютно любом приложении
So in
пининг
any
обычно
app,
снимается без каких-либо
pinning
проблем.
usually can be removed without any problem.
Не отходя далеко от темы пининга и трафика, давайте
Not going
теперь
far from
посмотрим,
pinning
что
and
мы
traffic
можем
topic.
делать с самой
Let's see
API-шкой,
what we
когда у
can
нас
do
есть
with
API-шка.
the API itself. When we have an API.
Так, во-первых, как нам получить саму API-шку, методы
Well,
сервера?
first of all, how to get the
Самый простой
API, the
способ
methods of
это
the
вот как
server.
раз-таки снять
The
пининг,
easiest
открыть
way
трафик
is to
и
remove
в Boot
pinning,
Suite посмотреть все
open
запросы,
traffic and the Boot
все
Suite
запросы, все
to see
методы.
all
Вот,
the
когда мы в приложении
queries
сидим, там
and
ленту
all the
обновляем,
methods.
ну, что бы то ни было. Вот
Usually
мы
when you're
собираем
in the
трафик.
app, when you're
Теперь
updating
очень
your
интересный
feed,
момент.
and that's how you collect
Смотрите,
traffic. So,
на
interesting
этапе
point.
разработки приложения обычно используют
At the
OpenAPI-генератор. То
development
есть там
stage of
есть
API, they use
spec-YAML,
API
который
generator. So there's
описывает
spec-YAML
карту
that
API-шки.
describes
Вот,
the
оно
map
подается в
of
OpenAPI-генератор, ну, например,
So it goes to
SwiftOpenAPI-генератор.
OpenAPI
Это
generator.
преобразуется у нас в код, то есть в клиента
So it is
на Swift. И потом,
transformed
уже когда
into
мы
code
компилим приложение, это
on the
все
Swift, and
преобразуется
then
у нас в
we
машинный код.
compiling
Что
the
интересно,
app,
что
it
с машинного кода
goes
тот или иной метод.
all
Ну, например, там, если
AIPs,
юзер
and for
постоянно
example, what user
апдейтит
calls
ленту,
which
ищет
method.
много новых,
So, for
как бы,
example,
там,
users
юзеров
updates
контакты, там
the
общие
feed
контакты,
and they're
и
looking
прям
for
аномальная активность, то, скорее всего, это
users
бот.
and the common
В среднем по палате там
contacts.
значение должно быть примерно
They can be
одинаково, но
anomaly in their
аномальная
behavior.
активность — это, скорее всего, боты, и на них стоит
And when
обратить
there's an
внимание.
anomaly in
Ну и на этом
activities, and you
все.
have to pay
Всех
attention to
благодарю за
those bots.
внимание.
So that's it. Thank
Готов
you very
ответить
much.
на ваши вопросы.
I'm ready to answer your questions.
Не стесняемся, задаем вопросы.
Don't be shy. Ask your questions.
Спасибо за доклад. Ты говорил, что
Thank you
есть
for your
в jailbreak на
presentation. You said that in jailbreak on the iPhone, there is such app as App Store++.
А позволит ли оно скачать как раз как вредоносное приложение? Ты говорил распространение через сайт-лоадинг, что там банк при устанавливании устанавливает свое приложение и что-то подобное. И
like
есть ли
banking
такой вектор
application
атаки,
something.
такие вот
So is there such a
именно
vector of attack
jailbreakнутые App Store, то есть
like
магазины приложений?
broken
Да,
app
спасибо за
stores?
вопрос. Смотри,
Thank you for the
любой
question.
jailbreakнутый телефон, он уже заведомо у тебя
Phone that
небезопасен.
was
То есть,
jailbroken,
если,
it's
например,
already
гоняешь с айфоном, нельзя
unsecure.
туда ставить jailbreak, если это твой
So,
основной телефон, потому что там есть элементарно какие-то
If
простейшие
it's
атаки на
your main
браузер. Ты,
phone,
например,
so
зашел в
don't
браузер,
install jailbreak.
там
So
есть
they're
специальный
like
скрипт,
elementary
который
attacks.
Safari
So you get
эксплуатирует,
special
там
script
сразу он видит, что
that
jailbreak, и
Safari
все, он у тебя уже как бы
exploits,
сразу на телефон
and you can
payload
see the
отправляет, и все, как
jailbreak,
бы ты
so
заражен.
it sends
Поэтому,
payload to you, and it's going to be
если у тебя
infected.
jail стоит, то
So if you have
знаешь,
jailbreak,
заведомо у
then
тебя там вирусня стоит, поэтому это вот его можно
so
использовать только
you
в
may think
контексте
that by
рабочего
default
телефона,
there
как
is a
бы вот
virus
для
there. You can use it in the
исследований.
context as like a working
Если же
phone
мы
for
говорим не
your
jailbreak, ну как бы у нас там и App Store++
investigation, so to
нету.
speak, or
Если
like
говорим с App
your
Store++, как бы все, что нам позволяет,
if
это нам позволяет
App Store++,
задаунгрейдить
what it
приложение
helps you to
из
do,
самого App
it
Store.
helps
То есть
you
все
to
версии, что там предыдущие,
downgrade
они
the
как бы тоже
applications
хранятся в
from
App Store,
App
вряд ли там
Store.
будет
So all the
вирусня.
versions that
А в целом
existed,
в таких
they are on
магазинах
App
есть
Store.
какая-то
In
проверка
such
там,
stores, is there
вообще
any
надежности приложения,
checkup
какой-то рейтинг и бан вот таких вот
how
заведомо
reliable
вредоносных или
the
нет?
apps can be,
Смотри,
and
в App
if
Store
they can
есть, но
see
App Store,
if in App Stores they
разумеется,
have
да.
that.
А в других, ну, конечно же,
In
нет, например,
others,
Cydia.
Of course not.
Ну
In
зачем там
CD,
какую-то проверку, это как бы
why would they do
открытая
any
платформа, там
checkup?
кто-то один твик
It's a
написал,
public
кто-то там
platform,
написал
so
твик,
one wrote one tweak, and
который
some
там
people
полностью дизайн
would
телефона
tweak.
меняет, там как бы, ну и нет
It
смысла
changes
проверять,
design of the
как бы, ну,
phone,
вредонос или не
so there's no
вредонос.
point
Понял,
to
спасибо.
check if
Вот
it's
там нужно как
malware or
раз-таки
not.
заведомо считать,
Thank
что это
you.
вредонос,
So
и
you
на этот
need to by
телефон ни в коем
default
случае
think
не
that it's
ставить
a
ни
malware,
криптокошельки, там,
and
ни
you
соцсети,
shouldn't
ну никуда не заходить, только вот как
install
рабочий
any
телефон
crypto
его
wallets
использовать.
and to go into social media. You can use
Спасибо
it
за
only as a
вопрос.
working phone. Thank
Привет,
you for the
слушай,
question.
вопрос такой, что в твоем понимании, как различается rootful и rootless jailbreak?
What's the difference between
Дополнение у тебя на
rootful
слайде
and
говорится о том,
rootjam?
что rootless это до 15 iOS,
In
это
your
неправда,
presentation, you
до
you say
16
that
включительно на
up to
iPhone
15 it's
10
not
и
true,
далее,
up to
и
16
на
it's only
iPad,
true
насколько я помню,
for
7 это
iPhones
iOS 17 на
10
сегодняшний
and
момент.
iPad with iOS
Возможно, я
17 as of
ошибся.
today.
Действительно,
Well,
rootful
probably
это
I
полный
made a
jailbreak,
mistake.
он до 15
You're
включительно.
right. Rootful
Все,
is
что выше, это
full-fledged
уже есть
jailbreak,
rootless.
which
Отличие
works
заключается в
with
том, что в
iOS
rootless,
15
например, ты не можешь
plus. The difference is that with rootless,
изменить файлы системы,
you cannot
которые
modify the file
системы
system.
хранятся. Ты можешь только влиять на сами приложения, то есть внутри контейнера приложений, ну, аналог на Android Data, вот внутри ты там можешь копаться, а в каких-то системных
Within the
функциях там
container, you can do things.
смотреть, например,
However, when it
keychain
comes to
тоже
system
общий вещь,
features,
который для системы ты не можешь.
for example,
Вот, в
the
этом заключается
keychain
отличие.
is
Именно
shared,
поэтому в докладе мы
and
рассматривали
you cannot
rootful,
do anything for
чтобы
it.
ну вот посмотреть
That's
keychain,
why
например, да,
we
понять, как он у нас
consider
работает. Фрида тоже, кстати, не работает на
For
rootless, она
example,
только
to understand
на rootful работает, потому что Фрида, она дергает именно
it
системные
works.
функции, которые в
Frida
rootless
doesn't
режиме
work with it
недоступны.
either. It can only work with
Смотри,
the
я тебе
system
очень
features.
советую открыть интернет и почитать, что такое
I
Polyrain.
highly
У него
recommend
есть режим
that
rootful.
you go
Я
to the
согласен, что
internet
это
and
не
read
полный
about
rootful, у
Polyrain.
тебя не сохраняется он после
I
перезагрузки,
understand it's
но
not
там есть
complete
доступ до
rootful, it's
системных
not
функций, и
safe.
он поддерживает все
And
вплоть до
after
iOS
downloading,
16
however,
максимальный.
it
Спасибо
supports
за доклад.
everything all the way up
Спасибо
to
за вопрос, я
iOS
обязательно
16
посмотрю.
full
Я
version.
сам
Thank you for
мониторил,
your
смотрел,
presentation.
но, к сожалению, такого не
Thank you
нашел.
very much. I appreciate your hint. I will Google for it for sure.
Микрофона, да. Левее.
Так, да-да-да.
Да, приветствую. Вопрос такой. Подскажи, как для человека, ну, не глубоко погруженного в тему вопроса, как проверить наличие в приложении SL
a really savvy individual. How can we check pinnings?
Вопрос со стороны разработчика или со стороны клиента, исследователя?
Are you interested from the perspective of a developer or researcher?
Людей, которые управляют инфраструктурой и ставят приложение на устройство компании.
Who manages infrastructure and installs applications?
Например, есть какая-то корпоративная сеть, там люди ставят приложение, им нужно удостовериться, что там есть пининг, чтобы в случае чего там их не поломали.
People deploy applications on it, and they need to make sure that they cannot be broken.
В принципе, такой вариант, как бы вполне понятный. Это прокинуть трафик через BookTuit, установить BookTuit'овский сертификат, то есть телефону полностью доверить этот сертификат и посмотреть, как бы трафик улетает в BookTuit, работает ли приложение исправно или нет. Если оно не работает исправно, то там висит SSL-пининг. Если весь трафик улетает и как бы ничего не изменилось, то там нет SSL-пининга. Вот, например, таким образом можно проверить. Это самый подлинный, как бы понятный способ. Ну, точный способ.
It's a pretty clear
как бы ты симулируешь, что ты как бы некий злоумышленник, что вот ты вот
сертификат там поставил, you pretend being a malefactor.
Ну, вот, например, он пошел, значит небезопасно. Если он не пошел, значит безопасно.
If your traffic is let through or not. If it is, you are not secure. Otherwise, you are protected.
Как сейчас актуально оплачивать сертификат разработчика? Для России же закрыта оплата.
How can certificates be paid for developers? Payments are closed for Russia, as far as I know. As far as I remember, you can do it through Apple Pay or via mobile operator. In my case, this option was not available. You would download an Apple Dev app, and you need to be able to pay via your mobile provider. In my case, this feature was not available. A friend of mine got access to it, however, he got no subscription. I paid $300 to a guy who had a registered Apple account. There's another trick. There may be someone in Europe, and you can use this person's account to pay the amount you need, say $100. Don't try to do it in Russia. You'll just waste time. Another important point as to Apple certificates. As you may remember, permissions were issued for Apple phones. For a new account starting from 2022, the first two UIDs will be getting their certificates momentarily, where the other 90 will require up to 3 days to be certified. For instance, if you need to deploy a farm comprising 100 phones, you will probably need to find some old existing Apple account to download all the certificates at a time. Otherwise, of course, you can use a new account. However, after number 10, you will need to wait for about 3 or 4 days. Thank you, and thank you for your question.
Есть еще вопросы?
Any more questions?
Так, ну тогда всех благодарю за внимание.
Alrighty. Since there are no more questions, thank you everyone for having me with my presentation.
Вот, к тем, кто хочет пообщаться,
And
подходите. Я сейчас вам...
I'd kind of ask the organizers to help me with those wires.
Все.
And should you have any more questions, feel free to approach me offline.
Test. Test. All right. Welcome back to our presentation.
Ну что ж, добро пожаловать на нашу презентацию. Поговорим о итерациях на границе. Меня зовут Лули, и я исследователь, который занимается безопасностью в среде Java. А это мой партнер Хошин. Он является исследователем в области безопасности в облаке, в средах Kubernetes и так далее. И Ван Ли также нам помогал, это старший инженер по безопасности в нашей компании. Я хочу рассказать вам о наших исследованиях. Когда мы начинали, я не очень много знал о ядре Linux. Это было достаточно странно. Вы можете удивиться, почему я занялся этими исследованиями. Я занимался аудитом кода для самых разных приложений, написанных на самых разных языках, включая Java, PHP, JavaScript и так далее. И в прошлом году я решил, что пришло время заняться чем-то более сложным. Это вот программа моего выступления. Мы начнем с мотивации, с того, что стояло за этим исследованием, с базовых идей. После этого мы поговорим о основах OOB и B-кэшецах. Рассмотрим ряд конкретных примеров. И в конце концов подведем итог, сделаем определенные выводы.
First, we are more familiar with file systems in our daily work. Second, most of file systems run in OS kernel, so bugs in these file systems may cause devastating errors. And third, take a look at this figure. We take XFS as an example. New features means more code, so more new code means a great chance of fighting bugs. But what about the real possibility? Before we started, we reviewed commits in file systems and found that bugs still existing in many famous file systems in the past year, such as AST4, BTRFS, and NTFS3, and we think it's possible. So where to begin? We started 3 previous works, and the second and third are both based on the first one. The first work is fuzzing file systems via 2-dimensional input space exploration, which released a fuzzer called Janus. The 2-dimensional input space here are disk image and file operations, while mutating sequence of file operations is relatively easy. But a disk image is a large binary blob that is structured and complicated, and existing fuzzers mutate only non-zero chunks in the image. However, mutating metadata blocks is more effective than mutating data blocks, but fuzzers do not have any knowledge about image layout and also fail to fix any metadata checksums. So Janus implemented metadata parsers for different file systems and found many bugs that can be triggered by mail phone images. So for this reason, we think metadata in disk image is still a vulnerable attack surface. Yeah, then I will hand over to Guoxing, and he will introduce the metadata that we focus on and detail the first out-of-bounds bug we discovered. Okay, I will continue to walk through the metadata 101 and how we discovered the first out-of-bounds bug in Bcache-FS. So what is metadata? If we think of hard drive as a library, the metadata plays the role of recording the number of bookshelves, the location and category of each book, and even information for disaster recovery. In short, metadata is used to describe and manage file systems, but it doesn't include the content of files. Let's focus on 4 types of our related metadata: sweep block, log record, directory entry, and XTTR. So first, sweep block.
It's like control center for file systems. The primary superblock resides at a fixed location, and copies are stored at different locations for redundancy and recovery. You can locate these superblocks using a specific magic number, and superblock records variable information about file systems, such as sector size, block size, and some information about inode, like size, counts, and the root inode number, and so on. And then to recall file operations, we need log records. Log records are used by transaction logging to provide crash recovery capability. A record typically contains members such as operation type, transaction ID, associated inode number, and time. To describe different operations, the size of each record is variable. So log record table looks an array of various sized elements. Each element contains a record length member that indicates the size of its variable part. The next one is direct entry. When you run ls command to view the content of a directory, what you are actually seeing comes from directory entry stored in the metadata. And the layout is similar to that of log records. It's quite easy to understand because file or directory names can vary in length. The size of each entry is also variable. And the last metadata type we will cover is XTTR. In addition to file permissions, owners, modification time, and other common file metadata, file system also supports extended attribute called XTTR. It looks like user-defined properties for file or directory. Look at this figure. We can use getFTTR command to list all XTTR file, or use setFTTR to set one. Now you may have noticed that all the metadata types we are discussing, except for block, follow a layout that looks like an array of variable size elements. The superblock usually doesn't follow this pattern, but there are some exceptions in some specific implementations. We'll go into more detail later, but for now, what's important to keep in mind is working with such arrays, we need to pay attention to boundary consistency issues. So now, if there is a bug in the metadata, it should be clear that we need to mount a crafted image to trigger it. Metadata parsing work happens during the mount process. Typically, the mount operation requires the cap system capability. However, there is an exception. A file system can declare itself safe use with URL space by using the FS URL space mount flag. But unfortunately, most file systems do not support this flag. By default, pocket rules in the latest Ubuntu allows user with an active local station to mount an image. So it's true that desktop or even server environment allow regular non-privileged user to mount and auto-mount file systems. All right, all of that covers the foundational knowledge you need to understand what we will be discussing next. And I will talk about an OOB in Bcache, which is our first bug. So why did we choose Bcache FS as our first target? Well, it was contribute to the Linux 6.7 and the end of October 2023. It's quite new and complex file systems, which make it a great candidate for us to discover something interesting in the metadata. This OOB bug occurs in the superblock. As we mentioned earlier, we can use a magic number to locate the primary superblock and its copies. The implementation of this block is defined as a structure called BCHSB. Unlike other file systems, this block is split into two parts, a fixed part and a variable part. It uses the flexible array member to describe the variable part. The size of output gives the size of the structure as if the flex array member were empty. So it's common to use a fixed member to indicate the size of variable part for the allocation. For simplicity, we call this member length 1. The variable part of the sweep block contains many fields of different types. Each field starts with a common structure called BCHSB field. We can use container of micro to get the actual field. The BCHSB field also has a variable part, and the size member, we called it length 2. So now we have two length members. The first one is length 1, which is used to calculate the total size of entire sweep block. And the second one is length 2. It's used to calculate the size of a single field. The actual field we focus is the clean field, corresponds to a BCHSB field clean structure. Again, this structure has a variable part which contains an array of G-sides, a G-side entry. Now take a look at the definition of the G-side entry. Familiarize a variable part and the size member, we call it length 3. So far, the layout might be a little bit complicated because this implementation makes heavy use of flexible arrays. One of the nerds. Here's an overview. We have left out the less important part and we only focus on the variable part and each level. There are 3 nettest levels. The first is entire sweep block. The second is an array of fields, and the third is an array of entries in the clean field. As we can see, if the clean field happens to be the end of the field, the iteration at every level will end at the same point, which is the end of the sweep block. Actually, there are 4 nettest levels in total. The first level is the array of keys in each entry. And it's important to do boundary check during iteration at each level, so that all the ends line up correctly and there is no risk for an out-of-bounds bug. So let's dive into the iteration code. The function BCH2SB clean validate later. The function iterates through the entries in the clean field. It checks whether the start of each entry is within the memory range of the clean field. This condition is very common in for loops. Most people write it in this way. However, the key point is that it just checks the start of the entry. So we still need to do an extra boundary check before accessing the member of an entry. Next, the function journal entry B-tree keys validate will be called. This function iterates through all the keys in an entry. The where condition checks whether the start of each case reaches the end of the entry. During each iteration, it calls journal validate key function, which accesses the member of a key directly without any further checks, just like the previous function. Condition itself isn't the problem. When everything works as expected, all the conditions are satisfied and all the iteration ends normally. Now let's put 2 conditions together. These 4 levels end at the same point in memory, but here is the problem. It accesses a member of an entry or even a key without making sure there is enough space in the first place. So if the end of the last entry is not equal to the end of the clean field, accessing the last key in the entry probably leads to an out-of-bounds bug. But there are still 2 questions we need to figure out. The first one is, where is the memory boundary? In the function BCH2 read-through block clean, it calls kernel memory duplicate function to allocate the memory for each clean field and its parameter is length 2. So the clean field is location independent. If the allocation is based on the type level, and the location size is an entire sub block, and we need one more step to trigger this auto bounce bug, which is placing the clean field to the last position. The second thing we need to check is we need to figure out if there are any check functions. Right now, we didn't see any checks during iteration, but it's possible the check was already done before. And we focused a function, and we found a function called bch2sb clean validate. It only ensures there is not enough space for the fixed part of the clean field. That's it. So when we access the key in the last entry, it triggers out-of-bounds bug. And because of weird error handling, it ends up getting stuck in an infinite loop, like on local doors. Actually, we can also trigger this out-of-bounds on the last entry. It happens in another function. If you are interested, feel free to try building the POC yourself. Okay, let's summarize the 3 insights that can lead to this kind of out-of-bounds bug. So first, we need to determine the memory boundary. We must understand where the iteration occurs. In some cases, allocation might be based on the page size, and default the target layout isn't reached the end of the memory. So we need to place it in the right place. This could be why such bugs are difficult to find by fuzzers, because mutation often happen on the original layout. Second, we need to identify the array of variable size elements, which is vulnerable layout we focus on. And there may be a size consistency issue. Third, there is no check code during iteration. Or if there is, it's not fully considered. We will talk about this case later. All right, this is the first bug we found at the start, along with some key insights we learned from it. And I'm going to give the stage to my partner, Luli.
Thank you. Guoxin summarized 3 key insights from the first bug. And after that, we wanted to check whether other file systems might have similar issues. So we implemented image parsers for the specific layouts we were interested in and across different file systems. And finally, we discovered 14 bugs in 7 file systems, 13 of which have been fixed and assigned 10 CVEs. Based on the root causes, we categorized this out-of-bounds bug into 3 types. The first type is when there are no checks for layout we talked about before, and when existing checks can be bypassed. The second type is when a fixed size member is used to validate the variable part, but the code doesn't make sure that the fixed member itself is within the valid memory before accessing. The third type is the elements in such arrays use an offset member to locate a variable part, but the offset member is out of range. All right, here's an example of type 1 issue in BTRFS. We choose this one because it's different from other type 1 issues, and there are some ideas worth learning from. Okay, the B tree in BTRFS provides a generic way to store a variety of data types, such as inode files, cat directories, XATTRs, and more. The implementation of a leaf node is a structure called BTRFS leaf. It contains 2 members, a header and a fixable array member called items, which is an array of BTRFS items. As the code comments explain, a leaf node is divided into 2 parts, item area and data area. In between is unused free space. and each item contains an offset member that is used to locate its corresponding data in the data area. Take a look at this diagram. The header contains a member called NR items, which indicate the total number of items. Each item has 3 members: BTRFS disk key, offset, and size. Using offset and size, we can find corresponding data, and the type member in key indicates the data type. As you can see, the item area and the data area grow toward each other. So the first item corresponds to the last data, and this pattern continues for the rest. The type of data is determined by the type member in the key, with this design, a leaf node can store different kinds of data. Here are some examples, such as inode reference, dev item, and so on. But for now, we will focus on one specific type, BTRFS dir item. It represents a directory entry in BTRFS. So we know that for performance reasons and other factors, the size of memory allocation is not the same as the structure. In this case, the memory representation of a leaf node is called an extend buffer, or EBE for short. When the kernel needs to read or modify a leaf node, it first allocates an extend buffer, then reads the leaf node data from the disk image into that buffer. After that, access to the leaf node is done through the extend buffer. And all the corresponding access interfaces are defined in the file, accessors.h. Now for this layout, because the data area is at the end, so we can simply assume that the layout is already reached the end of the memory. And if there is an out-of-bounds bug in certain data area, we hope it's the last data, which is the data 0, so that it can trigger KSON report. Of course, this is only to ensure we can catch the bug. However, if the bug happens in the middle of the data area, we might still be able to use an out-of-bounds write primitive to modify the content of adjacent data, potentially leading other impact. The layout of BTRFS dir item is an array of variable size elements. This layout looks very similar to XATTRs because an XATTR is a key value pair. It has 2 length members, name length and data length, so it's clear that this kind of layout works well for XATTRs. And it also makes sense for directory entry. We can set data length to 0 and just use the name length to represent a file or directory. Next, let's look at the iteration in the function BTRFS match dir item name. This function goes through all the dir items, searching for one that matches the given name. The problem is there's no check to make sure that each dir item is within valid memory bounds. So let's try to build poke. First, as we mentioned earlier, to get a KSON report, we need to trigger this out-of-bounds at the end of extend buffer. That means we need to place our poke in the last data. We choose data 6 here, which contains the default dir item pointing to the root item. This way, the mount process will automatically parse that data without any file operations. Second, we only left 1 byte of memory for the last item, which isn't enough for it to be used. And then we need to modify the object ID. Because each item's ID must be smaller than the next one, we have to make sure they are in order. In addition, we update the root dir object ID in superblock, so it matches the object ID of the default dir item. Finally, we fix all the checksums. But unfortunately, we failed. The reason is that there's a check function called check leaf item before the iteration. This function checks all the types of data. You can see that when the data type is either XATTR item or dir item, it calls the same check function, check dir item, because their layout are very similar. After looking into this function, we realized that everything was already being checked. However, when we look at the caller BTRFS check leaf, we notice an interesting flag called written. In short, this condition was introduced in commit at the 2023. In debug case, there might be item data that isn't fully consistent yet. So this flag is used to identify whether the data is consistent. If we don't set this flag in the leaf header, it will skip the check. For now, this case no longer exists, but the code still does. So here's our final poke. We just need to remove the written flag from the header as one extra step. Now we can successfully mount a crafted image and trigger this out-of-bounds bug. All right, this is type 1 issue. There's a missing check both before and during the iteration over an array of variable size elements. Okay, next is an out-of-bounds bug in XFS, and this one is a type 2 issue. Let's dive straight into the key part. The layout of directory entry is a little bit different, and an entry can be either a data entry or an unused entry with just marks free space. And the size of both types of entries is variable. Directory entry can come in different formats. When the number of entries becomes large, it switches to the extends format. We won't go into too much detail here, but in simple terms, the existent format means multiple blocks are used for storage. So in this case, the memory boundary is defined at a block level. Okay, let's take a look at the iteration code in the function xfs dr3 data check. We can see that the condition looks similar to a type 1 issue. When accessing the free tag member in an unused entry, it can already trigger an out-of-bounds access. The difference is there is a check code. This check uses the length member to validate the total size of the entry, but it doesn't ensure the length member is valid. Although this case is also a type 1 issue. In some cases, this check logic will be the first thing done inside the loop. So we classify this as type 2 issue. And again, here is an out-of-bounds read. So a type 2 issue happens when the code uses a fixed length member to calculate the size of the variable part and then checks whether the entry is within valid memory. The problem is the fixed member itself isn't validated. It's a little bit better than a type 1 issue. The code does try to do some validation, but it just trusts the wrong thing. All right, the last case we'll look at is in NTFS3. And this one is an example of type 3 issue, which typically has a critical impact. First, let's talk about the log file. So what's it? The log file is used to store all metadata chains to the file system. It ensures that critical structures can be recovered after a system crash. The layout of log file is shown in this figure. Basically, it made up a series of pages. The first 2 pages are the restart page and its copy. They store basic information. And the remaining pages are used for log record, which we call log record page. The restart page has 2 members used to locate the valid range of the log, oldest LSN and restart LSN. An LSN is like an index for a record. From it, we can get both the record page number and the offset within that page. The oldest LSN points to the beginning of the valid log, and the restart LSN points to the last record. Let's take a look at what a record in the record page looks like. A record page starts with a header followed by multiple records. Each record has its own header called LFS record header, and a variable size record data area. As we mentioned earlier, the last record is located using the restart LSN. In this record, the variable size data contains a structure called NTFS restart, which includes several LSNs. These LSNs point to other records that hold data needed for log record, for log recovery. We are especially interested in 2 records, attribute names and open attribute table. For now, we will focus only on understand their layout and not what the data actually represents. First, let's briefly take a look at the memory boundary of the open attribute table. In the variable size part of the record, there's a header called log record header. We use its redo of member to find where the table starts. And then kernel memory dupe function is called to allocate just enough money for that table. And open attribute table contains a restart table, which followed by many entries. Just like open attribute table, there's an attribute names right after the log record header, and it's also used kernel memory dupe to allocate memory. So the layout is the same. Only the type change, and attribute names also contains many entries. The layout of attribute names looks pretty familiar. Each entry has a variable size name member, and in the log reply function, the code goes through each entry and stops when it sees the auth member is 0. But since it doesn't check anything else, if the last entry only has a valid auth, accessing other members would go out of bounds. That makes it a classical type 1 issue, but this is not our focus right now. Let's take a closer look at how the code actually works here. For simplicity, we will call the entry in attribute names AN entry, and the one in open attribute table AN entry to load. Here, this function uses the auth member in AN entry to locate the corresponding OA entry and then perform some assignments. The auth member here is actually an offset relatively to the start of the table. We can see the assignment process has 3 steps. First, the value 2 is written to the attribute name in the right entry. Second, the name bytes in the left entry is divided by the size of a short type, and the result is stored in name length in right entry. Third, the PTR pointer in right entry is set to point to the name in the left entry, which means it's pointing to somewhere in the middle of a heap allocated memory. So the issue is quite clear. The auth member is not validated. So if we put a large value in it, it can lead to an out of bounds write on the right entry. All right, we can parse NTFS3 image and set an offset that points outside table to trigger this bug. So we call this type of issue as out of range offset. Now let's summarize the primitives that are available to us. By the way, by that way, we can use these primitives multiple times because attribute names contains many entries, and each one has its own auth member that can trigger an out of bounds write. And auth member can represent an offset with a 2-byte range. So here's what we get. First, we always write the value 2 at offset 0 from the positions specified by auth. Second, we can write any 1-byte value at offset 1. And finally, we can write a pointer at offset 18. This pointer points to the middle of the attribute names, specifically to a name member in AN entry. For the third primitive, in order to figure out which slab our pointer targets and where out of bounds write occurs, we need to know the size of both attribute names and open attribute table. Let me quickly explain what is the slab. The slab allocator is widely used in the kernel. Its purpose is to allocate small fixed-size objects. Each slab is divided into fixed-size objects. So if we know the size of an object, we can determine which slab it belongs to. So we need to figure out the size range of a record. Typically, a log record page is 4 KB in size. If a record at the end of a page is too large to fit, the remaining data gets stored in the next page. So theoretically, the object size could range from 64 up to at least 8K. So the last primitive allows us to write a pointer to an object which can belong to almost any slab into a position that's relatively to the table, and this table can also belong to almost any slab. It's clear that we can use the second primitive to achieve arbitrary value writes, but the problem is the other primitives that end up writing a lot of garbage data before and after it. So a better approach would be to use the third primitive just once. That way we can write a heap pointer of controllable size at offset 0 of an object adjacent to the table, which avoids leaving behind any junk data. A commonly used object that fits our needs is a structure called pool list. It forms a linked list using its first pointer member, and when it's free, the kernel walks the list and frees every pool list in sequence. So we can actually turn our current primitive into a double free primitive. The idea is to use the out-of-bounds write to place a pointer at the start of a pool list, which adjacent to the table, and we choose write a pointer which points an object in kmalloc 19.6. Later, when the mount process finishes, it frees that object. After that, we can reclaim the same slot by allocating a user key payload object. Now, we have a classical double free. The first free happens when the pool list is freed, and the second occurs when we free the user key payload. The next step we want to use is called the pipe primitive, which is based on the dirty pipe vulnerability. The main idea is to modify the flex member in pipe buffer, which allows us to modify a page in page cache so that we can modify read-only files. To do this, we need to perform a cross-cache attack. Because the pipe buffer object lives in a different slab cache. So here is a simple example. For UAF, we can trigger the UAF to get a victim object, and then we can reclaim the victim slab to page allocator. After that, we can get another slab cache to reuse the pages of victim slab. By doing this, we can make victim object to reallocate it as target object. At this point, the victim object is fully overlapped with the target object. Typically, if we get an object that's fully overlapped with a pipe buffer, it would corrupt other members in pipe buffer. So indeed, we choose to use an unaligned overlap, which means our victim object doesn't start at the beginning of the pipe buffer, but in the middle. In this case, we are doing a cross-cache attack from kmalloc 19.6 to kmalloc CG 192. There are two possible layouts, slot 1 and slot 2. But we can only exploit in the slot 2 scenario. So if we hit slot 2, our victim object starts in the middle of the message 1. Now when we free the victim object, the size of the free operation is based on the current slab cache. As a result, it will free half of message 1 and half of message 2. Right now, we have an unaligned overlap between message 1 and the pipe buffer. The first half of the pipe buffer overlaps with the pure data of message 1. So we can read message 1 to identify this situation. Finally, we can free the message 1 and spray enough new messages to reclaim the slot. So we can control over the first half of the pipe buffer, and that's enough to modify the flex member. So here's the final exploit. First, we use an out-of-bounds write to place a pointer to the next member in a pool list. After the mount process, we allocate a user key payload to reclaim a slot. Then we free this slot by freeing pool list. Next, we perform a cross-cache attack to achieve an unaligned overlap between a user key payload in kmalloc 19.6 and a message in kmalloc CG 192. So we free the user key payload to trigger the double free and spray pipe buffer objects to reclaim the slot. At this point, we get an unaligned overlap between a message and a pipe buffer. Finally, we free the overlap message and spray new messages to modify the flags in the pipe buffer. All right, here is a quick demo. Initially, we have a normal user called test. For demo purpose, we use etc sudo er file to grant this user mount capability. And we run our exploit. Now we already modified the password file and we enter the new password. Now we are root. Okay, let me wrap this up with few takeaways. First, we need boundary checks for the arrays of variable size elements, including fixed members, variable part, and offset. Second, we believe metadata is still a vulnerable attack surface in file system. Third, code review remains one of the best ways to deeply understand a system. You may discover some bugs that fuzzers might miss. And finally, such issues are not limited to the Linux file system. You can apply these same ideas to other targets. Okay, if you have any questions, feel free to contact me. That's it. Thank you.
онлайн-игры, Google Chrome, Zero-Day эксплойты и группировка Lazarus. Были все замешаны.
Online games, Lazarus grouping, everything was detected. Basically, I work at a team that's called GREAT. We observe and follow various groups, do research on their attacks, and Lazarus appears to be one of the most interesting groups that falls within the range of our interests quite often. They are engaged in cyber espionage, cyber sabotage. Quite often, they carry out attacks intended to obtain financial proceeds, attacking banks and the gaming industry. They're well known under different names, and it will be quite logical to assume that they comprise different subgroups. There is a side group engaged in cyber espionage, as well as a group engaged in financial operations called Blue North. But the most important and interesting is the Lazarus group, which was engaged in Blockbuster. A Blockbuster was carried out by Kaspersky. In 2014, they researched the attack against Sony Pictures Entertainment that preceded the interview movie. You can see the banner on the slide. We have analyzed this attack and found a lot of proof that allowed us to link this attack to numerous previous cases that had been believed to be not interconnected. But based on the code patterns, we managed to attribute that attack to this group, Lazarus. While the software was used for this attack that shared the code called Manuscript. Manuscript is the backdoor used by Lazarus. They've been using it since 2013. And currently, the group uses it quite actively. They use it so often that in the previous years we have registered at least 50 unique cases used when this backdoor was used for various unique attacks. The attack I would like to cover today. So, how we got down to researching into it. We found a new backdoor manuscript application which was detected in Russia, and we rushed to investigate it. What surprised us immediately was the fact that it was a home user in Russia. What Lazarus might need from a user in Russia, we started analyzing the situation and found out that prior to the manuscript infection, there had been an attack against Chrome. And it happened when that user was on the network. We have different agents and robots that manage to identify new and unique malware infection cases, as well as the robots that help associate infections with various well-known groups. And in this particular case, we use the logic that was based on this principle. This is the website. Of course, we looked into it and found out that it was an online crypto game, like the Tanks, which is very popular in Russia. Basically, it was something very much like it, but linked with cybercurrency. Users could earn cryptocurrency and exchange it for real money. With this button, you could download the beta version of this game. I wanted to do it. I felt an urge to do that. But that was not the intention of the developers. Their purpose was to infect me with malware designed to exploit vulnerabilities in Google Chrome, as well as some other browsers such as Microsoft Edge. Having researched it, we understood what it used. We informed Google about it, and very soon they fixed the vulnerabilities. It only took them just a couple of days. In that attack, the vulnerabilities in V8 were used. It's a JavaScript engine which serves basis for Google Chrome and all the today's browsers, those developed by Google. This engine includes a very complex conveyor or processor for JavaScript. Usually it's generated by Mission, a special virtual machine. It's a pretty simple inverter with a number of instructions, all of them working with registers. And there is also an accumulating register that's used by the majority of code. Should any code be executed a certain number of times, the engine may wish to compile it on its native machine. There is a number of compilers allowing to do that. There is a compiler called flag, and the code produced by it will be just a little bit faster than the code of the interpreter. There is also an optimizing compiler called turbofan, which produces an optimized code. You can compile it using Visual Studio, and you can use it. You can compile it using turbofan. And the difference in performance between the two compilers was so big that the developers decided to develop a new one, and they called it maglev. This optimizing compiler is intended to compile an optimized code very fast. It was launched in 2023, and the malefactors would exploit the vulnerabilities in it. What's the simplest way to look into the code generated by the interpreter? The easiest way is to compile JavaScript engine separately from the code itself. There is a developer shell called D8, which allows to execute all the scripts from the CLI, dump the bytecode, dump various object structure, all those things that are used by the engine developers. There is another option, which is about just launching it and granting special flags that would dump the grunt code, applying it to the compiled code. This is an example of the bytecode compiled with the use of ignition. Each of them is linked with a processor capable of correctly unpacking the variables that are transmitted via registers and the scripts that will be used to generate machine-readable code. And here you can see a piece of code generated by a maglev compiler. As you can see, it's a heavily optimized code. It just takes the pointer to the object and writes the properties into the storage, where those objects are stored immediately in the body of the object. And here you can see the vulnerability, the code that was actually exploited by the malefactors. As you can see, it does initiate an array comprising two elements, then the elements are removed from it. Then the manufacturers apply a certain dictionary, and it looks as though nothing is being done with this array and dictionary. It's just returned. And there is also very interesting a function call. This function has a very simple code. Everything it does is just carrying out this expression. Some exported variable is set with floating point and is checked whether there is an error or not. If there is an exception, the function is returned, and according to the logic, this is the way it should be done, until it's returned back. How can this be possible? Let's have a look at the bytecode generated for this expression, and we'll see that there are only 4 instructions. The main one being setNamed ID property. If we look into its code, we'll see that if the exported module value is set, there will always be an exception. Writing into module from JavaScript is prohibited, which triggers an exception. If we wait for this action to be completed a certain number of times, let's say 1,000 times, we will see different code generated by Marlev, and as you can see, it doesn't throw exceptions. It just writes the pointer to the JavaScript object, which presents this floating point figure. And this prohibited operation is exactly the vulnerability that was exploited by the malefactors to run their code. This is how it was fixed. The only thing the developers needed to do was making sure that all the objects that should be prohibited in terms of setting values, that all such attempts will be declined. That's, as I said, everything that the developers needed to do. Basically, we have already sorted it out with the vulnerability itself. Now let's look into how the malefactors exploited it. They use the following structure. This structure is very similar. Everything begins from a pointer to an object called map. There is a separate object called map, which literally means a map. It describes the object with all its properties, its address and object types. Well, actually, it's a hard-coded number, and if the manufacturers manage to replace it or rewrite it, it will result in tab confusion errors, which will eventually damage the memory, which in turn makes it exploitable. Here you can see an object created for such a module. It looks like generic JS receiver object, which can have a number of properties, actually. And this number of properties is represented by property array object. Should it be a common non-exportable module object, the entry would just rewrite the 8 offset here in the array. However, since it's a prohibited operation, this operator should have never happened. Instead of offset 8, we see offset 0 here, and the map pointer is rewritten, which is really bad, because it results in type confusion. Well, as I said, the map can be rewritten and replaced for floating point object. You can see here the structure of this floating point object and the number itself, which is represented by offset 4 and 8. And the lower part can be easily overlaid on the type of object. Theory, as a result, can be processed by the engine like any other object the manufacturers may be interested in. By default, property array was used here. However, there is another option for 8 engine. It can be found in property dictionary. But property array and property dictionary are different in size. Obviously, they comprise different fields, since the manufacturers make sure that the property array be processed like property dictionary. For a hash of the dictionary to be generated in a certain point in time, to set up the size and damage a certain memory area. Well, everything the manufacturers need to do is to set up the desired memory parameters to come up with proper offset figure. Why do they get rid of 2 elements here? It's done exactly to locate everything in this particular way for this array to equal 0 in size. If it equals 0, the hash will be written into the dictionary, and the size will be rewritten by the hash in the dictionary, and the engine will believe that this array is huge in size, thus allowing the manufacturers to read and write into the memory, while modifying any other objects that go after this object, this array holder, or the dictionary that they've been creating. It's at this point that they can rewrite the size of the array to make it openable from the memory, to be able to read pointers as numbers, thus having basic object to obtain the addresses assigned to objects and be able to replace them completely. Well, actually, it's the mover, but their utmost goal is to be able to use their code, and for this there is a special security feature which is called V8 sandbox, which prevents them from doing that. All the pointers that are used in V8 engine, they are not real pointers, but just part of them, a kind of offset. Part of it is stored in the processor registers, which means that the manufacturers are unable to get access to full addresses, as well as the addresses of sensitive memory areas such as stack or memory areas or regions for the storing of just-in-time code, JIT code. In other words, we have a kind of sandbox or consecutive memory area storing all the JavaScript objects, while not containing pointers leading to sensitive data. And since these objects are interlinked with the use of offsets, the manufacturers are unable to read the memory and write into it. Which is a pretty simple safeguard, while it's also very safe and secure.
Сейчас компания Google, у нее есть отдельная программа по баунти. Если вы находите
Google today
отдельную уязвимость, которая позволяет вам
has
совершить побег из этой песочницы,
an
вы получите
application
баунти.
that will help you to get that bounty should there be an attempt to steal from the sandbox.
Злоумышленники использовали, на мой взгляд, очень прикольную уязвимость,
Well, actually, the intruders use a cool vulnerability which is associated with a number of VMs, in addition to the key ignition interpreter generating the bytecode that's used by JavaScript and a number of compilers. There is an additional VM which is designed to execute regular expressions. For instance, you're using an expression, regular expression from GS, it will be processed by an ad hoc VM that will be compiled into a bytecode that will be eventually used by this virtual machine. It has a pretty simple set of instructions. Interestingly, this VM uses fixed size registers, which registers belong to a certain hard-coded register array. Internally, it's hard-coded which register is to be processed with this particular instruction. And an error which is encountered quite often in virtual machines is that quite often the developers don't verify if the register is within the range of the array, which was exactly the case. All the instructions believed that the register called was within the boundaries of the array, which allowed the intruders to use such register and another register to read the memory. Unfortunately, it happened that this VM has an instruction called succeed. The only thing it does is returning register retrieved from this virtual machine back to the JavaScript engine or ignition interpreter or the code generated. And this succeed instruction is translated into this particular function, which copies a certain number of registers by using specific fields for a number of registers to be copied, and those registers are copied to a specified address. It happened that this number of registers to be copied, including the pointers, all those things were stored in the memory immediately after the register array, which means that the malefactors were able to rewrite the number of registers, the pointers for copying, or called main copy operation to rewrite any indicator, any memory register, region, by replacing them for the values they required. We found pointer to the stack, link to the page, after which the code was rewritten. Now, a few words about the shellcode. If you remember our last year presentation, you must be familiar with this concept. Quite often, attackers use various validators. They do it at different stages. This was exactly the case in this particular case. Shellcode provided a validator that would collect information from the detected machine, trying to amass as much data as possible. The processor model was checked. It was also checked if it was launched in the VM, the debugger, the type of the operation system, its version, like enterprise server, path, to the processor, system module versions, and the firmware versions.
Анализ вот этой всей информации на сервере Zoom.
And only this entire information was verified. The attackers would make their decision whether to continue or not.
Которые позволили бы совершить побег уже из.
But a couple of other vulnerabilities were needed in order to leak from the sandbox.
К сожалению, в данном случае нам не удалось получить этот следующий эксплойт.
Unfortunately, in this case, we failed to obtain second exploit. Kaspersky Lab is famous for having tons of 0 days used by thousands of users across the world. This is what we found. What was actually used in real-time attacks, and those vulnerabilities were fixed. In this particular case, we would need to wait for the next attack wave to include 0 days, for those 0 days to be up and running for a number of days, and then to be turned off. They turn them on, send out messages, and then turn them off. Is done in order to make it difficult for people like us to trace the entire chain, to come up with a fix. We decided not to wait for the next attack wave. We found that unwise, namely posing this risk of infection to thousands of users. Even those previous vulnerabilities that we had identified previously would actually foil the plans of the attackers, making it impossible to run the code remotely. And here you can see the privileges that were actually used. Well, basically, that's everything as to vulnerability and the exploits. But I have a few more words in regard to the company itself.
Удивительно, как много усилий эта группировка вкладывает в социальную составляющую своих атак. Они вот всегда прорабатывают.
It's interesting how much effort they put into the attacking social media. So they have this legend that is behind their attack. And it was the same this year. For months, they were posting different content, news updates in their account in social media X. In fact, they use several accounts, and on a daily basis, they posted different content that was generated by AI, like these ones. They did it to draw as much interest as possible to their project, to get more users to get to the game and to get infected. So if you're 0 day, then the attackers could infect any user of this web browser if the user used the link they got. And all this malicious activity is not limited by Twitter only. They tried to get in touch with different crypto influencers. They were writing in their messages, so we have this great project, so get to us. So first of all, they did it in order to make this crypto influencer use it and distribute it in their audience. But in order to, if this is a big person in crypto area, so they probably have a lot of cryptocurrency, and the Lazarus group wanted to get it. So in the past, there were many cases like that. So, and all this malicious activity wasn't limited by Twitter only. They even had accounts in LinkedIn, LinkedIn, and they had some other websites that were associated with this company. On those websites, they had contacts of attackers, and they were asking users to write something to them via email. So, the further we go in this story, it becomes more and more interesting, because as it was said before, you could push the button and you could download this version of the game for Windows. So I'm a great fan of video games. Is it possible to play the game of APT group? That was just great. So I did push the button, and there was an archive, 400 megabytes. I unpacked it, and it looked really like a real project that was written in Unity. And if you play some games that are written on Unity, so you probably know the structure and the names of the directories, everything matches the names of domains, the same name that was on logos of the attackers, as if they wrote a game, they compiled it and packed it. That was wow. And if you dig in the resources, you could see that these are resources for the game on Unity. I even found the artifacts of compilations, and you could see that the attackers, they compiled this game. So, what can we do? Of course, I launched it. And yeah, the game went on. If some of you play these online games like Warcraft, to play, you need to key your login and password, so the registration button, but none of them worked. So, is it all that the group did? So, I mean, it makes sense, because why would they put so much effort and to create this big website and to put so much effort in promoting it in an SM? It's kind of logical that they made this login start window, so you can't register in the game. I tried to do it from different websites, and also you can't really register an account with the game. So I decided to dig deeper. So I unpacked resources. I found textures of tanks, 3D models, elements of interface, and it looked like real, like you can really play the game. So I decided to reverse the code of the game. So the code for tanks, the code that's responsible for communicating with the server, and it was clear that the server doesn't work. So on domain, where the exploit was launched, so they had to do something so that the server would work, but sadly, they didn't do that. But I want to play the game, so we had to create our own server for the game. So we love APTs and we love games. Yes, we did that. So it didn't really take much effort. So I looked at the protocol, it was SocketTO. So we had the teams, all the payloads, they coded with base64, and you could see like how far they went. So I managed to realize the whole thing and managed to play the game. So you can see how I key my login and password. Like login, so logo of the attackers. I choose the most powerful tank, and I choose the map. So that's the game. The first game from Lazarus group. Looks a little bulky. Actually, I played it, I liked it, so there are some bugs. Where you can see these blue areas. It was supposed to be water. So they didn't quite push it well. So I like those games on the CDs, on different CDs that they used to sell them. So it was a level high that was written on a shame, but when in our childhood we didn't have enough games, so you could play on the disc, you could kind of entertain yourself. But if this is the game that was supposed to be sold and to make crypto money and invest your own money, I think it's not worth it. So it's just my personal opinion. So at this level, so now they're going to be congratulating me with a victory. So if some of you want to play it, so I can give you the original. So Lazarus group, what they do the best? They steal cryptocurrencies, source, and it happened like this at the same time. In fact, the source of the game, they stole it from the developers, and they managed to rewrite all the logos, compile it, so you can see the scale of it. And of course, their goal was not only to infect users in Russia, but in the world too. Yes, we found the original project of the studio. They have a lot of subscribers on Twitter, and they have a group on Telegram, more than 1,000 subscribers who follow the progress of the company. They always ask when the game comes up, and all. So the game didn't come out, wasn't released. But the group helped us to build the timeline of the attack. Original developers, they announced the game in 2023, and a year later, they started their campaign, those attackers. And a week later, they managed to steal the money from the original developers. So that's the scheme they use. So original developers, they could, if they could at some point could see that there is this malicious double of their game that's being promoted in social media, and this game could be downloaded. And at that point, it was unavailable, and Lazarus, they stole the source code from the team. So if they knew it, they could have started investigation, and they could have protected their money. Sadly, they didn't manage to recover after this attack. Now it's time for my conclusions. This is what I want to say. Historically, half of the vulnerabilities that was found in engine V8, we found them there. And the compilers, they write to each other, and they find new vulnerabilities. Now they introduced new fixes to Turbofan. So there will be new vulnerabilities that could be exploited by attackers. So all this processing, reprocessing, developing, redeveloping, rewriting, and using. So the development of these compilers never ends. But what should we do, the regular users, when you know that you're among the groups that can be victims, that the attackers could be interested in? Sadly, we can't do much. But there is a browser without just-in-time compilation. One of such browsers is Microsoft Edge that comes with Windows. Developers came up with this security feature, this super-duper super mode. So what it does, it just turns off just-in-time compilation. So it only does what it interpreted does. So you go to JavaScript, and you can put the strict mode, and compilation will be turned off. I used this mode for many years. I didn't notice any problems. That's why, at this point, my personal opinion, this continuous rewriting of just-in-time compilation exists only so that web browser developers could have work, and the developers of exploits could have work. So don't get me wrong, even if you turn off just-in-time compilation, Attackers could hack you using different vulnerabilities of different parts of the engine, but this mode helps to reduce the surface of attack and increases your security. And also there is a policy, security policy, that could include this option in all organizations. There are certain exceptions that could be done for certain websites, but actually advise you that. So this code that was used by this vulnerability, so now V8 exists, so but if without this option, exploit won't work, and this exploit worked, even worked without any changes with the Xbox console. You could take this exploit from Lazarus and you could hack your Xbox. So, summary. Main idea that I wanted to deliver here, so don't underestimate Lazarus APT. They're masters of social engineering attacks. They have quite a wide range of targets. That includes experts of information security. There were many cases when they managed to rub shoulders with information security officers, and I'm sure that some of you are here in this audience, so be secure. And oftentimes they used exploits of zero-day exploits, and very hard to protect yourself from these exploits. And also, they stole billions of dollars in cryptocurrency, in crypto industry. And we keep detecting attacks in Russia and Belarus. A new wave. It doesn't have to do with the particular story that I was mentioning today, but the latest wave that we noticed, it passed a few months ago, and they used similar tactics. And now one of the most popular tactics that Lazarus Group used, this is fake interviews. If you're a person that works in some interesting company or somehow you deal with cryptocurrency, so they'll get in touch with you through LinkedIn or through your email. They set up an interview with you, they'll give you some tests to pass, and if you try to launch it, you will be infected. It may not even contain some malicious code, but there can be some external dependence that might download a malicious code from repository somewhere else. So that's why most of you here, you're developers, so be careful. But the most important thing that we found out as part of our study, that at this point, Lazarus is not developing games yet. Thank you very much. I will be happy to answer your questions. I can see that there is a first question over there. Microphone there, please. Hopefully it works. No, it works. I'd like to ask you, you said that you didn't being copied. They managed to copy the shellcode code and they made a compilation. I think 3 or 4 years ago, I was studying V8, and at some point they started indicating their just-in-time page. So how they managed to write something where it can be written, why the system didn't detect this? In fact, pages that are associated with just-in-time code, they're privileges in writable and executable. You can write there using copy, and the code will be run. This is, so to speak, area of the memory where pointers of executable functions are written. So if you rewrite a code of one function, they can execute it. So, in other words, so they rewrite the code. So that's exactly what I wanted to ask you. I put it wrong. So it was a reg page. It was 21 or 20 year. So with turbofan generates, it was usually it had it to like every X and starting in 2021. I finished my university in 2021, so we started indicating its pages in RRX, presumably this. It was put in a layer between in its location and the location of the call, and when it was calling, it was put in there the execution and writing. So initially, there were pages where you could write to. Understand? Yeah, we checked it. Writable and executable. That's how they do that. Can you hear me? Yes. It's always interesting. So, your opinion, how does Lazarus find such a great vulnerability in compilers? Because it's not that easy. You're just using the fuzzing, targeted fuzzing. You can't really find it. So, read this so much code. In fact, Lazarus, it's pretty much advanced group. And if you talk about the number of people that work for Lazarus, maybe today it's 1,000 people. In my personal opinion, I think that they have expertise that helps them to develop exploits, because from attack to attack, they use their data. Some of them, I've heard some other versions, some people thought that they attack experts of cybersecurity and that develop vulnerabilities to steal these vulnerabilities, but I think they have the expertise that they can develop their own exploits. We analyzed a lot of exploits, and in fact, we can see some similarities. We can see that, say, so to speak, handwriting is the same. Exploits are written in the same style, using the same additional functions, supplementary functions, and clearly they were developed by the same people. And I think the people who work for Lazarus groups, we thought that Lazarus were qualified, more qualified engineers of security engineers in Google security. No, we don't think so. In Google team, they have great experts who can also find and can find vulnerabilities, but there is a certain distribution of talent. Some people choose white hats, some people choose black hats. Thank you for your presentation. I'd like to clarify how you attribute to Lazarus, why it's not somebody else. Good question, actually. In this case, everything began with manuscript. Manuscript, this is kind of their signature malware. They use it from 2013. They introduce small changes into it, and the code doesn't change really. And some of the sources of manuscript still come up in some different malware that are associated with Lazarus. So there is a direct attribution to this malware. We didn't see any other cases, manuscript or malware that was based on it, which was used by other groups. But there is manuscript here. Exploit, game. Where is manuscript? The final, the attackers used the exploit in order to deliver the malware. So you say payload in the second part. They didn't catch it because you would not catch in the second part. There was a The chain of the attack had several exploits. We had the first point when it was website. This site was using the installer of the exploiter, the JavaScript server. There was shellcode that was verifying a victim. And if they needed this infection, the server of the attacker with the exploit was available. Then the next exploit comes that was exploding Windows in order to do it in the sandbox. And then this next stage, probably there were some other stages that were verifying the infection of the final exploit. They were downloading manuscript. So we managed to detect the first exploit, the shellcode. We couldn't detect the exploit of escaping the sandbox, but we got the final payload. So it was available, right, on the same website.
у нас есть продукты, которые хорошо детектируют
In general, there are products that can detect different types of threats. But the problem with the chains is that there are some components in them that cannot be detected. And of course, such attacks as manuscript, even our regular products for regular users, so not APT solutions, not solutions that are designed to protect you from APT attacks. So there are just regular products that can detect payloads as manuscripts. So in fact, anybody can upload manuscript to the website through which they do the attack, and then it will be attributed to Lazarus. And you can write an exploit for several $1 million. But if you put the manuscript, they will be attributed to Lazarus, right? You know, there are so many APT actors that use the payload of manuscript. So all American. So it's your opinion. Thank you.
Вы устранили уязвимость в
So you managed to fix the vulnerability in browsers based on V8. Did you check the browsers based on SpiderMonkey and other ones? No, there was just one check that we made. And the condition was that the exploit was not supposed to work with browser Brave. So that was the only condition. But Brave is based on V8. And the exploit was also written for Chromium. Special ones for SpiderMonkey and Firefox, but we didn't see them. I have a question too. Sorry. Thank you for the presentation. My question, Lazarus. How often they use AI as ChatGPT in order to reduce the time of writing exploits? And according to the stats, we can see that the accounts are blocked in OpenAI and many others. So can you track them down like that? AI technology. There are many things. It's pretty fresh technology. I monitor this with great interest in how it's developing. It seems, yes. And actually, they did some studies. And they were saying that they could generate POC. And recently it was here. And I saw some other discussions in social medias where users discussing it. There were some great researchers in this community, and sometimes they could indicate some LLM. And after several prompts, it could find some vulnerability. And if you're talking about some real writing exploits using LLMs, when they will be able to bypass protection systems, I don't think so. If we look at the exploitation of mobile devices, it's not the vulnerabilities that they're interested in, the exploitation techniques. This is what they so they put a lot of effort in order to close these primitive exploitations. And the most important thing now, the technique of exploitation, it's a secret that couldn't get to the public area, and LLM doesn't know about this. So what is the chance that it will be able to generate an exploit? Thank you. Hello. Thank you for the presentation. What did Lazarus do with the bots that they managed to infect? You mean with the users? Yes, with the users. I think that the goal was to steal cryptocurrencies, and this is the tactics that they use. So they embed malicious code in extensions for web browsers, and they steal money. I think the ultimate goal in this attack was stealing cryptocurrency. Yes. Thank you. I have two questions. Hello?
Видимо, время
Well, seems like time is up. So if anybody has questions, so please, or we still have time.
Слышно так, да? Да-да.
Can you hear me? Okay. That mic was out of use. Okay, two questions about cryptocurrencies. If the main goal still in cryptocurrency, so if you can see where the money is transferred and following the money, you can see where the money goes, or at least we can monitor the path, so to speak, and how usually they work with Interpol. Did you do any investigations like that? Yes. We have colleagues that do this in particular, and they follow these suspicious transactions, and they take into account all the crypto transactions that are linked to attackers. In our team, we detect target attacks, and we analyze the case. So monitoring transactions, this is what my colleagues do. Yes, we do the work, as you mentioned. And the second question is more sort of closer to me, and maybe more people are interested in this. It's about the browser that you said that the only one, that Edge, where you can turn off JIT. So in Chrome, you can do this, but there are some other browsers you can do this too. Sadly, no. It was a feature that I was dreaming about. Developers from Microsoft, they decided to do it, and it's absolutely the right decision. In fact, this function, only Microsoft Edge has it. No other one, no Tor, no nothing. So you can like completely turn off all the JavaScripts, but in this case, nobody will be able to exploit you, but your website won't work. But here there is a balance that extremely increases your security, and the website work. It's only one option, and there is no other web browser that does that. Okay, thank you. Thank you very much. If you still have questions, I will be happy to talk to you. Thank you.
Добрый день. Спасибо, что пришли. Меня зовут Александр Попов.
Good afternoon. Thank you for coming. My name is Alexander Popov, and I'm going to discuss an environment for Linux kernel development. But first, a brief teaser. One good man told me a story, so I decided to share it with you. Teacher Yoda, do you only hire winners of competitions? No, I hire those who finish the task even when the competition is over. And after my presentation, you will understand why it's important. My name is Alexander Popov. I've been a Linux kernel developer since 2012. I was engaged in a number of free software projects, and I'm principal security researcher and head of open source program office at Positive Technologies. I'm also in charge of the open source program office. And by the way, tomorrow, in this particular room, I'll be moderating panel discussion with the leaders of Russia's open source. It will be interesting, but now let's discuss the Linux kernel. I've spoken at many conferences worldwide, including ZeroCon, Linux Security Summit. However, this particular event is always in my heart, especially given the fact that this room is named after Alexander Popov, a famous Russian physicist, the one who invented the radio more than 150 years ago. And in my understanding, he is a true Russian hacker. That's why it's so important for me to speak here today. This is my agenda. I'm going to cover the bug collision story, or a story of simultaneous discoveries. I'm speaking about CVE 2024-5264, and I'll demonstrate a new way to exploit this vulnerability to enhance your privileges. And I'll also discuss the kernel hard view project that helped me in achieving that. So, how did it all begin? In 2021, I was researching the system called VSOX for Linux, and in 2021, I identified a zero-day vulnerability in it, and my patch was deployed for Linux kernel. And last spring, I decided to fuzz the kernel of this subsystem again. It's really interesting because you don't need any additional privileges to work with the sockets. A non-privileged user can do it. And last spring, I found another zero-day vulnerability in the Linux kernel. And when I was reproducing the bug and disconnected the sanitizer, I found out that immediately after this damage being done to the memory, the zero pointer is impaired. But this vulnerability proved, I thought that it was not really good for exploitation, which was a mistake. Later, I reviewed that bug, and one day, which proved to be a bad day, I found out that there was a bug collision with two Korean researchers. Those guys, independently from me, found the same zero-day and exploited it as part of kernel CTF. And their patch, only comprising one line, transformed my prototype into a kernel crash. It was a very sad development for me. I was already cherishing some hopes I wanted to exploit that vulnerability. It was difficult. It was a hard day, hard time for me. After some time, Wabel and Query, those two guys, published an article describing how they had exploited that vulnerability, and it proved to be really complex, very, very complex, very sophisticated. I thought that I could come up with something different, something more optimal. The machine I used to launch those exploits is different, very different from the distribution kernels. So I decided to develop a bug using Ubuntu Server 24.04 with a fresh OEM HWE kernel. It is a newer kernel version supporting new features, so I decided to try. Although CTF was already over, I still wanted to complete that task. It's a really good bug. I mean, good from the perspective of the attacker. It appeared in Linux kernel in August 2016. This race condition, this is actually a race condition in AF-vSock sockets between connect and TOSIX signal. Just send the signal. Should the signal come in the right time during the execution of the command, user-to-free write will occur, which may be very interesting for the attacker. Another point, the vulnerable object, its size was 80 bytes. And it lives in slab cache of kmalloc 96, which features a number of other very interesting objects, comprising them by default. Unfortunately, this vulnerability features a number of very unpleasant limitations. All those limitations allowing me to say that it is the worst bug I have ever seen in my life in terms of its exploitability. First of all, a few words about reproducing it. Wabel and the 4-bell and Query used sigkill. Should this be done many times, at a certain point in time, you will find yourself in this race condition and the memory will be damaged. My father really surprised me. When I started investigating, researching the reproducer created by my father, I found an interesting signal there. I called it Immortal Signal number 33. This signal is used by POSIX thread library. And the operating system hides those signals from the application. It's used when the operating system is synchronizing the properties of the threads. And this one features a very interesting feature, very interesting property. It can be hidden. I thought, great, the operating system knows how to keep its secrets. Moreover, with this signal, should it be called with system call timers and time, you will be able to predict where to send it and how many milliseconds of delay you will need to send your signal. Now let's have a look at the vulnerable code, basically where the memory is damaged. This VVS pointer contains an indication to the damaged structure. Firstly, a spin log is captured here. A field is present in the structure. If it's 0, it means that you can enter 1 there and the execution will continue. Otherwise, it will wait for the 0 to reappear. Once the spin lock has been captured, should it be 0?
2 4-байтных записи.
Two 4-byte entries are written into the free structure. It's a plain and simple code, and in this sense, it's a great vulnerability. Should I put something into the freed structure? You don't need to know any address. You need nothing. This is how the vulnerable object looks. The fields are damaged. This highlighted yellow should contain a 0 for the spin lock to be captured. And two 4-byte fields, they are used for data. Now let's see, is it possible to control the data? I found a way to control the first field, which is peer buff lock. If you use SSRF to increase the size of the buffer for this virtual server, you can enter any value here from 1 to this one. So I can be in control of what will be written into the freed structure. If you use the second one, sock peer _forward. This is the number of units sent via the virtual socket. It will be 0. Not really flexible, not really good for the attacker. Now, to the shortcomings or limitations of this vulnerability. Super Mario had to overcome a lot of obstacles. The vulnerability is created in pair with a server object, which is really bad for cross-cache attacks. We have already mentioned cross-cache attacks today, and I'm going to touch upon this topic again. Reproducing this race condition is unstable, very unstable. Hitting with a signal at the right moment is a very difficult task, which makes the researcher's life really difficult. If I need to change something to have the system tested, it's a real pain. What else? When the kernel frees the vulnerable object, it will be written into very fast, 5 to 6 milliseconds. So I'm really short of time to write anything there. Even worse than that, once there is such freeing and rewriting, immediately after it, the naming of the 0 indicating happens. Null PTR deref happens. And this is not everything. Even if I manage to bypass this null pointer dereference, in a couple of milliseconds, the kernel worker will die. So I only have 8 seconds after the vSock close timeout. Otherwise, I'll need to restart the server. Last but not least, the kernel worker will hang if the text lock field is not 0. These were the limitations that I needed to overcome to exploit this vulnerability. That is exactly what I meant when saying that it was the worst one. But anyway, let's go. Let's see what these two Korean guys did. Their solution is super complex, but it's really interesting. At stage 1, they came up with a large number of BPF programs which flooded the physical memory of the machine. Having prepared like this, they proceeded to the exploitation of the vulnerability itself and the problem of having to create 2 objects. They use a technique called slapstick. In other words, the attacker determines when a new slab needs to be created, a new array of objects. And this switching to the new slab takes more time than the actual identification of a new object. They say that the new slab has been created. They need a vulnerable object to be created in the old slab and the new one in the new slab. This solution is not really stable, but it helps overcoming this limitation. Then they carry out an allocator attack and assign page tables. Then they use UAF
с какой-то определенной вероятностью указала на
to rewrite the page table to point at the program elements that they created. When this is the case, the JIT code is placed into the shell code, and this shell code is executed when there is an interaction. It may sound pretty complex. I found this solution pretty complex. I decided to simplify it. So, these are my first ideas. In the first place, I thought that I wanted to place an object with new nature to be written into after freeing. And probably after that, I'll be able to attach some new exploitation primitives to it. But there is a problem. The new kernel of Ubuntu Server 24.04 includes these protection tools, and they provide for different nature objects replaced in different subcaches. Usually, such vulnerabilities are exploited with the use of heap spray. When you create objects of the same size, and those objects are placed instead are placed in the freed areas. With these kernel compilation options, the objects with different nature are put into different free spaces, different slabs. Otherwise, your object will find itself somewhere else and you will not be able to rewrite the memory. And cross-cache attacks are used for that. I thought, great, it's already present in Ubuntu, so I will get down to my cross-attack immediately, without relying on the old method. So, first of all, I decided to cause a cross-attack in order to put the credentials of my process with my user ID. Well, actually, the vulnerable object is 80 bytes in size, while the new creds are 184, which means that these two vulnerable objects match one Ukraine slab. However, this field, which is xlog, which is supposed to be 0, is struck right in the user ID, and the user ID is 1000, but we want to become a root, a 0, which means that it will not work. However, if it finds itself in the second part, the overlapping of the fields will only allow us to write some controlled kernel address, and I don't have data for it. I don't know what to write there. That's why I declined this idea. I started looking at other objects, and the first thing that crossed my mind was the MSG object. In 2021, when I was exploiting the previous version in the virtual sockets of the kernel, I invented my hip spray method, which is about increasing privileges with MSG. Basically, it's about sending something via your System 5 socket. And eventually, this basic structure or primitive later became very popular among Linux kernel developers engaged in researching into vulnerabilities. Many developers use my invention, so I decided that it might be cool inventing something new for this object. So, how this overlapping of object work? It's not really great. This field that is supposed to be 0 finds itself in the attached list. When we send a message, the message is queued, and this queue is implemented through this list. And where the 0 should be, there is an indicator of the preceding element, which means that the kernel will just hang. So I started thinking how I could overcome this limitation, and I found a way to do it. Well, I wanted 0 to be present in the associated message list. This is a new technique. It has never ever been published anywhere, and I am happy to share it with you. I came up with the following solution. This message queue, I place my 80 kilobytes into it. When I call message send, my 96 messages, small messages, stick to the queue. They are identified, but they cannot be queued because there are only 2 bytes left. And they keep waiting with their target indicator, which means that right here I can come up with my user-free entry, and after that I can use my 8 kilobyte messages, and at this moment the kernel itself will correct the damaged indicators in the queue, in the list. This allows me to have a 0 here, and the kernel will not freeze if I use MSG to rewrite the object. Well, this technique is even more important than it is important in my specific case. Previously, for example, you could have a way to go beyond the frontier of your array. To rewrite MTS field, you as an attacker were supposed to know or to place here some known and good kernel address. To come up with an overflow, you needed some data leakage. My approach allows for so-called blind rewriting. Should you put anything bad in this field, the kernel will correct it, and you will be able to rewrite to go beyond the frontier of the array without any need for data leakage. Now that I know that I can place MSG in place of my vulnerable object, I can proceed to my attack. This command, it does something really interesting. It creates 16 caches. When you call camelog in the kernel, the structure will pick from one of those 16, and you don't know where. And the attacker cannot know in advance to hit the one that may be of interest. You need cross-cache for that. You'll need to fully free the cache memory where your vulnerable object is and create a new object with new nature. However, as I mentioned before, the bug that I've been working on is super unstable in developing a cross-cache attack for it, given that I didn't know how it would work on the Ubuntu kernel was a real challenge. So I started thinking what I could do. And I needed to practice. And to practice, I recalled my project dating back to 2018. I did it down for the students of Bauman Technology University. It was designed for kernel exploits. So I decided to revive my old project in order to practice.
Довольно интересно и занял все-таки свою нишу.
It proved to be really interesting, and eventually managed to occupy the niche it was destined for. So this is yet another project, which is also a kernel module that can be used to practice. But my kernel drill is much simpler. It's a super simple kernel module. Even if you've never written on C, you will still be able to understand it. My project will give you a lot of prototypes out of the box. When I was doing that project for the students, I needed some word to signify training or practicing, so I opted for the word drill. And, my colleagues used this idea and called it a drill. A drill is a tool. So we use here a super simple kernel module, which creates this file proc/drill_act to complete simple actions. You can create a structure, free a structure, do callback, because it contains a pointer to a function. And you can also write some value into the structure. And you can perform all those actions in a random sequence, and the module will not go down. The structure itself looks like this. I called it struct drill_its. With the size that I set up and define, I can indicate the overall structure size, so I can practice on kernel object vulnerabilities of any size. And it also, the project also includes a test. And there is also a step-by-step instruction guide, which may instruct you as to how to practice with this vulnerability. The simplest thing here is the use-of-free exploit, which is used to rewrite drill_uf, drill_item_t, which is about just transferring the control flow. Another exploit prototype that you can use for practice is something I've been speaking about. It's use.free vulnerability, but for this practice module, once space is freed, you can enter this object nag_nag.m_ts for you to come up with 80 kilobytes of data, which is great link.
Now with training from cross-caching on Ubuntu, I'm going to use it in my 0-day. So another one that frees the cache structure of drill_int, then cache attack. Cache, we had drill_int, turns into cache with 5 buffers. These are quite popular objects among the kernel searchers. And you can do the dirty pipe attack that our colleagues spoke about in a couple presentations ago. When you're rewriting flags in pipe, you can write it in only read-only file in the system. And you can do it in the root, and it can be done in one line. It's a beautiful attack that was developed by Max Kellerman, and I speak about it a bit later. That's not it. In collaboration with Vyacheslav Ratachka, we made a couple of more prototypes of exploits, and Slava will be talking tomorrow in PT Lab track about around 4 p.m. So please look at the program and come and listen to it. And he will be talking about how to attack Linux kernel through the pages. And kernel hack drill, there are prototypes of exploits where you can train, you can use after free into tables of pages, and through this you can come up with the privileges for Linux system. And here we have two prototypes of exploits. So one of them from using up to 3, it can overwrite page table entry. It shows you the 4 kilobytes pages or page upper directory. This is the page of the pages that show you 1 gigabyte huge pages. So you can get a gigabyte of kernel memory. You can read and write whatever you want. So all this is in kernel hard drill, and this is great to train. And we have even more prototypes of exploits with some basic primitive exploitation. So please join. So what cross-cache attack I was training at the Ubuntu kernel? Because among the researchers of kernel security, there are some mistakes. Well, cross-cache, it's all clear, nothing's particular, but there are some underwater stones. Cross-cache, cache, slab. It's a set of objects of one nature. And the slab, or different objects with different size, has different objects. For our object that is size 80, 96 bytes, this Camelot 96. And in this slab, there are 42 objects of 96 bytes in 4 kilobytes page. And you can see it like a house with 42 tenants. And with the kernel allocator, there is a list of not fully filled with tenants. And this thing is called CBU partial list. It's a partial list of unfilled slabs. The first goal is to understand how many tenants are in the house and how many are unfilled houses, and then to create a new active slab. What does it mean? This is a slab where we'll have objects allocated. This is the house where allocator will put tenants at this point, and this is a very important concept for allocator. Then the attacker's task is to create many objects in order to prepare slabs for the future fulfillment of this partial list, of this list of unfilled houses. We multiply 100 to 42, and this is how many objects we'll need, and they will be filling the objects we need. Then we create a slab with our vulnerable objects, where they're going to be used after free. We create 42 objects for this one too, so allocator will move to the next slab, and this vulnerable slab with a vulnerable object is active now. So now we saved the pointer to our vulnerable object in order to this USF pointer. And then we need to create another object for this. So if we don't do this, then we won't be able to make a cross-cache attack, because the active slab cannot move to the objects of different nature. So we created a new active slab. After that, out of 120 filled slabs, we free one item, one element. Then our list of partially filled slabs where we previously freed the slab with our vulnerable object. The slab with the vulnerable objects will be kind of pushed out under the allocators of different nature. First of all, we need to free the slab with the vulnerable object, and then we need to fill the list of partially filled slabs with this big set of 100 entities. So now, when we create objects of new nature, we can reuse the vulnerable memory for the objects we would like to highlight with the MSG. For example, we can write them in the freed memory, and we're not going to get to the old object. We'll get to the object of nature. That's the procedure. And it would be very difficult to develop it for my new vulnerability. That's why I went to kernel hug drill, and I created the exploit that trains it without any problems, trains this methodology. So now, a couple of words about how kernel researcher can tune this attack, because it's happening under the hood and you don't know if it went successfully or not. And some of the researchers say when they talk about cross-cache, but how to fix it, nobody tells about it. In the source of the kernel, it's enough to add 2 additional messages. In one, MAG that will be typing the address, and the second one will be the function, interesting function, put partials. This is the function that takes the freed slab under the objects of different nature. And now the session will look like this. In red, you can see the kernel log. You can see what the exploit writes to me in the shell. And in green, this is what you see in JWT session. And the kernel log, you can see the object with the 8A0 number. Using GDB, I'm looking in what slab this object lives, and it ends with 11.0, and I can see this message that 11.0 is pushed out by different objects. And when I highlight MSG 8.0, the address that I was looking for, drill item T, and it moved to MSG object. In fact, any kernel security researcher needs to study this thing, because the tools of allocator security, they're standard in many systems. And to do just a regular heap spray as we did 3-4 years ago, we can't do that anymore. We have to use these more complex approaches. If you'd like to study how cross-cache works, so go to kernel hack drill, and try to launch it. And when I was fine-tuning the cross-cache for Ubuntu, I thought it would be, I wouldn't call it the recent slab hardening features, but the kernel features that make cross-cache attacks completely stable. Because usually in the internet, the kernel researchers, they say cross-cache is so unstable, it's so difficult, it works with low probability. But here, when objects, they live in different slab caches, that's why cross-cache is done very stably, because they don't intervene with each other, and you can control, let's say, the tenants of each cross-cache. So when I was drilling cross-cache for Ubuntu kernel separately, I could bring it to my exploit. And as I initially said, cross-cache can be taken out of the box, because I need to completely free slab, and an extra object from the server may get there. So how can we unstick them? Korean researchers, they decided that when the kernel
brings a new slab, they use a timing of attack, and they see that the bringing objects is longer. So this is how they manage to separate them. But what if I hit it very, very early with my signal? I want to exploit this state of the race with a different state of the race. So, and I managed to do that. So I hit connect with my signal 33 after 10,000 nanoseconds after the connect began. At this point, this one happens. The communication through the virtual socket is not able to go through, and only my vulnerable object is highlighted, and the server's one is not. And what's great about it is that from the user space, from my exploit, I can identify 100% accuracy if I hit the race window or not. I manage those. So if a system call connect, if I hit it, so it will call back to me. But if with another virtual socket I connect to the server one, so I will be able to do that, because I didn't manage to do it with the first one because it was too early when I hit it with my signal. Because of that, due to this additional things, I can see that my race was quite successful. So it was a quick run for my exploit. So I managed to bypass this limitation of doubling those objects, and I significantly accelerate my exploit. So if Korean researchers, their bug hits once in a few minutes or even in hours, so 1 GLI, I met months ago when I was in ZeroCom conference, and I managed to bring him in so that he come and I could talk to him. The person that I had the bug collision and this competition, so I managed to meet, and he said yes. So it was very unstable, and with this tool, I managed to do it quite stable, and the bug hits once a second. 5 times for 8 seconds, I can do it free. So, but here we still have another limitation, because use after 3, we have no point rate reference. That was bothering me. That's why I decided not to do it at once. So that's why, and I use the same tool that Koreans use. I use this third race condition in order to exploit another race condition. After this vulnerable connect call, I do the system call listen. And it turns the kernel socket into no point of direct. It doesn't happen, and they have just different code ways. But sadly for me, this third condition of the race, it's extremely unstable. And probably the main problem of instability of my type of exploit, this is this place. If not this, it would be 100% stability. It would be a really cool bug. But with this thing I have to fight, and my Korean colleagues, they have the same story with this thing, no point of direct. So, but Super Mario didn't go around all the problems we have, as to speak, so to speak. So we have a quite tough issue that the message itself, the entry itself, happens very quickly after the kernel left the object, 5-6 microseconds, and I'm unable to cut the cross cache in. So use after free happens, but I am not able to put in this free space of the kernel. So what to do with this? It's a problem. So I use this great technique of Jan Horn, and that's how it works. The racing against the clock, it's called, hitting the tiny race window. The point is that at the point when the kernel is running and I need to slow it down, I need to send at this point an event to the kernel, the timer. So the timer should be up at this point, and I need to register on the file descriptor of the timer. A lot of Apple watchers, so when timer comes, the kernel is distracted from its work, and it goes to work with this huge queue of coachers, and that's why your window of race is expanding.
So we call it timer. We make 8 fork of our process, and in each fork we make duplicates of timers, and we create 500 fork watchers. So in the egg that was in the duck, and the duck was in the rabbit, so there was a lot of work for the kernel. And when the timer comes, when the kernel needs that, so and then the kernel goes there to work with these watchers. And there's this interesting problem that Jan Horn doesn't have. The commit of these watchers is limited, and it turns out that desktop Ubuntu is, I think, is 100 times more than on the server. That's why on the server system, I had to be careful with these watches because there were not too many of them, and I was unable to significantly expand the window race window, sorry. So, and when I hit with the timer on this kernel worker, where we had the entry, so I managed to expand the race window by 80 times. I had 8 microseconds, and I managed to expand it by 80 times. Finally, I wrote my MSG, and instead of the free object, now I can rewrite its MTS field and increase its size. All of a sudden, MSG is 8 kilobyte kernel message, and I can get this now. If you remember the assessment to 2021, and I did out of bounds read and in the kernel, and I found all the interesting things. And here, among other things, we have things that I identified, this function that for the structure file, and that's a great structure. And we, safety researchers, security researchers, we find credentials there in the structure with the rights of our system, and I found there the user 1000, and it's great. So, what to do next? Now I need to write it in these credentials, and what I thought about is to make the cross-cache attack, the cross-allocator attack. So that's allocator, would highlight the tables of pages. But in order to do that, this dirty page attack in a Linux kernel, I need to know the physical address of the kernel in order to map the kernel memory in my exploit. But I don't know this kernel address of the physical memory, so the first thing is maybe brute force it, but I have only 5 attempts for 8 seconds, and it's not, that's a great brute force when I can scan big space. I started thinking, maybe this leak that I got, maybe this kernel address in the virtual space will give me some prompts. Started looking there. So, simple experiment. I launched the virtual machine twice, and I see where the Linux kernel is, physical and virtual. Sadly, this one, the randomization of this, it mixed up the physical and virtual address. Now, the allocation doesn't depend on each other. So when I launch it and when I send it, so when the kernel address that I linked doesn't help me, to do the dirty page attack. So, to my surprise, physical KSLR is stronger than virtual ones. In virtual, it's just you link one address, but in physical, you have a whole bunch of structures of the kernels, and in randomized space, so without the leaking, you can't find them. So, dirty page table doesn't fit here. So what to do? Maybe to do this like allocator arrangement, something so, and I thought it's going to be just as difficult as with Korean, so it doesn't work for me. I want something simple. It was quite a painful stage of my research, I started looking up dozens of articles, what kernel objects I can put instead of the one that was freed in a kernel exploitation dashboard that Eduardo Vela does in kernel CTF team. And as a result, I found pipe buffer, and kernel researchers of Linux, they know it's a great object. It's pretty elastic. It can be a different size, and I can easily, with this special system call, can say what the size of the kernel will be. This object is created when in the system, Linux system, you do a pipe. You create a pipe and you say, I want the pipe to be like 2 pages, 4 kilobytes each, and then you have it's 80 bytes. I can create a pipe buffer that is similar to my vulnerable object. And I thought it would be great to make this dirty pipe attack that Max Kellerman came up with to overwrite flags, to change privileges. That'd be great. So it looks like this. There's a pipe buffer that is written instead of the freed structure, and the data that's controlled by the attacker, they override the flags. That would be ideal. And of course, I went to the drill to train it. So I made a prototype of exploit. It's in the repository, and it makes use of the free entry in pipe buffer. And it's a great prototype of exploiter because it does 4 bytes without any leaks of information. It gets the privileges, and you can write in files anything, even those that are read-only, ATC shadow, for example. So training in the test venue, I went to my exploit, and this horrible limitation hit me. As it turned out, in pipe buffer, they have this offset. And this offset in the memory that our pipe will be taking information from. And sadly, it's not 0 there. That's why my kernel gets frozen when I launch the exploit. So I started studying the code, and I realized I can do this splice. The system call, this is zero copy, that allows us to copy data in Linux without copying the user space. It's important in terms of performance. So if I use splice to pipe, then I will be very close to this. But then it turns out this before a counter we have 0. That it overrode it, and it broke the whole thing for me. When I work with pipe, this broken pointer, it's all apart, it breaks my kernel. It was bad, so close, and it turned out to be so far from it. I started thinking maybe I can affect the value there, this number of bytes, but I couldn't do this either, because as soon as you send data through the virtual socket, use of the free bug stops shooting. I made a prototype that actually pumped 4 gigabytes through virtual to do UFFs, and so nothing happened because my vulnerability is not working then. So it was quite emotionally strenuous moment. But then I had this idea. So I do cross-cache. Why? I bind myself to the size of 96 bytes, so I can do it to any objects of any size. So why to turn into a small object? What if I create an object of 4 pipe buffers, 192 bytes? So I have 4 pipe buffers, and my vulnerable structure can show up in the first hop or in the second hop. If in the first hop, so that everything is bad, like in the previous case, because the kernel shuts down. But I can spend the first pipe buffer, I can call splice for it, So the splice would be red, and then this field that was corrupted with the pointer to the function, there will be 0 there. And I can write 0 there, and everything will be great. So that's why I can bypass this limitation. But what's going to happen if my user after free? The entry after freeing is going to be in the second part. So here it's great, because the flags in the pipe, they're 0. And if I work with a file, and there is no any freeze of the kernel, so I managed to bypass it. That's great. So what happens with the override? So 0 from the F4 account gets to the field that is not used, private field. That's great. Nothing broken. Then here buffer lock, then control gets to the struct page pointer. It was at that point it was a victory. Because the struct page, if I control it, I can in my kernel exploit, I can reflect any kernel memory. So my pipe works with some memory, with some buffer, and I can control with what buffer in the kernel I will be working with pipe through user space. That was great. At this point, I managed with my user after free, my second one, to rewrite struct page in this pipe buffer. So that was arbitrary writing of the whole kernel memory. So now what to read and what to write in order to escalate my privileges. So in the pipe is working through a map, the special area in Linux where all the virtual memory of the kernel is reflected. But in order to escalate the vulnerabilities to rewrite the kernel of it, so I need to know where it is in this VM map. The kernel SLR doesn't allow me to do that because this area of VM map is under the unknown address. What can I do? I can try with my pipe hit with struct cred that I found in the previous stage, and I can calculate the offset of, and I can do it pretty easily. There's a formula for that. So I just need to do it like this. So if you can see, I just said 60, and I get the address using the formula on the screen. So this is where I need to be reflected in order to write my credentials. But sadly, this ugly KSLR, 2 random bits, put in 2 junior bytes that I'm writing into this 2 random bits that I don't know. And I thought, okay, fine, 5 attempts. I need to process 2 random bits. I need to do the brute force of 4 variants, and I can do that. Maybe I have the smallest brute force for the whole history when I'm just working with 2 random bits. And then it looks pretty beautiful. If with my pipe I didn't get right with the physical address, then work with the pipe, brings bad address back, and if I get it right, then I can see user ID 1000, and I can write there 0, and it's going to be great. So now demo. So Ubuntu server 2404 with the latest kernel. Here I show that this is the freshest kernel. In the options, if there is no KSLR, I can try to read C shadows. I can do that. Now I launch the exploit. 5 times for 8 seconds. I triggered this vulnerability, and you can see that here I am working with physical addresses one after another in a map, and then I read user ID 1001, and now I'm root, and I can read ADC shadows.
Заключение, коллеги.
To conclude, the collision bug is simultaneously a discovery and a pain.
Alexander Stepanovich
Popov, the inventor of the radio, knows what it is about, because he had such a bug collision. He discovered the radio simultaneously with Marconi, but in my opinion, he was the first, 130 years ago, and that's great. As for myself, since I came second after the Korean researchers, It was emotionally hard. However, I am happy that I have managed to complete this work. I learned a lot, and I also completed and pumped up my open source project, which I use heavily to work with my students. So feel free to join the club as a contributor. Thank you for your attention.
У нас истекло время, но не знаю, возможно,
We've run out of our time, but possibly the organizers will allow me to take a couple of questions. Otherwise, you can always approach me offline at this venue. And tomorrow, don't hesitate to join us at our panel discussion devoted to Russian open source. It will kick off at 11 a.m. tomorrow morning. Thank you.
Hello. So my name is Ibrahim Higazi, and I'm the CTO for a company that is called Dark Entry. I'm not sure if presenting in, I would love to present in Russian, of course, but the only thing I know in Russian is как житуха братуха, so I'm not going to speak in Russian. It will only be English presentation today, and I hope you will like it. So today we're going to speak about the dark web monitoring. So it's a buzzy word that we have heard a lot, right? Like AI, everywhere AI, right? Similarly, also the dark web monitoring. So what is the dark web monitoring? What happens on the dark web? How do we at Dark Entry as a company also monitor the dark web? What do we see when we monitor the dark web as well? So this is the agenda for today. We're going to explain the difference between the dark, deep, and surface web, and what you can find on each level of these web internet as well. How do the hackers have hacked like Uber, Cisco, 1Password, the most known companies, Fortune 500. We will also speak about the Russian market, one of the most famous markets where hackers are selling data of compromised computers for employees of companies as well. And how can we validate if your computer is also hacked or not? We are going to give some resources here today. Okay. So first things first, what is the dark web and what is the deep web and what's the surface web? In a traditional way, if you are using your own browser, you are navigating to google.com. This is the surface web, a normal browser, a normal internet website that is accessible for everyone. This is what we call the surface web. But then there is also the deep web. A deep web is a bit darker side of the internet. Still, you're using your traditional browser, like Firefox, like Google Chrome, for instance. But to access that website, you need a little bit more access. For example, one of the most known hacking forums was called Darkwood. Darkwood was raided by the FBI back in time, 2012. And back in time, if you want to be part of that forum, you have to first receive an invitation from someone who is inside the forum, like a black hat hacker first. Once you receive the invitation, still you don't see anything. You have to first write a post about yourself. What do you do? For example, I'm a black hat hacker. I can cash out money from PayPal, for instance. Or I do create malwares. I do make the malwares FUD, fully undetectable for malwares, for example. Then another 3 members from the forum would have to vouch for you. Says like, yeah, this is a legitimate black hat hacker. We have done some deals with him. You should allow him into the forum. So still, although this website is accessible from the internet, it's called darkwood.com. It's accessible from your traditional browser like Firefox or Google Chrome. You cannot see any content. So accessible normally, but you cannot see the contents of that website. This is what we call the deep web. But then there is another side of the internet that's called the dark web. So a dark web is mainly .onion websites. So when we say a traditional website, it's .com, .net, .ru, .nl, for instance. But the dark web websites are usually .onion, ends in .onion. In .onion means that your traditional browser, like Firefox or Google Chrome, would not understand what that is. So you cannot open a website that ends with .onion from a normal browser. This is why you need a special browser that's called the Tor browser. So the Tor browser would allow you to visit these websites. The Tor works in a way different way, not just like you're visiting a server, your request goes to the backend server. No, in Tor browsing, it's a different case where exit nodes and multiple things, that's very hard to track. So in a normal way, if a threat actor is having a website on the internet, you can try to identify the IP address of that web server on the internet. That's very easy, even with internet machines and non-passive DNS records like VirusTotal. And then you can track the hackers. On the dark web, the way is totally different. Okay, so how was Uber hacked? It was not only Uber, it was multiple companies, but Uber was the largest example because of the damage that happened to Uber back in time. So, usually when you are using Google Chrome, you open Google Chrome, you log into your Gmail account, Google Chrome will start to store or to save a copy of your passwords on the Gmail account. So if I click save to my passwords in Firefox, it will save the password only on my laptop. But in Google Chrome, if you are logged into your Gmail account, it will also save a copy of your passwords on your Gmail account as well. It's a feature that is called password sync. This is a feature by Google Chrome that's called password sync. So as you can think, an employee for Uber from his corporate laptop, he opened Google Chrome, he logs into his personal Gmail account, all his corporate passwords, all his Uber passwords are copied to his Gmail account. Later on, that employee from his home laptop, he downloaded a cracked game. So a game with a crack, basically. And because, of course, if something comes for free, then you are the product. He downloaded a cracked game for free. It had a malware. So his laptop at home was hacked. So where does the connection happen here is because at home, he is logged into the same Gmail account. So the hackers here were able to steal Uber passwords from the home laptop of that employee, because all his Uber passwords were copied to his Gmail account because of a security feature by Google that is called password sync. So now, the hacker is having a zip file or a RAR file that contains all the data stolen from that device. We're going to see it in a few minutes. And that zip file or RAR file do have the passwords of the Uber employee. What would he do with this? In simple words, the hacker didn't know himself that he hacked the Uber employee. He just put his cracked software everywhere on the internet and then spray and pray, waiting for people to get infected. So after that, he extracts the passwords, he put it in a zip file, and then he sells that file. I will go back to this slide, but this is where the hacker was selling access to the Uber employee passwords. This is a website that's called Russian Market. It's very famous for people working in the dark web. This website, what it does here, so what you see here is the malware itself. That's called Luma C2, or Luma overall. This is one of the most famous information stealers. It's called Luma. And then the country here that is hacked or compromised for that laptop is Egypt in that case. And then here would be the websites where you can find basically the links to and the passwords of that compromised device. Uber have uber.com, but for the corporate, they have uberinternal.com. So what the hacker did is, hacker visited Russian Market, he go to the search bar here, he writes Uber internal, and then he got some machines that is compromised. This file here, this is the zip file we are talking about. They call it log file. If you click here, you see a list of files that is stolen. We will see now the files. And then this file was sold only for $10, like only $10. So the hacker, which was only 18 years old, he goes to Russian Market, he searched for Uber internal, he found a compromised employee device for Uber. He bought the zip file for $10, he downloaded it, he found credentials to Uber network VPN. So he have a VPN access to Uber network just for $10. This is still also part of the deep web, right? Because this website is accessible, yes, on the internet, but you cannot see the content unless you pay them $50 to be able to access the website. So again, going back, the same scenario here when we talk about like finding things on the dark web, what we can see. This is a website for the very famous Russian group that's called Lockbit3. Lockbit3 is also became famous in Egypt as well because they hacked the largest payment gateway in Egypt. It's called Fawari. So that's why they also became famous in Egypt as well. At that time, when we took the screenshot, they were claiming to have hacked Etisalat. Etisalat is the largest mobile operator in United Arab Emirates, in Dubai, UAE. But then it turns out it was not really critical data, so that it was not paid. But what you see here is one of the, for example, ransomware groups. They hack companies. They offer the data for sale on the dark web or on their dark web website. And then if you want to get the sensitive data or even access to that website, you have to pay us this amount. Also to the clients or to the companies, you have to pay them not to publish your data. And that takes us to a different perspective. How do the ransomware groups operate? In a traditional way, if I tell you ransomware, the first thing that comes to your mind is he encrypts the files, he asks the company to pay money so that he can decrypt it, right? But that's called a single extortion technique. However, for Lockbit3, they use a technique called double extortion. So they encrypt your files, they also steal a copy of your sensitive data. So now they ask you to pay 2 times. 1 time to decrypt your files, 2nd time not to publish your sensitive data. And there is also a triple extortion technique for which, in addition, they put you under a DDoS attack. So you pay to decrypt your files, you pay not to publish your sensitive data, you pay to stop the DDoS. But for Lockbit3, they had a double extortion, and this is one example of what you can basically find on the dark web. Going back to the Russian market, when that teenager or the hacker, when he downloaded the zip file, by the way, this website again is accessible from the internet, so anyone can buy a subscription, go search for any company, see their passwords as well. So what was the content of that zip file? When we decompress that file, we see a lot of files. Let's look at it one by one. The first one here is called user information.txt. This file would contain all the data of that computer, like the IP address of the computer, where the malware is, the location, where, Windows operating system, it's in enterprise Windows or like home Windows, the domain controller name, the local computer name, and so on. And then there is a screenshot. This screenshot is taken by the malware itself. So when you double click the cracked game or cracked software, the malware will take a screenshot from your laptop so that the hacker knows what was the main way he infected all these machines. But for us as dark entry, we collect this as evidence of how this employee was compromised, how he was hacked. The root cause analysis, basically, how he was hacked. And then we see a process list, which includes all the processes running on that computer. And then the most important one, passwords.txt. That includes when we say passwords.txt, I'll come back again to this one. Well, actually, let's look at it one by one, basically. These are the files. Let's take it again file by file. User information, this is how it looks like. In user information, you can see here that it contains the malware location, which is the most important part, like this one here. It's called the file location. This is where the malware is on the machine itself. And at Dark Entry, this is also how we help companies identify where the malware is on the device without having to investigate the machine. No forensics required, no incident response in a detection way, I would say. And then the rest of the information about the device, like the hardware ID. This file would help the companies answer a very good question. You tell me that one of my employees is hacked. This is his laptop at home, or this is his laptop at the company. Now, using this file, we can answer this question. You can look at the public IP address. You can look, for example, here that he is only using Windows Defender. So this is a home laptop. In companies, they would not only be using Windows Defender, right? They could be using EDR or whatever the other solutions in place. But also you can see the other aspects like the keyboard, here he was not joined to a domain, the username is called Dell, so traditional naming of laptops as well. And then this is the screenshot. This is again a screenshot that is taken by the virus itself, the malware itself. So we can see that the employee have visited a website called saloaudio.com. He downloaded a file called file.7z. What is this file? This file is basically Camtasia screen recorder. It's a software that you can use to record your computer by video or take a screenshot. But in the free version, they add a watermark. How would you go about it? Will you buy the license? Of course not. You will find it cracked, right? I'm just making a joke. Anyway, but yeah, once it is cracked, again, that means you are the product. Because if it comes for free, yeah. So again, he decompressed the file, he executed, he was infected. This is the most important file that I was talking about, passwords.txt. How is the data stolen? It is in the format of URL, username, password, and the application it was stolen from. Now a good question is, what is the source of these passwords? In my computer, I use Firefox. But in Firefox, the passwords are stored encrypted, right? You have a password to decrypt it. So how did the hacker steal it in plain text from my browser? Google Chrome, Firefox, whatever it takes. That's one. Second thing is the key logging. Basically, in key logging, he would be storing all the usernames and passwords you write in HTML form. That's second. And the third part, which is the most important one, is the passwords that was copied to your Gmail account. Remember when I talked about Uber that the passwords of the employees copied to his Gmail? That's the same thing here. How do we know this? Look at this one here. This is an Android application of Facebook, username and password. If we say this data was stolen from Google Chrome, how come this is Android application, right? Think about it. That employee was using Android phone. On Android phone, you are required to log in using a Gmail. And that employee logged into the same Android using the same Gmail. So same Gmail on Android, same Gmail on Uber laptop, same Gmail on home laptop. So if the hacker compromised his home laptop, he was able to steal the passwords from his phone, his corporate laptop, and his home laptop as well. And this is why you are able to see some Android application credentials in here. And when it comes to the question of how he was able to steal these, although it was encrypted, that's very easy. This is a malware running on the machine. He will wait for you to authenticate. The password will then be stored in memory, and because he is having access to the memory, he will copy the password and be able to decrypt it as well. Works. Cool. Now the most important question. In many cases, when we do a proof of concept or a demo to companies, what they say is like, okay, passwords is stolen. We have two-factor authentication. But here, in this case, it's useless. Two-factor authentication is super useless. Why? Because this is not just a username and password stolen. It is a compromised laptop. So let me ask you a question. When you open Facebook, Do you see the home page, or does Facebook every time ask you for a two-factor authentication? Usually, I will only see the home page, right? I authenticate one time, then I can see the content of the Facebook. But then how did Facebook know that it's me, Ibrahim, who have authenticated before, who have provided also his two-factor authentication before? That's using the session or the cookies that we see here. It's random values, so we can see HSBC Bank, for example, here, and then the cookies of HSBC. What does that mean? That means if me as a hacker, I copy this, I add it to my browser, I go to hsbc.com.eg, I am logged in already on behalf of that compromised user. So this is why we say two-factor authentication in this case is useless, because the hacker will steal the session and the cookies, use it in his own browser, visit any website he want to log in, basically. No credentials required, no two-factor authentication required. Okay, the good question that we ask all the time is, if you have access to 1 million computer, like you have a malware, you manage to infect, let's not say 1 million, 100,000 computers, what you will be looking for? What is it as a hacker you would be willing to collect or to do with these 100,000 computers? In the most cases, we saw people going, of course, behind money. So money means credit cards, PayPal accounts, bank accounts, whatever they can use to make money out of it. But what if that computer does not have a credit card or even a bank account? Then the next thing is the social media accounts. So in a social media account, he is adding this social media account, Facebook, Instagram, whatever it takes, as part of a larger botnet. So one hacker controls 100,000 Facebook accounts, because he hacked their computers, right? So if you have a Facebook page, I can make 100,000 likes on your Facebook page. If you if you want to change the trend in Moscow or the trend in Egypt or the trend in Netherlands, I have 100,000 Facebook account that can post about only one topic, and they can comment about the same topic positively or negatively, right? And this is, by the way, how the US election was hacked. It was not actual hack. It was tens of thousands of Facebook accounts posting about certain topic, voting for Trump, saying some positive things about Trump, negative things about the other woman. I don't recall her name anyway. So yeah, but this is how you can change also the mindset of the public people, right? Because if I am here, I see food and I see 10 people saying this is delicious food, I do not have to confirm. If 10 people say this is delicious food, it is delicious food, right? Even if I try it, it's not delicious, I will think it's a mistake in me that I don't like it, but the other people like it, it's 10 people, so it's delicious, right? That's the same thing. This is why they also go behind social media accounts. Cookies, we explained about this already. Targeted access is similar to what happened with Uber. So I collect passwords for companies like Uber Internal, like United Airlines, like any company, like Google, any company, and then I sell this. Like, hey, do you want to hack Uber? I will tell you the username and password to a VPN employee on Uber, for example. And then, of course, the personal identifiable information, or PII. This is a data that they collect to sell to marketing companies, so that marketing companies knows what to sell to whom and those kind of things. Okay. This is the part of the security of if I'm looking to secure myself from similar attacks, what do I need to do and how would I do it? In most cases, and by the way, in dark entry we have access to 25 billion record. Not 25 billion person, but record. So one person could have 1,000 username and password on many websites, right? So 25 billion records. The root cause we identified was leaked because of this, was cracked software. So if we are looking to secure ourselves, number one is like, do you use cracked software? You use a cracked game, right? Yeah, I think at some point you always had to use a cracked game / software for any reason. So, of course, saying not to use a cracked software is a very cliche. And then, of course, the phishing websites. And nowadays, what the hackers are doing on Facebook is that they would compromise the very famous website, web page on Facebook, any page, but it had the verified logo. And once they had a verified logo, they changed the Facebook name to something like Google AI. And then they ask you to download a file that will give you or grant you a free access to the beta version of Google AI. Now, because I see this is a verified page and I see 100,000 likes on that post, I will blindly download the file and execute it on my machine. But again, that's a malware. So you have to always validate what you are looking at. You have to also validate what you are logging in. One very good domain that we saw used in phishing on Facebook, you see facebook.com, but that website was called face and then BTOOK, Facebook. But because the URL is long, people will never be able to identify it. Again, have a closer look at the domain name as well as a good option. Never use a cracked software. We talked about this one. Yeah, if it's too good, it's not true. A scam that happens all of the times, that messages on Telegram or on Facebook, they tell you like, hey, if you download this software, you're gonna have, I don't know, $300 as a survey or something. Again, if it's too good, it's not true. Now the question is, how can I make sure if my computer was hacked before or not? If I'm asking, how do I know if my email was leaked before or not? There is a website very famous called Have I Been Boned, right? But if you type your email in the website that is called Have I Been Boned, it will only search, it will mainly search in third parties. Like, I registered in LinkedIn, LinkedIn was hacked, my passwords were stolen from LinkedIn. But it's not my computer who was hacked, right? And that's why, I will come back to this slide again. And that's why we thought about it differently in dark entry. I will explain it in the next slide. But now when we talk to people about like compromised devices, dark web monitoring, those kind of things, people will always say, okay, I have the best security team in my company. We have all the security solutions, firewall and everything. What can you do more than what they are already doing? And are you replacing them or not? The answer will always be no. We do not replace companies. We actually complete what they are doing. Because human is always the weakest part of the chain. You could have the best security team, you could have all the security solutions in place, still a not aware employee will download attachment. He will get an error message or a warning message that says, this is a file downloaded from the internet. Are you sure you want to execute it? Yes. So no matter what is the security you have in place, think about Uber. Uber, they have the best security team. They have security operations team monitoring 24/7. They have all the security solutions and controls and GRC and whatever it takes in place. Still, they were compromised because a home laptop of employee was hacked. So for the corporate assets, they have full visibility, but for the home laptop, they had zero visibility. That's what we do at Dark Entry in order to cover this part. Now, this is we open it for free. So if you go to www.darkentry.net, this is the website. You can type your company email or company domain name or even your personal email. Here, we are not going to tell you if your password was hacked or not. No. We're going to tell you if your computer was hacked or not. Is your company hacked or not? So if I work for Vodafone, for example, and then I type here in the search bar Vodafone.com and then click on search, that will tell me if Vodafone.com as a domain name had employees hacked and their data are being sold on the dark web or not. Now, if I search my email, Higazi@darkentry.net, and then I hit the search bar. Now it will tell me if that computer of Higazi@darkentry.net was hacked or not. Either it's his computer at home or his computer at work as well. Again, this is a free search, which means you can do it unlimited. You will not see the actual data. However, if you hit the request free demo, you can of course have access to that data if you are working for that company for sure. This is part of what the data contains: corporate domain names, corporate personal emails, searches across billions of records, 25 billion records, and then the compromised devices logs, not third parties. Again, compolists and ULBs, which is a type of data leaks that is about a text file that contains URL, username, and password. This is also searchable using the same website. These are my contact details. In case you have any questions, you are more than welcome to reach out. Thank you. Yes, you had a question, please? Maybe someone can give him the mic.
Good afternoon. At the beginning, you mentioned how Uber system was broken because one employee used the same Google account on his work laptop and the home laptop.
Yeah.
Would you say that the whole practice of using synchronizing your home laptop and work laptop is, in general, is bad? And would you like have some precaution measures about it? What's your opinion on it?
Yeah. So the question says if Uber employee was hacked because he had to sync his passwords from the corporate laptop to the home laptop, the sync feature, is it something bad? Unfortunately, yes. So if I'm syncing my passwords from my home laptop to the corporate laptop, it is fine. Why? Because corporate laptops would have all the security controls in place, EDR, data loss prevention, security team monitoring, but copying my corporate data to my personal laptop, no, that's very bad. Yeah. Yes, please. Yeah, that's a very good question. So the question here says, why don't we recommend to use a one-time credit card payment, right? I used to manage the cybersecurity team at Visa, the Visa payment company, for 3 years. The team that I was responsible for was the tokenization team. It's actually what you're talking, the same exact thing that you're talking about. But here, security is not a bulletproof. It's not one single thing you can do. If I give here the recommendations, for example, to use a strong password or something, that's like we are trying to make it harder for the threat actors. Yes, what you said was a good option, but only to secure the credit cards, right? But what about the other things like credentials, access to PayPal, for example, access to bank account? It's a different story. Yeah, but thanks for the suggestion. Yeah. Please.
So in the beginning of your presentation, you defined a deep web website as a website that requires like additional barrier to look at the information. So you can access the website but can't see the information on it. How is it different from any website that requires registration or maybe like a news article that's paid for?
Yeah.
They consider deep web too, or?
They consider it, sorry?
Are they considered deep web? Also, because they also require registration or payment.
I understand. Yeah. So in a normal way, you could have some websites on the internet that is accessible if you pay something, right? But then in a normal website, not a deep web website, you would be paying using your credit card, your PayPal account, right? However, on the Russian market, the only way to pay is through cryptocurrency. So it's USDT, Bitcoin. This is to make sure they are anonymized as well. So this is also part of why not everyone would have cryptocurrency to pay, right? It's a different story. That's why it's still, yes, accessible from the internet, but not everyone can access it. Yeah. Please.
Hello, Bragim. Thank you for your research. So I'm wondering, I've checked quickly your website and I've seen that you're constantly getting like 24/7 updates from the leakage feeds and so on and so forth.
Yeah.
As far as I know, URLs in the dark web are changing constantly, and well, from time to time, new domain appears, others disappear, and so on and so forth.
Yeah.
Are you using some sort of an automated tooling to update the URLs which you're searching through to get the data, or is it done manually?
Yeah, that's a very good question. So the question says that some of these websites on the dark web will change a lot, right? Like even Logbit3, they had so many mirrors website because the FBI or any other agencies will take it down from time to time, right? So one, dark web is not only referring to websites. It could also be a closed Telegram group somewhere. Sorry. When we say dark web, deep web, surface web, we mean so many things. But with regards to only your question, this is part of the data we collect. We took 9 months to write our engine. Why 9 months? To collect it automated? Because it's not only about websites goes down. It could be also incredible threat actors. What if it's a website for hackers that they publish garbage data, right? So we also need to score these hackers. That's second. Third is what if they use CAPTCHA. Like Russian market, they use CAPTCHA. Still, we managed to bypass it to be able to automate the process. That's one thing. But also, what about if they use Cloudflare, Imperva, and so on? That's like why it took us 9 months to be able to automate the process. So yes, the process has to always be automated. Otherwise, you are way prone. You cannot do it manually, no. Hope that answers your questions.
I've just heard that you said that dark web domains are also using Cloudflare. Is it so? Is it possible?
It is, yes.
Through a proxy or in what way?
Now, again, like when I say dark web, I mentioned multiple sources, right? It's not only the forums, and when I say dark web as a technology, it refers to everything that we monitor. That includes the dark web, the surface web, and the deep web as well. So the dark web as a .onion website, you cannot use Cloudflare for sure.
Okay, thank you.
And by the way, on the dark web, that's onion websites, you do not need to hide because it already goes through like the exit nodes of the Tor network, so you don't have to hide it. Yeah, sorry.
First of all, thank you very much. My question is about the future of the dark web. After Pavel Durov's arrest in France, we observed some discussions among the cyber criminals about the future. Will they stay in Telegram closed channels, or will they use restricted websites or some other platforms? What's your opinion about the future?
Yeah, it's like because this question is a very good question. I hear it a lot. What if the dark web goes down? It feels like you're asking me, what if hackers stops to create malware? Will that ever happen? No. Every day you see new malwares, right? That's the same thing. If a website goes down, think about Silk Road, for instance. It was the most famous one, like on the dark web, Silk Road. They were doing drug dealing, they were doing like selling weapons and so on. Still, although it goes down, like 10 other websites goes up. So it will never finish, I would say. Well, hackers will do what hackers will do.
Okay, thank you very much.
You're welcome. We have room for one more question.
Yeah, I'm right here, to the left.
To the left side.
Yes.
Sorry.
Hello, Bragim. Thank
the
you.
lights here, okay.
Yeah, I'm a little bit shiny right now. So, first of all, thanks for the interesting report. I hope the Moscow treating you well. But my question is, you showed some vendor that is showing what is leaking like the country. But I know that there is like 2 companies, SourceGraph.io and Hudson Rock, but it only shows if you write them from the domain email. Is there any vendors that can sell the full ULP by searching the domain? I know only 2, it's Akula and SSRF, I think. Are there any other vendors? My question is, thank you.
So when you are talking about like downloading, you mean for free or paid?
Either way.
Yeah, paid, of course, everyone does it, including dark entry. But for free, no.
No, I'm talking about commercially selling for security.
Yeah, exactly. Commercially speaking, if you are the owner of that domain, every company will allow you to see all the records for that domain. Yeah, and download it, of course, yes.
Oh yeah, but I'm talking from the point of not the owner of the domain, but penetration tester who wants to buy the stealer logs of said company for an actual
no, I get the question.
Yeah.
Yes. So the question is, if I'm a penetration tester and I'm doing a pen testing for any company, let's say Vodafone. Now I want to search for the data leaks for Vodafone and be able to download it to use it in my pen testing, right? So there is not one single answer for this question because we have thought about this scenario a lot. Why would I give you to the data of Vodafone if you are not able to verify that you are doing that for them? So for that, to do it at dark entry, for example, we ask you to give us authorization from the client. So if Vodafone, for example, gives you authorization to view their data because of a pen test, then we will hand you the data. But some other companies, they will give you the data no matter what. They don't care if you are the owner of the domain or not, if you are doing a pen test or not. They will do it like Socradar, for example. Yeah. Which again, like we are a Dutch company, we are based in Amsterdam. If we do this, this is illegal. They close our company next day. We cannot do like what Socradar is doing. This is illegal, I'm telling you.
Thank you very much.
Oh, cool. Okay, more questions? Thank you so much.
Thanks for joining in. So today I will be speaking about Firebase misconfigurations. Who am I? My name is Bhavuk Jain.
Итак, меня зовут Бхавук Джан. Я представляю компанию StackTrace. И я в прошлом работал с Yahoo и целым рядом других проектов. Это программа моего выступления, то, о чем мы будем говорить. Поговорим о том, что такое Firebase, что отличает сервисы
and Firebase backend communication takes place, and then we will explore the exploits around it. So what is Firebase? So Firebase is an app development platform provided by Google. It helps developers to build iOS, Android, and web applications quickly, and it provides web-based, cloud-based tools that eliminate the need for a back-end infrastructure. It is also used by multiple Fortune 100 companies as well as many startups. So what are the key benefits? First is it has a fast integration. So Firebase provides easy to set up SDKs for web and mobile, including both Android and iOS. Second is a scalable backend. So it handles everything from authentication to real-time databases. Third, it's reliable because it is backed by Google's infrastructure. And fourth, not the least, versatile. It supports rapid prototyping. If you're building an MVP, people do like it because it's rapid. And it also helps in full-scale production apps as well. Now we will be discussing what are the different services offered by Firebase. The first one is real-time database and faster. So Firebase has their own cloud-based NoSQL database, and it syncs on real-time. Second is authentication. So it provides functionality to log in with email, phone number, social logins, log in as anonymous. Third is cloud storage. So if you want to store documents, images, or videos on the cloud, you can use the cloud storage functionality. Next is multi-tenancy support. So if there is if an application wants to have multiple tenants, and they want to isolate the data, they can use multi-tenancy functionality in the Firebase applications. Next is the cloud functions. These are the serverless backend logic, and they're triggered by Firebase events. Next is the analytics and crashlytics. So it's really important for mobile applications to understand when the crashes are happening and what are the root causes. So they can leverage analytics and crashlytics for it. And last but not the least is the hosting. It's used for hosting fast, secure web and static content. So these are not the only services provided by Firebase. These are a few things that I found vulnerabilities on. So I will be discussing only on those parts. But there are certain new tools as well, like they are doing on AI as well, but we will not be discussing that. So iOS and Firebase communication. So in this talk, I am discussing about iOS, but it works similarly in Android and web applications as well. So here we will try to understand how an iOS app communicates with the Firebase backend. So typically, if we want to understand if an iOS application is actually using Firebase, we take out the IPA, and in it, there is a file called as Google service-info.plist. It's embedded inside the application itself. So this is a property list file which contains critical key value pairs, and they are necessary to make communication with the Firebase backend services. Also, Firebase provides their own SDKs, both on Android, iOS, and web, that you can integrate within the iOS app, and utilize this Google service-info.plist file and communicate with the Firebase backend. So this is how Google service-info.plist file looks like. There are multiple information key value pairs. So the ones we are mostly interested in are the API key, API_key. So it is used to authenticate requests to Firebase services. Second is the project ID. So this is a unique identifier for the Firebase project associated with the app. Third is the storage bucket. So this points to the cloud storage bucket where we can store our documents, images, or videos. The last thing is the database URL. This specifies the endpoint accessing real-time databases, or which we call the Firestore backend. Now, let's see some of the exploits. So these exploits are the misconfigurations done by the developers while they are integrating this SDK. There are no issues in the Firebase itself that I'm discussing, except one, which we'll be talking about later on. First, exploit number 1. Unintended user sign-up to the application via alternate path. So generally, in web and mobile applications, they generally have their own APIs that they use to sign up a user or log in a user. There can be various of reasons. For example, they have their own custom authentication like SAML or OAuth, and they want to integrate Firebase with it, so they have their own APIs. But if we look at this Firebase endpoint, which is the /view/account signup, and we provide the API key that we recovered from the plist file, we send it, and with any email and password, we get the ID token, which is the authentication token, which we can use to log into the account. Another interesting thing is if the application is not supporting email and password login, they are using phone number or a social login, we can leverage this API, and using email and password, we can actually create a new user. And this will give us an ID token, which is an authentication token for this particular email. Of course, it is not a validated email, but yeah, we can leverage it in the other exploits. So this is the starting point of all the exploits that I'm discussing today. So yeah, let's go further. So this is the vulnerable request. So you just need to update the API key, which we can get from the plist. And this is the request body. Exploit number 2, account takeover in multi-tenancy Firebase applications. So in the previous one, we discussed how any user can sign up to the application, right? Here, we can do the similar thing. So in the same API, Firebase also provides another parameter called a tenant ID. So generally, if the application is an enterprise application, they generally have multiple tenants. So if a user exists on tenant A, they have a different login, and on another tenant, they need to create another sign up for the same user to log in. So that's what we can exploit over here. So let's consider there are 2 tenants, tenant A and tenant B. And there is a victim testing at testing.com who is registered on tenant A. And as an attacker, now I want to take over the user account on tenant A. What we can do is we enter the tenant B ID over here in the tenant ID parameter, and we use the same email of the victim. The attacker uses their own password, and they will get an ID token again for the same user, but it's on tenant B. So it's safe, right? But what happens is the attacker can use the same ID token and send it to the affected vulnerable website and use it to take over the account on tenant B. So it turns into an account takeover. So this is the vulnerable request, similar to the previous one, but here you are also sending a tenant ID parameter in the request body. So why it happens? So the funny part is it's mentioned on the documentation provided by Google. So if you want to verify if a tenant belongs to tenant A and tenant B, you need to have this if statement. If this if statement is not there, you can actually bypass the authentication. And if you provide any tenant ID ID token, it will accept it and will log into the user. So yeah. Exploit number 3, access to accounts with pre-configured mobile numbers with fixed OTPs. So Firebase has provided a few functionalities for the developers to make their development easy. So they provide, so if the application is using login with phone number, they can use a pre-configured mobile number and with a custom OTP. So they can just enter that phone number, the hard-coded OTP, and they will get access to the application. So if you go to the Firebase console, you will find they are the test phone numbers that you can add. And you can actually use these numbers to take over the developer's account. So there can be issues with it. So sometimes the application stores credit card information that are used by the developers. So they can be leveraged. Another thing is there can be sensitive information in the web or mobile applications that can also be leveraged because it's a developer account. Exploit number 4, access to storage files on Firebase. So this is the particular endpoint, /vo/b/the storage bucket.aspot.com, and in the authorization we use Firebase and the ID token that we get it from the sign-up endpoint. And if it's not configured properly, we can dump the whole storage files on the server. It can be it can be photos, videos, private documents, everything. So this is a vulnerable request. Here you need to update the storage bucket again from the plist file. And in the authorization, you need to use the ID token that we got from the sign-up API. The interesting thing is, we have to use Firebase ID token, not the bearer tokens, because it doesn't work. It only works with Firebase tokens. Exploit number 5, full dump of collections and associated documents. So we discussed that Firebase provides cloud-based solution and it has a NoSQL database, right? So in a NoSQL database, we have collections, and inside collections, we have documents. So what we can do is we can call another Firestore API, and this is a particular endpoint, /v1/project/the database URL, database ID, /databases default, documents/users. Users is the collection ID. And if we pass, again, the same sign-up token that we receive from the sign-up API, we can dump the whole collection. It contains all the documents. It contains the email addresses. It can be anything. Generally, applications store like email address, phone numbers, push tokens, everything. So this is the vulnerable request. So you need to update the project ID over here and the collection name. Another thing, in the authorization header, it uses bearer tokens. It doesn't use Firebase tokens for some reason. So it has to be a bearer over here. Another issue in this request is it has missing rate limiting. So you can brute force the collection names, and like you can just run an intruder and try to get the actual collection name. Only if you know the collection name, then you can get the documents. So this is one of the issues with Firebase itself. Another thing is to identify collection names. You can check the web code or the binary of the iOS application if they are using any different collections, and you can get you can dump the whole collections based on it. Exploit number 6, insecure Firestore rules to unauthorized read and modification of data. So this particular functionality is associated with the previous one, and here we will discuss why it happens, why there's a misconfiguration, why we were able to dump data in this particular request, why we were able to. So we will discuss that. So to understand that, first we need to understand what are firestore rules. So there exists a file, firestore.rules, and it is a critical part of the Firebase security. So it defines who can access your Firebase database and how they can use that data. What it does is, first, it controls read and write access. So it determines which users can read data from or write to specific collections and documents. Second, it enforces conditions. So it uses expressions to define who can access a particular functionality based on user authentication. It should be admin or regular user. It also defines the roles. It also performs data validation. And the third thing is it protects data in real time. So whenever you call, so in this particular request, when we are calling this endpoint, the Firestore rules are invoked, and they are validated if the rules are valid or not. Only then it will return the response. So coming back, and why it matters. So first thing is, if there are misconfigured rules, example, allow read and write if true, that means anyone can access it and write to the database. It can expose entire database to the public. Second is, weak rules can lead to unauthorized data access and data modifications, which actually what we call as privilege escalation. So let's take an example of what a vulnerable rule looks like. So to give a context, so this is a service where users can store their mobile push tokens. And push token is a service, the messages, the notification that you see on your device when your device is in a locked state. The messages are sent to the push tokens, and the APNS delivers it to the device. So in this vulnerable rule, there are two things happening. First is the creation, which gives which creates a push token over here, and it checks if the user is authenticated, and it also validates if the request is by the authenticated user. So it checks the request body, which is the request.resource.data.user. This is from the request body, and this is the decoded ID token from where they have they get the authenticated user ID. They matches it, and the checks if the user authenticated, it creates. So that's fine, right? There are no issues with that. But what about the allow update functionality? It checks if the user is authenticated, which is the right thing to do. And then it checks if the resource.data.user. Resource is a document that already exists on the database. So it checks if that resource was created by the authenticated user that is requesting it. So this is also fine, but do you think there is an issue with it? Anyone? No? The fix is, the issue was, when the user has created their document using the create service, it's their own document. The document belongs to the attacker, right? But the update functionality also checks if the resource, the document that is already exists on the database belongs to the authenticated user, which is again true. But what they can do is they can rewrite their own document, and they can pass on the victim's user ID. And the fix was to add this line, this check, which is the request.resource.data.user, which again checks the request body if it's the same user who is updating it or not. So this would have fixed it. So yeah, that's pretty much I have for this talk. If there are any questions. No questions, I think. Yeah, you have.
You said that all these issues happened due to misconfiguration, yes? So I wonder, are there any tools on the side of, say, Firebase or Google or Apple that maybe check for some misconfiguration like you demonstrated?
The best thing is to read documentations properly when you're integrating a third-party library. For example, if you are using integrating Firebase, you read the documentation, how validation works. If you're using any other third-party such as sign in with Apple or log in with Google, you just need to check the documentation, how it works, because every documentation have a security document which mentions what issues can happen if you don't check these things. So it's really important to follow the documentation while integrating these third-party libraries.
Yeah, but maybe some automatic tools to check these rules.
I'm not aware of those tools, but if those are still present, there can be, you cannot depend on those external tools. You need to validate and check the documentation for a foolproof.
Yes, of course, but I think that these tools will be available, and if you are an expert in this, you maybe can develop something like this.
So the thing is, you can automate this stuff. You need to put checks, or you can do a static code analysis of the source code and see if these checks are available, present or not. If these are not, like that, cases will fail. But in the first place, you need to know these vulnerabilities exist. If you know these vulnerabilities exist, tools can be developed.
Okay, thank you.
Welcome.
Hello. Thank you for your presentation. Actually, previous question was about, is there a tool to automatically check make all checks for Firebase? Okay. So I actually made this one. I have on GitHub, it's called Firebase Tester.
Okay.
So currently I check for anonymous and authorization checks. So automatic sign up, and then with the session try to access database, write to database, and so on. But you mentioned collections. There is API where we can brute force collections, right?
Yeah.
Is there a REST API to write to collections?
Sorry?
So we can read brute force collections?
Yes, we can.
Like users, right?
Yes.
Can we write?
I'm not sure, because it's a GET request that I was trying to do, but that particular endpoint is vulnerable. If it supports post request, then it will be vulnerable, yeah.
Mm-hmm. Yeah, but I actually tried also to research, but currently there was only JavaScript code, which allows to write, but it's only a solution for now. So I thought, is there a REST API as well? Okay, thank you. And one more question. One API you mentioned for storage bucket.
Yeah.
It requires authorization Firebase, especially, not Bearer. But actually I had a case where Bearer also worked.
Yeah, so there's a funny part. So sometimes it works, sometimes it does not. So it's a very random behavior across Firebase, different applications. I believe the legacy application supports Bearer, but the newer ones uses Firebase.
Oh, okay. Yeah, that's very good one. I actually will add the additional check to my tool for this case. Yeah, thank you. That's a very good finding.
Thank you. Thank you so much.